Oli, Oli, wala kang sound. Oli.
Into scenes of chaos.
Dalawang suicide bomber sa hulong.
Ayusin mo. Huwag ganyan. Oli. Oli. Test tayo, Oli.
What? Nandito na yung ano, hindi nila mapagana yung sounds eh.
Hindi ganun kaganda yung mic mo.
Ha?
Hindi ganun kaganda yung mic mo. Hello.
Pumunta na dito yung nag-audio kaso umalis ulit eh.
Okay, okay. Sige.
Oh. Pero mayroon akong sounds kanina, yung nagpe-play.
Meron naman.
Oh, yun
Pero
na, hindi
parang
namin marinig.
masyadong malakas lang.
Oh, sige, pahinaan ko na lang, sir.
Hindi ganun kaganda. Hello, Oli.
Lumalabas na yung
Pero merong tunog. Hello, Oli. Magparamdam ka, Oli.
May ako.
Ha?
Yung sarili niya dito sa ating ka.
Wala.
Wala, di ba? Dapat nakamagitaw lang.
Hello, Oli.
Sagot lang siya.
Oo. Oli.
3, 2, 1.
Oli.
Sound check. Napalo eh. Sound check. Check yung ramdam tao. Narinig mo ako. Hello? Mic?
Malakas daw sir yung playback masyado. Yan sir.
Mute mo na, sir, nung playback.
Pamute daw yung playback mo sir. Baka itong malakas.
Sure ha? Yan po ulit.
Sige, sir. Salita ka, sir.
Good morning, we are back.
Yan. Sound checks. Check sound.
First, excited na. Ayan, okay.
May playback, hindi ko ano.
Okay. Ayan yun pala. Hello sir, yan. May playback pa.
Yan. Sige. Salita ka, sir.
Ayan. Check sound A. 1, 2, 3. Malinaw yung boses, sir. Sound check. A. 1, 2.
Okay na.
Check sound.
Okay na, compare
Okay na.
kanina.
Okay, sir. Sige.
Okay, sir.
Namin to. Thank you.
Thank you. Hi, Sir Joel. Morning.
Welcome. Before we begin our meeting, please be informed of the following video conferencing etiquette. Number 1. If using a laptop, tablet, or mobile phone, make sure that your battery is fully charged to avoid sudden disconnection. Number 2. To be the best, you have to look the best by observing and wearing appropriate attire fit for the meeting. Number 3. Be on mute at all times and listen attentively to whoever is speaking. Number 4. Maximize the use of chat box and other tools made available by the system whenever you want your voice to be heard. Number 5. Avoid interrupting the speaker and make sure that you are acknowledged before you speak. Number 6. As much as possible, turn on your video so that we could have a wonderful conversation. Number 7. We encourage you to station yourselves at a place free of destructive noise so that you could focus on the meeting. And lastly, number 8. We want to capture the moment with you. Kindly stay until the end as we will have a group photo after. Thank you, and have a good day ahead.
The nation rumbled into scenes of chaos.
Dalawang suicide bomber sa hulo. Good afternoon, Supremo.
Hello, good afternoon. Hello, good afternoon, everyone. Oh, good afternoon. Good morning pala. Sorry, magkaiba tayo ng time. We have a different time zone, so I'm
Morning,
confused.
sir.
I'm confused once in a while.
Morning, Sir Primo.
Okay. So it's almost 1 minute before. So asan yung moderator natin? Did we have a moderator here on this plenary?
Sir, meron po. Baka
Okay.
hindi pa lang po nag-online.
Hintayin na lang natin. Baka hindi pa nagkakape.
Oo nga po. Minsan po yan, kahapon may technical problem dun sa sa kanila.
Pasensya na kayo. Lagi ako maaga.
Good morning, sir.
Good
Bong
morning.
from Legazpi City. Ko yung magpalit moderator muna kayo, Japet.
Okay.
Oo.
Meron bang susunod sa akin after? So we need to be mindful of our time, right? Para hindi
Ikaw yung mauna, sir? Ikaw ba yung mauna?
Hindi
Sir
ko alam.
Primo.
Alam ko ako.
Sir,
Hello.
sa plenary kayo, sir. Plenary 3 po kayo, sir.
Oh my God. Did I go to the wrong plenary?
Yes, sir.
Nasa 1 kayo, sir.
Can you send me the link then? Sorry. Okay.
Okay, sir. Will do po.
Michela, good morning.
Yes, sir. Good morning.
Oo, si Engineer Charles nag-attempt to mag-log in as the presenter for doon sa transient voltage.
Yes, sir. May provided na po tayong link sa kanya, sir, under Plenary 1.
Okay, pinadala mo na. Sige, confirm. Thank you.
Before we begin our meeting, please be informed of the following video conferencing etiquette. Number 1. If using a laptop, tablet, or mobile phone, make sure that your battery is fully charged to avoid sudden disconnection. Number 2. To be the best, you have to look the best by observing and wearing appropriate attire fit for the meeting. Number 3. Be on mute at all times and listen attentively to whoever is speaking. Number 4. Maximize the use of chat box and other tools made available by the system whenever you want your voice to be heard. Number 5. Avoid interrupting the speaker and make sure that you are acknowledged before you speak. Number 6.
1 p.m.
As much as possible, turn on your video so that we could have a wonderful conversation. Number 7. We encourage you to station yourselves at a place free of destructive noise so that you could focus on the meeting. And lastly, number 8. We want to capture the moment with you. Kindly stay until the end as we will have a group photo after. Thank you, and have a good day ahead.
The nation erupted into scenes of chaos.
Dalawang suicide bomber sa hulo.
two, one.
Welcome. Before we begin our meeting, please be informed of the following video conferencing etiquette. Number 1. If using a laptop, tablet, or mobile phone, make sure that your battery is fully charged to avoid sudden disconnection. Number 2. To be the best, you have to look the best by observing and wearing appropriate attire fit for the meeting. Number 3. Be on mute at all times and listen attentively to whoever is speaking. Number 4. Maximize the use of chat box and other tools made available by the system whenever you want your voice to be heard. Number 5. Avoid interrupting the speaker and make sure that you are acknowledged before you speak. Number 6. As much as possible, turn on your video so that we could have a wonderful conversation. Number 7. We encourage you to station yourselves at a place free of destructive noise so that you could focus on the meeting. And lastly, number 8. We want to capture the moment with you. Kindly stay until the end as we will have a group photo after. Thank you, and have a good day ahead.
The nation erupted into scenes of chaos.
Dalawang suicide bomber sa ulo.
Good morning again to our electrical practitioners who are here with us. Hopefully, you have enjoyed our sessions yesterday. So down to our last day of the technical sessions. Of course, we hope that you enjoyed our sessions yesterday and you will be with us for the rest of the day. Without further ado, I would like to call on the member of the Technical Sessions Committee and of course, one of the energetic members of our committee, Engineer Ronaldo Ebrada, to introduce our first resource speaker. Sir Bong?
Hey, thank you, Yel. Kay sa mga santos siya kabuksan ed sa kayo amin. Naimbag nga bigat, maayong buntag, maraing na aga, and good morning, everyone. Okay? So our first speaker for today has a 15 years work experience in engineering, design, and maintenance. He graduated Bachelor of Science in Electrical Engineering in Pamantasan ng Lungsod ng Maynila. He is a former Associate Design Engineer, Control System Department, Floor Manila, Philippines, Alabang, Muntinlupa. He is a former Assistant Engineering Manager, Electrical Safety Manager, and PCO at Unilever Philippines Incorporated, General Trias, Cavite. Current Department Manager of Electrical Engineering Department and Certified Engineering Manager of St. Luke's Medical Center, Quezon City. Let's, mga kasama ko sa electrical practitioner, let's all welcome Charles Ryan Villanueva. Sir, right, Charles, the floor now is yours.
Yes, good morning, Sir Bong. So, I'm glad I have this opportunity to share to all of you the setup in hospital care. So, good morning to the board members, to the IIE officers, and to my fellow engineers today attending this session. Are you seeing my presentation?
Yes, sir.
Yes,
I'm
Charles.
here.
Okay, so the topic for today is transient voltage disturbances mitigation and power safety requirements for hospital equipment. So what is a hospital? Hospitals are institutions that is built, staffed, and equipped for the diagnosis of diseases, for treatment, for both medical and surgical of the sick and the injured, and for their housing during this process. The modern hospital also often serves as a center for investigation and for teaching. Right now, and the past few months, almost more than a year, 2 years, already experienced great need in hospital care. Having a pandemic that we are experiencing right now, it is essential for us to have a power and a safe hospital to deliver the needs of our patients. So my contents are about transient voltage disturbances, mitigation, power and safety requirements, and the summary and the standards that would help us more have to understand what is there in the hospital setup. About transient voltage disturbances. Transients are power quality disturbances that involve destructive high magnitudes of current and voltage or even both. It may reach thousands of volts and amps even in low voltage systems. However, these exist in a very short duration from less than 50 nanoseconds to as long as 50 milliseconds. These the shortest among power quality problems, hence its name is transient, usually include abnormal frequencies which could reach as high as 5 megahertz. Sources of transients. There are two sources of transients. It is internal and external. For the internal, there are capacitor switching, current interruption for motors, power electronics operations, electrostatic discharge, arc welding, copy machines, faulty wiring of circuit breaker operations, contact and relay closure, load startup or disconnect. For the external, lightning, capacitor switching, line or cable switching, transformer switching, current limiting fuse operation. Effects of transients. Electronic equipment. For the electronic equipment, equipment will malfunction and produces corrupted results. Improper specification and installation of transients surge voltage surge suppressors can aggravate the failures. Efficiency of electronic devices will be reduced. Electronic devices are helping our doctors, our nurse in the healthcare industry. Even a minor electrostatic discharge could affect the operation of blood pressure monitor or automated external defibrillator. Effects of transients in motors. Transients will make motors run at higher temperatures, may result in microjogging leading to motor vibration and noise. Degrades the insulation of motor winding resulting to equipment failure. Increases the motor losses, hysteresis, and its operating temperature. Effects of transients in lights. Fluorescent and bulb ballast failure. Appearance of black rings and fluorescent tube. Of transients. Indicator of transients. Premature filament damage leading to failure of incandescent lamp. Effects of transients in electrical equipment. Transients degrade the contacting surfaces of circuit breakers and switches. Nuisance stripping of breakers due to false activation to non-existent current demand. Reduce transformer efficiency because of it increases hysteresis loss. Damages due to such power quality problems are uncommon and compared to voltage sags and interruptions, but when it does occur, it's more destructive. To protect against transients, end user may use transient voltage surge suppressors, while utilities install surge arresters. There are two types of transients. It's impulsive transients and oscillatory transients. Impulsive transients are described as a sudden non-power frequency change in voltage, current, or both that is unidirectional in polarity. An example of impulsive transient would be a lightning stroke, arcing, step load change, insulation breakdown, or electrostatic discharge. Oscillatory transient. It is described as a sudden non-power frequency change in voltage, current, or both that is bidirectional in polarity. An example could be a capacitor back energizing or cable switching. So what are we gonna do? Some mitigations. Installing surge arresters, voltage regulators, and transient voltage surge suppressors are designed to remove temporary overvoltage from the power system for protection of distribution and utilization equipment. Using shielded oscillation transformers are effective in rejecting certain types of transients. They will, however, not provide a clean noise-free ground. Some standards available to us are IEEE 142, the Green Book, and IEEE 1100, the Emerald Book. These are excellent references for transformer and sensitive load ground. Another one is voltage regulators or constant voltage transformers are designed to tightly control output voltage for many cycles. Regardless of variations of input voltage, the range of input voltage for which the output voltage will remain regulated is generally less than negative 10% to positive 20% or negative 15% to positive 15% of nominal. In addition to input voltage range, other considerations in applying a voltage regulator are regulator load sensitivity, load compatibility, power factor, energy efficiency, and electrical isolation. Having a power conditioners generally combine regulation, isolation, and transient operations into one policy is also a mitigation. UPS provide constant voltage withstand battery capacity for power failures, short outages, Static UPS may, however, be a source of electrical noise harmonics themselves and may not always deliver a thin sinusoidal waveform unless they are specifically careful. Typical setup of a healthcare facility having a UPS focusing on IT and the billing facilities and the medical devices. So depending on the requirement for each devices or each facility requirement, UPS is also designed and being connected to these devices and equipment. Most of us here in hospital care, we ensure that all medical devices have enough and appropriate UPS for the CT scan, MRI, ultrasonic, and X-ray or other imaging. Power and safety requirements. For the safety protection against electrical shocks or hazards, one environment where electric currents pose an acute threat is in medical treatment and care of patients. Often, patients are physically connected to one or more electrical medical devices for a period of time. In these circumstances, it is possible that the patients are unaware of their exposure to electrical currents, especially if being treated under full or local anesthetics. During invasive treatments, the human body's natural protection organ, the skin, no longer provides basic insulation against electrical currents. It is during these treatments that the electrical currents are low as 50 milliamps. These can travel to the human body and cause heart defibrillation or paralyze the respiratory system. Important terminologies. Equipment under test, the equipment which is subject of testing. Device under test, the device which is subject of testing. Applied part, part of medical electrical equipment that is normal use necessarily comes into physical contact with the patient. For medical electrical equipment or medical electrical system to perform its function. So there's type B, type BF, type CF. A type B is no electrical contact with patient and may be earth. Type BF, electrically connected to patient but not directly to heart. Type CF is electrically connected to the heart of the patient. Enclosure leakage current. Current flowing from the enclosure of the parts thereof, excluding patient connections, accessible to any operator or patient, is normal use through an external path other than protective earth conductor to earth or to another part of the enclosure. Enclosure. Exterior surface of equipment including all accessible metal parts, knobs, grips, and light accessible shafts. Important. This is very important. Output connector, conductive terminals are considered part of enclosure. Earth leakage current. Current flowing from the mains part to the through or across the insulation into the protective earth conductor. Patient connection. Individual physical connections or metal parts intended for connection with the patient, which is for part of an applied part. Patient environment. Volumetric area in which a patient can come into contact with medical equipment or contact can occur between other persons touching medical equipment and patient, both intentionally and unintentionally. So the picture shows the clearances of the patient when being subject for procedure. F-type applied part. Applied part which is electrically isolated from earth and other parts of the medical equipment. Example is floating F-type applied parts are either type BF or type CF. Applied parts. Medical electrical equipment. Electrical equipment designed for treatment monitoring or diagnosis of patients powered from connection to mains supply does not necessarily require physical or electrical contact with the patient. Transfer energy to or from the patient or detect such energy transfer to or from the patient. Medical electrical system. A combination of equipment of which at least one is classed as medical electrical equipment and is specified by the manufacturer to be connected by functional connection or use of multiple portable socket outlet. A class 1 equipment protection against electric shock by earth, additional protection to basic insulation through means of connecting exposed conductive parts to the protective earth in the fixed wiring of the installation. Class 2, also referred as double insulated, equipment protection against electric shock by additional protection to basic insulation. Through supplementary insulation, there is no provision for the connection of exposed metal work of the equipment to a protective conductor and no reliance upon precautions to be taken in fixed wiring of installation. Some symbols and markings. Large variety of symbols for use medical equipment, medical system, accessories, and other related parts. This is the most commonly used symbol displayed. Usually, this would be seen in the medical equipment, any portable, or the fixed medical equipment. Importance of visual inspections on safety requirements. Visual inspection forms a critical part of generally safety inspections during the functional life of medical equipment. It's around 70% of all faults are detected during visual inspection under US statistics. This can include the following inspection. Housing enclosure, look for damage and cracks. Contamination, look for obstruction of moving parts. Connector pins, cabling, look for cuts, wrong connections. Fuse ratings, check correct values after replacement. Markings and labeling, check the integrity of the safety markings, integrity of the mechanical parts, check for any obstructions. Earth band. Earth band testing, also referred to as a ground band testing, earth resistance, earth continuity, or protective earth testing. Test the integrity of a low resistance connection between the earth conductor and any metal conductive parts, which may become live in case of fault on a class 1 medical devices. The IEC 60601, part 1, this clause requires a minimum test current of either 25 AC or 1.5, the highest rated current of the relevant. A test current of 25 amperes AC is most commonly used due to the exposure of high current. Some parts of the equipment could be damaged and therefore requires lower test current. However, the earth band test is designed to stress the connection under fault conditions. Faults in detachable power cord account for 80 to 90% of earth band failures, as most molded power cables are prone to stress when the cables are dropped. This is commonly happened in portable medical equipments because it's not stationary on a certain part, it's moving everywhere in a hospital care setup. So cables are usually being having this some problems that could be encountered. For fixed installations, such as MRI or X-ray equipment, a point-to-point continuity measurement can be made. The resistance is then measured between two probes, one connected to the incoming earth reference point and one based on accessible metal parts of medical installation. Test limits are set in 0.1 ohms for fixed power cords and 0.2 ohms for equipment with detachable power cord. This sample of an MRI equipment having a complete band for all possible metal parts connected. Importance of the leakage measurement. It takes only small amount of current to cause major consequences. Research has shown the current, not voltage, is often the source of injury or death. Consider the following examples on affect the current of the human body. When applied to skin, a non-invasive. It is between 0.9 to 1.2 milliamps. Current just perceptible is 15 to 20 milliamps. Release impossible, cannot be tolerated over 15 minutes. 50 to 100 milliamps. Ventricular fibrillation, respiratory arrest, leading directly to death. This is very crucial and dangerous. 100 to 200 milliamps. Serious burns and muscular contraction of such degree that the thoracic muscles constrict the heart. Stringent rules of the design of medical equipment. To prevent any patient operator being exposed to currents not part of the functional operation of device, these currents are referred as leakage currents. So the IEC 60601 defines leakage current of the three different sources. First is the earth leakage. It's a current flowing down the protective earth. Conductor means inlet. Lead. So there's a typical setup for earth leakage. Number 2, enclosure leakage. So a current flowing to the earth through a person by touching the medical equipment system or part of. Number 3, applied part of patient leakage, current flowing through a person earth from the applied part, or current flowing from the person to earth through the applied part by applying an intended voltage from an external source. To ensure a traceable simulation of leakage currents as passing through a human body, measurement circuits have been designed to simulate the average typical electrical characteristics of the human body. The human body models have measuring devices. Number 1 is single fault condition. To maintain a medical device high level of protection during operational life and maintain integrity of device electrical safety, a number of design features are taken in this account. This is done through by introducing conditions that could occur under normal use, such as reverse main supply or voltage of signal input and output terminals, and conditions that can occur under a single fault condition. Earth leakage test. The earth leakage test is show the current flowing to a medical device or its insulation into the protective earth conductor. The earth leakage test is important as is demonstrated to the total leakage for the device and medical. Under electrical under test and devices under test. Enclosure leakage test. Its general enclosure leakage displays the current that would flow in the person came into contact with the housing or accessible part of, not intended for treatment or care of medical device. Reference table when allowable patient leakage currents are and patient auxiliary currents under normal conditions on a single fault conditions. So it is for the type of type B applied part, type BF applied part, and type CF applied part. Under normal condition, you could see that the highest is 10, but in a single fault condition is 500. For the patient leakage current, sample for the type CF applied part, for normal condition is 10, and the maximum is 50. For a sample of total patient leakage current under type B is 500, and under single fault conditions is 1,000. The total patient leakage current values are only applicable to equipment having multiple applied parts. Another we need to consider on a hospital care environment is emergency power. When it comes to our hospital, standby generators are one of the most critical standards in response time. Your generators need to start before too much damage has been done. According to current standards, hospital standby power must activate within 10 seconds. Additionally, hospitals are required to store fuel on site to keep generators running for a total of 96 hours. In case of power outage, lasts for days. Risk of insufficient backup. We may have a loss of power to life support machines. In many hospitals, large numbers of patients rely on life support machines. Keep them alive. If these machines lose power, many patients could quickly lose their lives, whether patients are in long-term critical condition or recently suffered a severe injury. These machines are often the only thing keeping them alive. In this situation, this is dire. It is critical and that the backup power turns on in a 10-second window. If the power is off for longer than that, it may be too late for some patients, even if the power does not return. Lack of lighting, another risk for insufficient backup. Imagine a patient was in the process of receiving a heart surgery. When suddenly the power shut off, surgeons need to adequate lighting to perform these incredible and delicate operations. Without light, they cannot operate at all. However, with quick-acting generator, it's likely that the surgery can continue with minimal to no consequences. Every medical task requires adequate lighting. Something as simple as filling out a form or applying a bandage becomes nearly impossible in the dark. Lack of communication is also a problem. We have not enough backup. Communication is vital in hospital operations. If the patient is alone and begins experiencing pain or complications, the staff needs to be alerted so that they can address the situation. Without power, some patients have no way to call for help when they need it. During a power delay, many things could go wrong and results in series of consequences for the patient. Similarly, imagine an ambulance traveling with the patient to a hospital or in an ordinary circumstances. The ambulance staff would be constant communication with the hospital staff to prepare for the patient's arrival. If staff members are unable to communicate due to power outage, the patient might not receive the care they need. Decrease in safety. A power outage decreases safety in another setting. Without light, people can see when they're going or where they're going. Doing and accidents are more likely to occur. In hospital, where there are many ill patients, sharp medical devices and potential tripping hazards or even visitors are risked during a power outage. Also, security systems may not function properly without power. If security system fails, another could enter or leave the hospital. Having an essential electrical system is also a safety requirement. Under NFPA 99, treats the generators as a part of essential electrical system. Essential electrical system that refers to all electrical components designed to provide power during an outage and to minimize additional disruption to the existing electrical system. There are different types of essential electrical system requirements, depending on the services provided by the facility, whether the facility uses life support systems or not, and NFPA breaks down its essential electrical system into three different types. It's a type 1, type 2, type 3. NFPA requires all hospitals with an essential electrical system to conform to a type 1 system requirements. So what is a type 1 essential electrical systems, type 2, and type 3? Type 1. Essential electrical systems are comprised of two separate systems capable of supplying limited amount of lighting and power service that is considered essential for life safety and effective facility operation during the time the normal electrical service interrupted for any reason. These two systems are emergency system and the equipment system. Type 2. Essential electrical systems are comprised of two separate systems capable of supplying a limited amount of lighting power service that is considered essential for the protection of life and safety and effective operation of the institution during the time of normal electrical service in the interrupted for any reason. These two separate systems are emergency system and critical system. The type 2 have the number of transfer switches to be used shall be based upon reliability design, load considerations. Each brand of emergency system and each critical system shall have one or more transfer switches. One transfer switch shall be permitted to serve one or more branches or systems in the facility with a maximum demand of essential electrical system of 150 kVA or 120 kilowatt. A type 3 emergency power is essential electrical systems are comprised of systems capable of supplying a limited amount of lighting power service that is considered essential for life and safety, orderly cessation of procedure during the time normal electrical service is interrupted for any reason. Under NFPA 110, the NFPA 100 treats generator as a part of an emergency power supply system. With this specification, there are two definitions you need to know. Emergency power system, or EPS, the source of electric power for an emergency power supply system. Emergency power supply system, or EPSS, the entire electrical system including conductors, protective devices, transfer switches, and more. The emergency power supply powers the emergency power supply system. The NFPA breaks the emergency power supply system in the two categories. It is level 1 and level 2. Each has its own set of standards. Example is a level 1 system should be installed when equipment failure could lead to loss of human life or serious injuries. A level 2 system should be installed where emergency power supply system failure is less critical to a human life. So, healthcare electrical systems consist of two parts. It has non-essential and essential. A non-essential electrical systems consist of general lighting, general lab equipment, non-critical service equipment, patient care areas. And number 2 is an essential electrical system. The electrical system requires for essential electrical system vary according to the associated risk to the patients, visitors, and staff that might occupy that space. NFPA 99 assigns the risk category to each space within the healthcare facility based on the risk associated with the failure of the power distribution system serving that space. What are the risk categories? So the risk categories are category 1. The failure for such equipment of system is likely to cause, or a category 1, is a major injury or death of patients or caregivers. For category 2, minor injury to patients or caregivers. This category 3, patient and discomfort. Patient discomfort. And category 4, no impact on patient. For these risk categories, it has type. So, sample is risk category 1, essential electrical system type 1, critical care space. Category 1, type 2, general care space. Category 1, not required for emergency electrical system, basic examination space. Category 1, waiting room. Essential electrical system branches. The type is also a part of healthcare electrical system. A type 1 electrical system consists of 3 separate branches capable of supplying power considered essential for life, safety, and effective facility operation during an interruption of the normal power source. They are the life safety branch, critical branch, and equipment branch. Under life safety branch is a power lighting, receptacles, and equipment. For the critical branch, task illumination, fixed equipment, selected receptacles, and selected power circuits for areas related to patient care. Equipment branch, necessary for patient care and type 1 operation. The equipment branch of the essential electrical system consists of large electrical equipment loads needed for the patient care and healthcare facility operation. The essential electrical system branch under life safety branch, such as illuminations of means of egress, exit signs and exit directions, alarms and alerting system, emergency communications, task illumination, battery charges for battery powered lighting, and selected receptacles and generator. Elevator lighting, control, communication, signal systems, automatic door use for egress. Under critical branch, it is some critical care areas, isolated power system in special environment, task illumination, and selected receptacles in the following patient care: infant nurseries, medication prep areas, pharmacy, selected acute nursing areas, psychiatric bed areas, ward treatment rooms, nurse stations. Specialized patient care task illumination where needed. Nurse call system, blood, bone, and tissue banks, telephone equipment room and closets. Task illumination, selected receptacle, and selected power circuits for the following general care beds: angiography labs, cardiac catheterization labs, coronary care units, hemodialysis. Selected areas, rooms, treatment areas, human physiology labs, intensive care units, selected post-operative recovery rooms. Lastly, number 9, additional circuits and single-phase fraction motors as needed for effective facility operation. Under equipment branch, central suction system for medical and surgical functions, such as pumps and other required for the safe operation of apparatus, compressed air system for medical and surgical functions, smoke control and stir pressurization system, kitchen hood and exhaust supply system if required to operate. The above said is our following equipment must be arranged for a delayed automatic transfer to emergency power supply. Another for the equipment branch, selected heating equipment, select elevators, supply and return ventilating and exhaust system for surgical, obstetrical, intensive care, coronary care, nurseries and emergency treatment areas, supply and return ventilating and exhaust systems for airborne, infectious isolation rooms, labs, and medical areas where hazardous materials are used, hyperbaric facilities, hypobaric facilities, autoclaving equipment, controls for equipments listed above, other selected equipment in kitchens, laundries, and radiology rooms, central refrigerations as selected. The mentioned above of the following equipment must be arranged for the delayed automatic or manual transfer to emergency power supply. So these are typical setup for and healthcare electrical system requirements. Type 1, essential electrical system. We have this a large electrical system, essential electrical system, and a small hospital. So as you could see, the previous explanations of the circuitry required for the electrical system requirement for the essential electrical system, we have provided different connections for equipment branch, life safety branch, and critical branch as identified as essential electrical system. Can you see the presentation?
Yes, Charles.
Di nag-move. Let's check. Okay. Another safety requirement for hospital care, a ground fault protection. As per NFPA 70, NEC Article 230.95, ground fault protection is required on any feeder or service disconnect 1,000 amperes or larger on a system with line-to-ground voltages of a 150 volt or greater and a face-to-face voltage of 600 volts or less. For healthcare facilities of any type, a second level of ground fault protection is required. As of NEC, ground fault protection is allowed between generators and the essential electrical system transfer switches. However, NEC of 517.17b prohibits the installation of the ground fault protection on the load side of the transfer switch feeding the essential electrical system circuits. So these are typical setup for healthcare electrical systems considering ground fault protection. These are the ground fault protection applicable codes, NEC and NFPA. The wet procedure location requires special protection against electrical shock. The ground fault in this area may not exceed 5 milliamps. Healthcare electrical system requirements for GFCI outlets. So protection to patients and staff in wet procedure locations can be provided through the use of GFCI outlets. The GFCI breakers or isolated power systems. If the GFCI protected is utilized, each circuit must have a dedicated GFCI outlet or GFCI breaker. But it is not possible to use single GFCI device to protect multiple outlets. This limits interruptions resulting from ground fault to a single outlet. Could see. Okay. So I just moved, I think. Okay. Check. So having also international code references, we have also some partners of government agency who sees how ready or how the healthcare facility having enough healthcare electrical system. The Department of Health provides guidelines for this as for the safe hospital. This is a sample of their checklist they would want to check in healthcare facilities regarding your electrical systems. Some arrows also already give us some info to what to expect on a checklist. Right in this one is 7.1 of the electrical system must confirm the Philippine Electrical Code. For the also mentioned the emergency generator, automatic transfer switches. Also mentioned the ground fault circuit interrupters, adequate lighting, electrical system emergency battery with lights, energy saving, and non-current carrying metallic parts of electrical system, electrical enclosures and boxes. So some summary and standards for the healthcare facilities. So this table already summarized the code and standards regarding the transient surges voltages and for the mitigation and the power and safety requirements. For the international code, there is IEEE, NFPA. Also, we have our local code, national code, the PEC. PEC Article 5.70s define the healthcare facilities. So this is the healthcare facility industry having the requirement for transient voltage disturbances to have a mitigation and what power quality and power emergency needed on a healthcare facility that we should entail and have it available in our healthcare facility. And for that, thank you for listening, fellow engineers, for this presentation.
Hey, sir. Thank you very much, Sir Charles Ryan Villanueva. Okay. It's very informative. Okay. So let's move on to the question and answer. Let's move on to the question and answer portions. Okay. So one of the question here is it advisable to use water pipe as a grounding medium?
Water pipe, no sir, kasi for our codes really implies that we must use electrical system grounding or equipment grounding. This under our codes on the PEC, NEC, and alike of standards. I don't know about the ground pipe method. I believe as we grow up, yun na nakikita natin. So I don't know what applicable standards requires for the plumbing system to be a grounding system.
Okay, so thank you very much, sir. Next question is, as you discussed, there are so many mitigation apparatus. Can you give us just one major equipment to do all the mitigations?
All the quality analyzer, sir, could have check some mitigations. So
may I help Engineer Charles with the answer? So so there's no solution, walang one size fits all. And it should be with regards to ano yung practical, with regards to the operation ng isang entity or establishment. And for, I think the best solution that we have right now is yung UPS, of course, in tandem with the generator set. And of course, with the proper wiring installation, we can mitigate yung mga concerns that we have. So pervasive yung installation of UPS sa mga equipment within the hospital.
Okay, sir. So thank you very much. So that's very clear. We don't have a one-stop shop na equipment. Okay, so next question, sir, is the genset room required to be fire rated when located inside a parking floor? Is the genset room required to be fire rated when located inside a parking floor?
Parking, sir, parking.
Parking area. Parking floor.
We will check, sir, if what are the requirements for the genset when if it's fire rated. Possible code standard would be NFPA and our fire code of the Philippines for the fire rated.
Okay, so next question is, there are some government hospitals that use 2 incoming medium voltage circuits. If the incoming circuit is just one and down, Is the standby generator enough to serve the load? Are the tests for the generator like full load test? Are there tests per generator
Okay.
like full load test?
Yes, sir. As per standard of NFPA, we should at least have load test of
There
1
are some
hour.
government hospitals.
Yes, sir. As per standard, sir, it is required for us to test our generator set at full load 1 hour per month. It's then about doon sa sinasabing it must kick in, yes, less 10 seconds or less than 10 seconds, and identify what are the essential electrical system to be provided of the generator as a minimum requirement.
May I add also on that one kay Engineer Charles? So, tama yun. So, based on, meron pa kaming standard, yung Joint Commission International, in which St. Luke's is a member, no? We are required to do load testing of the generator sets, and it is being checked during audits. So, yun, load testing, actual load, no? And since critical loads and essential loads or essential loads within the hospital are covered by UPS, walang masyadong epekto yan pagka kami nag-change over going to generator sets. We just inform everyone 1 week prior that we're going to test our generator sets so that they could switch off yung ibang equipment na hindi kasama dun sa UPS.
Okay, sir.
And we also tama po yun yung additional or redundant na incoming supply. Doon sa aming QC redevelopment, we are looking into one additional incoming power line coming from another substation, which is Valencia, aside from the Santa Mesa namin. Thank you.
Okay, sir. That's there's a very good answer. Okay, so next question is just one recommendation on the presentation. No, sir, it's initial. Okay, next question is, how about lightning protection and grounding system? What type shall be utilized?
Lightning protection. Lightning arresters. Yes, I should install lightning arresters as the PEC and NFPA describes.
Siguro minimin niya dito sa type kung meron ba tayong yung may mga rod type o yung mga
it depends sa application that you will need to wear. Pumunta hospital building itself for the lightning arrestor. So pwedeng rod type siya doon na to the highest level, having a electrical system grid below. So what application he will do the lightning arresters. Kasi pwedeng hospital building, then if malayo naman utilities mo sa hospital building, you should include another arrester for the setup.
Okay, sir, so thank you very much. So next, another question is aside from wet locations, is it advisable to install GFCI to non-wet location areas like common areas, halfway rooms, and outdoor areas?
Hindi po advisable. Unang-una, you are going to add a device that is not required to the system. So maintenance po 'yon. No, nag-add ka na ng cost mo, initial cost mo. At the same time, during maintenance, you're going to add cost because may maintenance din yun. And you are going to be subjected, of course, doon sa nuisance stripping din. No, in case, because yung area, kung doon sa example, hallway, no, tatamaan nung ating mga janitors na nagmamap doon, yung outlet, potentially, magkakaroon ka ng nuisance stripping doon sa area affected.
Okay, sir. So thank you very much. Maybe last question. Since the hospital is continuously in operation, how do you program the maintenance of the facility?
Regarding power, so For maintenance of a healthcare facility, number one, you should have a regular maintenance. So we have a maintenance program for your electrical equipment. So regularly, you have to check the condition of your electrical equipment, having basic visual inspection to thermal scan. So if there are some hotspots, you could correct them, and some insulation resistance test. You should conduct that in your maintenance. So, and some grounding. Should also check that in your healthcare facility. Regarding to emergency power, have a regular maintenance. Most of the time, this must be under accredited service provider who is expert in emergency power generator, to ensure that you have emergency power generator in a tip-top condition when the emergency arises.
And just to add on that one, kaya importante yung redundant system natin, yung alternate power supplies, so that you could do maintenance dun sa mga power supplies alternately. So add lang.
Okay, sir. So thank you very much. That's all for now. We will now proceed with the awarding of certificate of appreciations. Technical, can you show on the screen the certificate of appreciation? Okay, so this certificate of appreciation is presented to Charles Ryan Villanueva for imparting valuable insights as a source speaker on the topic transient voltage disturbance mitigation and power safety requirements for hospital equipment during the simultaneous technical session in conjunction with the 46th Virtual Annual National Convention with the theme GAT1 IIEE at 46, Transcending the Challenges in the New Normal by Embracing Resiliency and Complementarity, held on November 22 to 27, 2021 in Manila, Philippines via Zoom video conference. Given this 27th of November 2021. Signed, Alberto R. Herrera Jr., National Secretary. Signed, Roland P. Vasquez, National Vice President for External Affairs and Exhibit Bureau Director. Signed, Lindon R. Bagge, National Vice President for Internal Affairs and Convention Bureau Director. Signed, Alan Anthony P. Alvarez, National President. Sir Charles, thank you very much for your time and effort and support. Yes, the honor is yours.
Thank you very much, Sir Bong, and of course, our sincere appreciation to Sir Charles and Engineer Noel Pabilona. Thank you, sir, for gracing our event today. So it was indeed a very relevant topic for our electrical professionals, especially who are working in the hospital industries. From one speaker to another, let me call on another member of the Technical Sessions Committee, Engineer Japet Mapa, to introduce our next speaker for today. Engineer Japet. Sir Japet.
Yes, ma'am. Are we done? So we're going to the next speaker?
Yes, sir.
Okay. Kala ko kasi 10 a.m. pa eh. So good morning once again, guys. Let's go to our second speaker. And our second speaker this morning for this plenary is an Asian Chartered Professional Engineer with field of specialization in design, project management, and construction supervision. An Asian engineer registered specialized in electrical design, senior member of the Institute of the Integrated Electrical Engineers of the Philippines, State of Qatar, and has over 33 years of experience in the field of electrical engineering in Asia and in GCC countries. This includes electrical detail design, electrical calculation utilizing various electrical computer softwares, project management and construction support, plant engineering. He has also backgrounds includes design of electrical power distribution systems, lighting and power, ELV systems. Project types includes low and high rise building services, stadium, mass housing projects, hotels, data centers, healthcare facilities, and commercial and industrial buildings, mass railway transport, infrastructure, and oil and gas industry and projects. So our speaker this morning is very expert in so many fields, but he will be giving us a lecture in the healthcare facility. So please welcome Engineer Ben Hardy Wong.
Hello, Sir Japet. So we had a technical problem with the connection of Engineer Ben Hardy Wong. So in the meantime, I was still waiting for him to come in the session room 1. Please watch this video. And we are back. Just a simple reminder for our electrical practitioners who are here in session room 1, you have until 12 noon to cast your vote. So please, exercise your right to vote for the right BOG 2022. Again, let me call on the member of the Technical Sessions Committee, our active member, Engineer Japet Mapa, to introduce our next resource speaker. Sir Japet?
Para hindi kasi narinig ng speaker natin. So once again, I would like to introduce to you our resource speaker this morning. He is an Asian Chartered Professional Engineer with field of specialization in design, project management, and construction supervision. He is also an Asian Engineer registered specialized in electrical design, senior member of the Institute of the Integrated Electrical Engineers of the Philippines at the state of Qatar. He has also over 30 years of experience in the field of electrical engineering in Asia and in GCC countries. This includes electrical design, detailed design, electrical calculation utilizing various electrical computer softwares, project management, and construction support, plant engineering. He has also background in design and electrical power distribution system, lighting and power, ELV systems, and his projects includes the types of low and high rise building services, stadium, mass housing projects, hotels, data centers, healthcare facilities, commercial and building and industrial building, and also a mass railway transport, infrastructure, and oil and gas industry projects. Maraming experience, sir, based on his 33-year experience in electrical engineering. So without much ado, I would like to welcome Engineer Binhardi Wong. Sir? Thank you, sir. It's your time. Nakamute ka, sir. Yan. No sound. Mamiela?
Hello, sir. D, we
sound.
cannot hear you po. Hello, sir. Hello, sir. Hello, sir. We cannot hear you po, but we are seeing you speaking.
Yeah.
Again, sir.
Nakamute siya. Yala.
Nakamute.
Yon. Oh,
Hello, sir.
nakamute.
Ask to unmute.
Yan.
Hello, Sir Ben. We cannot hear you, sir.
Baka sa headphone. Sir, can you hear us? He can hear us, but we cannot hear him. Sir,
We cannot hear you po, but your presentation is visible already in our screen.
Sir Ben, can you take off your your headphone? Maybe that's the problem. Amiela,
Yes, sir?
siguro sa signal niya kasi is no.
Yes po. Lagi na po siya. Hello, sir. Since we also have technical issues again, so we will be waiting for our speaker. So in the meantime, we'll be playing a video so that we don't have an idle hours or minutes for this presentation.
Hello. Hello.
Hello, sir. Audible na po kayo, sir.
Yan, okay na yan.
Okay
Yan.
na ba?
Yes, sir. Yes, sir. Go
Sorry,
ahead, sir.
naglolo ko internet.
Oo nga, oo nga. Sige, sir. Take your time.
Oo. Hello.
Yes, sir. You can start now.
Okay na po yung yung screen. Okay na yung
Not
screen?
yet. Wala pa, sir.
Si-shared ko?
Wala pa, sir. Can you share it?
Share.
Miela?
Wala pa, sir.
po, yung presentation ninyo, sir.
Yan.
Okay na?
Yan. Okay na.
Okay na?
Yes, sir. Go ahead,
Yes,
sir.
sir.
Okay. Sorry for the inconvenience.
Okay lang, sir. Okay lang.
Okay. So, to our honorable distinguished guests, BE Chairman, Honorable Francis P. Mapili, BE Member, Honorable Jaime Mendoza, our National President, Alan Anthony Alvarez, Board of Governors, former presidents, my colleague in the profession, to all attendees, my colleague from IIESQC Qatar chapter, ladies and gentlemen, a pleasant morning to all. My technical presentation today is about electrical safety in healthcare facilities. We have the objectives to highlight. So number one is safety measures in healthcare facilities recommended by various national and international agencies. Guidelines for electrical engineering practitioner in design, construction industry, operation and maintenance, and use of electrical medical equipment and devices. Then we have the introduction. Most of the equipment used in healthcare facilities are electrically operated, such as ECG machine, bedside monitor, anesthesia machine, ventilator, catheter machine, suction machine, laboratory equipment, radiology equipment such as X-ray, CT scan, ultrasound, mammography, and etc. Incubator, implants, one-mer, and etc. Then we have the protection of people in critical current threshold. So for 1 ampere, you will have a cardiac arrest. Then 75 milliampere, you will encounter irreversible cardiac fibrillation. Then 30 milliamps, breathing arrest. 10 milliamps, muscular contraction. 0.5 milliamps, tingling. Then we have the graphical for time current zone of AC effects. This is as per IEC 604719-1 edition 2005. Okay. So we have the threshold from AC1, AC2, AC3. And under AC4 or AC3, we have C1, C2, C3. And under AC4, we have AC4.1, AC4.2, and AC4.3. AC-1 is about perception, and AC2 is involuntary muscular contraction. AC3, difficulty in breathing, while AC4, serious pathopsychological effects. And AC4.1, probability of ventricular fibrillation increasing up to 50%. And for AC4.2, probability of ventricular fibrillation up to 50%. And for AC4.3, probability of ventricular fibrillation above 50%. This time current zone effect of AC current in 15 Hz up to 100 Hz on person, it is seen from the graph that the danger lies in zone AC3 between curve B and C1, and C4, which is located to the right curve of C1. So from B to C and C1 to AC4. Okay. According to the gravity of electric shock at its duration, a person may experience the following: discomfort, muscular contraction, a cardiac arrest, electrocution. Then what are the sources of electrical shock? So these are the direct contact and indirect contact. From direct contact, for example, the person is in contact with a live conductor. Okay. And for indirect contact, the person is in contact with a metal part of an electrical machine or device with an insulation fault. So what are these protection against direct contact? So we have protection by insulation, protection by barrier or enclosure, provision of obstacle, and placing out of reach. While protection against indirect contact, there are 5 recognized methods of compliance with the requirements of the regulation for protection against indirect contact. The techniques can be used singly or in combination within an insulation to provide protection. Earth equipotential banding and automatic disconnection of supply. Use of class 2 equipment. Class 2 equipment is about the double insulation equipment. The non-conducting location, earth-free local equipotential banding, and electrical separation. Then we have the important safety measures. First is the limiting the seriousness of shock, increasing resistance, limiting the system voltage, limiting the contact time. Then we have the selection of correct power supply system. So we have the TNS system and the IT system. Under the TNS system, wherein we have the separate neutral and protective conductors throughout the system. So you'll notice from the source, we have a separate conductor for neutral and protective, or we call it PE. So we have the separate neutral and protective conductor. The protective conductor is the metallic covering of the cable supplying the installation of a separate conductor. All exposed conductive parts on an installation are connected to this protective conductor via the main earthing terminal of the installation. Okay. What are the use of the TNS system? We have the fixed equipment, non-critical equipment, the TNS system in combination with a residual current device, or we call it RCD, must be used for the following devices: permanently installed or mobile X-ray equipment, devices with a connected load of greater than 5 kilowatt, room lighting, this does not include the theater and operating theater table. Then the IT system, so you'll notice that all exposed conductive parts of an installation are connected to the earth electrode. So from the source, we have the earthing impedance, then the installation device, we have an earth electrode, then another installation device, we have an earth electrode. So the source is either connected to earth through a deliberately introduced earthing impedance or isolated from earth. Okay. So use of IT or isolated power system recommended for group 2 location as per IEC 60364-7 710, where discontinuity of supply can cause danger to life. Example, intracardiac procedures, the operating theater and vital treatment, and the isolated power supply remains in operation in the event of a single line to earth fault who may be more susceptible to leakage and unable to move. So the definition of group 0, group 1, group 2 location as per IEC 60364-7-710. Okay. Group 0 is the medical location where no medical electrical equipment is in contact with the body. Okay. So all the medical equipment are not in direct contact with the body. While in group 1, medical location where medical electrical have to be used as follows. Externally, a limited residual 30 milliamps current device is mandatory. Okay. And group 2 medical location where discontinuity failure of electric supply can cause danger to life, like intracardiac procedure, operating theater, and etc. Medical electrical equipment have to be invasively in the body. Okay. Isolated ground system is mandatory. Okay. What is the isolated power? And the isolated power is an ungrounded power distribution system isolated from the ground, serviced via an isolation transformer. There is no neutral to ground bounding connection. High impedance between lines and ground resists flow ground faults. Properly maintained system can protect against direct contact with energized line. First fault, second fault, and demonstration. Okay. So this is a typical diagram of a isolated power supply. From the source, we have the line to neutral and AC/DC diode. Okay. Then we have the AC/DC and then the transformer. Take note of the UPS, IPS, and then there is an insulation monitor. Okay. Then this improve reliability, reduce the leakage current, reduce the touch voltage. A touch voltage of 10 millivolts can be sufficient to trigger ventricular fibrillation. Then we have the grounded power and ungrounded power. Kindly note in the grounded power, see, on the equivalent circuit, we have the line to 0 and hot wire to 1.2 mega ohms at 1,000 ohms for the person. This is a low impedance neutral grounding banding and does not restrict the current return to source. While in the ungrounded power, so with the use of isolator or isolation transformer, kindly note the secondary of the transformer, we have the protective breaker. Okay. While in the grounded power, we don't have any circuit protection. So we have the line to line and 120 volts, line to ground 60 volts. Okay. So at a person of 1,000 ohms. So kindly note of the high ground impedance limits, first fault current that flow to the source. Okay. So this is the flow of current in the grounded and the ungrounded power. Okay. So like what I've said, in the grounded power, the low impedance neutral ground bonding does not restrict the current return to source. While in the ungrounded power, high ground impedance limit fault current flow to source. Why isolated ungrounded power? The continuity of supply, an uninterrupted power isolation power system remains in operation in the event of a single line to ground fault. Okay. It will remain in operation even in the event of a line to ground fault situation. It will eliminate danger of electric shock risk. Conditions to be considered are the surgical techniques, bypass the patient's body resistance. Infants are more susceptible to electric shock because of their smaller mass and thus lower body resistance. Patients are under influence of anesthesia and hence unable to react to electric shock, just in case it will happen. Okay. Fires and explosion due to flammable anesthesia, minimal arcing effect from a first phase to ground fault condition. So monitoring device for the isolated power system. So we have the monitoring of resistance. This is through insulation monitoring device. This is as per IEC requirement. So IMD is for IEC requirement. The insulation monitoring device is able to sense a developing insulation fault at an early stage and to provide an alarm at an adjustable set point, thus providing an improved level of safety. The alarm is raised visually and via a mutable audible alarm at the patient location. Okay, so kindly note, for IEC requirement, we have the insulation monitoring device. While for the NFPA or UL requirement, monitoring of impedance through the line insulation monitor. So that is the difference between the two standards. The LIM monitors the impedance of the conductor to earth and measures the fault current in milliamps. And the red light alarm light up and sounds an audible warning signal as soon as the prospective fault current reaches the threshold of 5 milliamps. Monitoring of load and temperature as per IEC requirement is to protect the isolating transformer primary and secondary terminals and the distribution bus from overloading the overheating. Okay. So this is the comparison of IEC standard and NFPA as per IPS monitoring. So we have this diagram for the IEC wherein we have the IMD. Okay. For NFPA, we have the LIM. Then in the IEC, we have the isometer in continuously measuring the insulation resistance of an unearthed AC or DC network and will trigger a visible and audible alarm at a preset threshold value. It will display the amount of insulation resistance in ohms, and it also monitors the load current, the transformer temperature, L-port location. Is optional to identify the faulty branch circuit. And the alarm is less than 50 kilo ohms. While in the NFPA standard, the line insulation monitor is continuously monitoring the leakage impedance in an introduced ungrounded AC network. Based on this information, the maximum total hazard current is calculated and displayed. The LIM will trigger a visible and audible alarm at a preset threshold from 2 or 5 milliamps. Monitoring of load and transformer temperature is also an optional. So alarm will be at greater than 5 milliamp total hazard current. So this is the difference. For the IMD, we have the 50 kilo ohms, while in the LIM, line insulation motor is 5 milliamps. Then IC standard request the measurement of insulation resistance between an earth system and earth, all times continuously in kilo ohms. Earth fault location is optional, and the isometer absolute monitor the insulation resistance in ohms and trigger a visual and audible alarm when the resistance, the total load amount of the isolation transformer temperature are critical. While in the NFPA standard, request the measurement of resistive, capacitive, and hybrid fault currents to ground. This information will provide an estimation when at all times continuously in milliamps. The LIM or line insulation monitor detects the fault, calculates the total hazard current, which could possibly flow under extreme circumstances, and initiate a visual and audible alarm. An IPS panel as per NFPA or UL and NEC. So this is the photo of the IPS panel, wherein the main components are, we have the isolation transformer, the LIM or line insulation monitor, isolation monitor, circuit breaker, we have the incoming and the outgoing, then the enclosure system. Then there are optional accessories like the remote alarm units, nurse station annunciator for supervisory control, and the power ground modules. So this is a typical schematic for the isolation transformer. So kindly note the unshielded transformer and the shielded transformer. Okay. So for the earth of the system, we take an example for the square D brand transformer. Since quiet operation is important in hospital application, so the Schneider Electric also follow a rigid design criteria to provide a virtually inaudible transformer core and coil unit. Sound rating is about 30 decibel or less are guaranteed on units for 5 kVA and below, and 35 decibels for units 7.5 kVA and above. Okay. And this standard transformer uses a 220 degrees rated insulation system. This insulation system allows by NEMA ANSI standard a temperature rise of 150 degrees centigrade and a 40 degrees ambient. However, this Schneider brand limits the temperature rise to isolation transformer to 80 degrees centigrade maximum, further ensuring reliability on all standard of transformer. These are the sample of an line isolation monitor. Okay. Then the line isolation monitor, the alarm condition does not mean there is imminent danger to the patient or anyone else. The alarm simply indicates the system and has reverted to a grounded or partially grounded system, which is the same system contained in the rest of the hospital. Correct the problem as soon as possible, but do not interrupt procedure being conducted when the alarm sounds. The LIM does not interrupt electrical services. Loss of integrity in the ungrounded system does not affect the operation of the type support devices. An activated alarm does not mean hazardous current is flowing. And the LIM is a predictive device. By sounding alarm, it predicts that 5 milliamps of current could flow from one conductor of the isolated system to ground if a path for the current is provided. This requires a second fault or electric failure to be present in the system before a true hazardous condition exists. Then we have also the circuit breaker. Hospital isolated system includes a primary circuit breaker and 2-pole secondary circuit breaker. All panels are designated to accept up to 16 secondary breakers. So we have only up to 16 secondary breakers. This is as per UL standard. It is recommended using the snap-in type circuit breaker in isolated power panels because of the ability of the breaker to grab the bus. There is no maintenance recommended for the snap-in type circuit breaker. However, for the bolt-on type circuit breaker, it is recommended. It recommends checking the tightness of the bus connection at least once a year. So it is recommended to use the snap-in type or plug-in type circuit breaker rather than the bolt-on type circuit breaker. And we have the enclosure. The back boxes are constructed of cold rolled steel that is degreased, phosphatized, and finished in gray baked enamel. The boxes are designed for flush mounting but are available for surface mounting upon request. The front trim is number 304 stainless steel with a brass finish ensuring corrosion resistance and ease of cleaning. Isolation panels use a non-ventilated enclosure for most panel design. The trim no louver or grills for air circulation, which contributes to safe and easy cleaning. More important, no room air circulates through the transformer compartment, removing the danger of bacteria growth in the warm compartment. So this is to avoid the contamination of bacteria. Okay? The high-inch access door to the dead front circuit breaker and the LIM compartment as a lock to prevent unauthorized entry. The design prevents accidental entry into the transformer section when operating the circuit breaker or LIM test circuit. We have the remote alarm unit. So the remote alarm units, we have the safe function. The green-red light in this push button stays illuminated as long as the measured current is less than the set level. Pressing the safe push button activates the test pressure of the remote alarm unit. Okay. Then we have the hazard, wherein the red light illuminates when the measured current equals or exceeds the set level. The buzzer, the internal piezoelectric buzzer is activated during a hazard condition. The buzzer has an audible level of 65 to 80 decibel at a 10 feet distance. Silence, pressing this push button during the hazard condition silence the buzzer and illuminate a yellow LED. The LED stay illuminates as long as the hazard condition remains. And then we have the bar graph provides from 0 to 160% indication of the amount of leakage current that could flow in the system. Absolute value of current to which this signal corresponds is set on the limb 0 to 69. Leakage current is indicated in green to 70 to 99 is indicated in yellow, and 100 and above is indicated in red. Then we have the nurse station annunciator. Remote indicator alarms are available in annunciator panel for monitoring from a single central location. Code requires an indicator alarm in its operating room, and many hospitals feel it's necessary to monitor its operating room at a central location. This combined annunciator panel unit meets the needs. So annunciator panel for 1 to 4 circuits, and then annunciator panel for 5 to 8 circuits. Power and ground modules, where room ground extension and power receptacles are both required. This module offers convenience and saves such labor in field welding. The units include 4 power receptacles, 4 twists to lock ground jack and ground bus with a generous number of lugs for external ground connection. The main ground connection in the module accommodates up to number 10 cable, and the unit is completely factory weld. Only field power connection and ground connection are necessary. The form trim is number 304 stainless steel with number 4 brass finish. So this is an example of a ground modules. 4 red duplex receptacle and 4 ground jack receptacle. Okay. Where and why we use this isolated power supply? So these are in critical care areas: OR, ICU, CCU, EP, and cath lab, labor and delivery, post-operation, and emergency. Represent a unique environment where electrically powered equipment and conductive fluids routinely coexist with extremely vulnerable human beings. Many common medical procedures within the critical care patient areas expose patients to increased risk of electric shock. Medical gels, antiseptics, saline irrigation, and bodily fluid all conduct electricity and lower the body natural resistance to current flow. Patients are often unable to perceive the occurrence of a shock and incapable of acting in self-perseverance. Okay? Hospitals have duty of care to provide effective prevention against the hazard inherent to environment. As part of a well-designed risk management system, isolated power safeguards against electric shock hazards in areas where human life is most vulnerable. Isolated power system also ensure that normal supply of power to critical medical equipment is not interrupted due to a ground fault occurrence, unlike GFCI. At the design phase of new or renovated facilities, all relevant stakeholders, including consulting engineers, clinicians, biomedical, and facility engineers, should work together to analyze the safety needs of the space, including potential future uses. And most doctors will want their facility to be as safe as possible, and they may be influential in adding IPS to the specification. This is an example on an IPS earthing arrangement, okay? Operating theater. So kindly note, we have the local division board, IPS, and then isolation transformer, the temperature sense, then the load CT. This is the insulation monitor. Then we have the socket outlet, which are connected to the isolation transformer. Then the alarm panel, connected to the insulation monitor. Then we have the earth reference bar. So this is required in the operating theater. So we have an earth reference bar, wherein all the metallic parts, including the anti-static grids, all the operating bed, then all the equipment are connected to the earth reference bar. And then kindly note, the IPS insulated installed, the ERB should then be connected to the local distribution board or protective conductor. Okay. Then this is an example of an IPS in the operating theater. Okay. So kindly note of this IPS. Then another setup for an IPS at the operating theater. These are the setup for the IPS at the critical care areas. So these are the IPS. Then another example of an isolating transformer. Now we have the bed unit. So for the patient room, so we have this bedded unit. Also, these are connected to the IPS. Okay. This is an horizontal type. So we have also a vertical type, which are located on both sides of the patient bed. So this is another bedded unit connected to the IPS. Another type of bedded unit connected to the IPS. And so this one, wherein you will see there are the normal socket outlet. The red one, we have the emergency socket outlet, and then we have the outlet for the medical gases. Okay. These are as per the requirement. There is an example just to share to you. So in one hospital, when they put the patient in the intensive care unit, because of not properly designed, so every time the cleaner cleans the room, he pull the plug and then put the vacuum cleaner. So the patient will die. So they notice this one every time that somebody clean the room, so the patient will die. So they put a camera and then they notice that the cleaner pulled the plug and put the vacuum cleaner. So he did not know that this is connected to the medical equipment. So this is the importance why these socket outlet are properly connected to the IPS, and it should not be removed and should not be power off. Okay. Then design and application as per NFPA UL requirement versus the IEC design. Okay. In general, UL international system are equivalent in purpose and application, with a few difference that exists between the two design and summarized below. UL style has a more sensitive monitoring scheme and is generally less expensive to build and install than the IEC. So NFPA is generally less expensive as compared for the IEC style installation. So under the NFPA, we are using the LIM or ground impedance measurement. While in the IEC, medical IT system, we use the installation monitoring device. This is ground resistance. And for NFPA, the alarm is equal or greater than 5 milliamps total hazard current. While in the IEC, it will be alarm at 50 kilo ohms. Okay. Then standard UL 50 plus wall mounted panels inside OR, 1 to 2 transformer per OR. While in the NEMA rated, standing enclosure outside OR, multiple small transformers per panel in OR. So the IEC, it is installed outside, while in the NFPA, it is installed inside. Okay. The trans overload and temperature monitoring optional, and the trans overload temperature monitor is required. It is required in the IEC, while in the NFPA, it is only optional. Okay. NEMA style panel board bus and bolt-on circuit breaker, no internal wiring. While in the IEC style, a DIN-mounted finger-shaped circuit breaker custom wiring. Okay. Then we have the coding standard as per US. So under NFPA 99, which is the healthcare facilities. So what I use is 2005. We have the latest edition nowadays. So under Chapter 4, Electrical System, it will cover the design, application, and testing requirement. Wet location, the area in patient care area where procedure is performed that is normally subject to wet condition. While patients are present, including standing fluids on the floor or drenching of the work area. Either of which condition is intimate to the patient or staff. Specific commissioning test requires as well as recurring test frequency. NFPA 70 Article 517, latest edition. So article section 517-20, all receptacles and fixed equipment within the area of the wet procedure location shall have ground fault circuit interrupter protection for personnel. If interruption of power under fault condition can be tolerated or be served by an isolated power system, if such interruption cannot be tolerated. Then under 517.160, installation requirement for IPS, orange with distinctive stripe other than white, green, or gray silver screw. Brown with distinctive stripe other than white, green, or gray brass screw. Green foreground may be THHN. No pooling compound shall be used other than the dry talc. Then we have the suggestion for low dielectric XXXHW wire only. Shortest practical branch circuits runs and larger conduits, lighting fixtures, and commercially power supplies can cause excessive leakage current. Then to be verify compatibility with IPS before installation. Then under IEC 603-64-7-710, this is the requirement for special installation or location for medical location. Medical IT system, in Group 2 medical location, the medical IT system shall be used for circuits supplying medical electrical equipment and system intended for life support, surgical application, and other electrical equipment located in the patient environment. So these are the requirements for the medical IT system. Then it requires insulation monitoring device instead of LIM, wherein DC versus AC monitoring. So this is the comparison, okay, or relevant standard between the two standard, the IEC and the NFPA. For IEC standard, the relevant under the medical application, IEC 603-64-7-710, this is about the electrical safety for hospital in medical application. Then IEC 603-64-4.1, this is about the protection for safety and against electrical shock. IEC 603-64.5-54, earthing arrangement, and IEC 604-79-1, this is effect of current on human and livestock. While in the American standard, the relevant medical application under medical application are NFPA 70, the National Electrical Code. Okay, NFPA 70B, practice of electrical equipment maintenance. NFPA 70E is the electrical safety in the workplace. NFPA 99 is the healthcare facilities standard. UL 1022 standard safety line and isolation monitor. Then CAC 32-2 electrical safety and essential electric system in healthcare facilities. NEC Article 516, hazardous location. And UL 1047 is about isolated power supply system. Then we have the safety measure for medical electrical devices. Selection of safe electrical device, wherein the electrical devices to be used in hospital must be safe and tested as per IEC 60601-1. The following tests are required to be conducted. So we have the resistance of protective conductor, earth leakage current, enclosure leakage current, patient leakage current, and patient auxiliary current. Then this is an example of the earth resistant bar. Okay. The use of earth resistant bar and equipotential banding has been recommended for medical location of Group 1 and Group 2. This is by Megan. Megan is the Medical Electrical Guidance Note of UK Department of Health. The resistance between the earth resistant bar and all accessible conductive surfaces of installed equipment should be less than 100 milliohms. The resistance between the earth point and all main socket and the ERB should also be less than 100 milliohms. So these are the requirements. Okay. So kindly note, we have the permanently installed medical devices on the left side, and then on the right side we have the supplementary equipotential banding. Then the lighting and 30 outlets, we have another separate earth bar. This is an example of an earth equipotential earth bar. Okay. Then in one of our project, the operating theater in Rumayla Hospital in Qatar. So this is the earth bar. Okay. Then this is the isolated power supply hanging. So in one of my previous project at the Sidra Medical Research Center, so this is the type of what do you call this, isolated power supply, wherein the changeover module and transformer cabinet for medical location differ significantly from the system that are typically used in industry and feature many more components. So this is an example of a remote alarm control panel, which is a vendor type control panel. See? The universal remote alarm indicator and test combination is designed for visual and audible indication of alarm messages from the system such as the EDS, RMC, MS, and MEDICS. This is the operator control panel, okay, wherein the visual and audible indication of operating status and alarm messages from EDS, Ehlers and Danlos, Ehlers and Danlos syndrome. So this one is also a vendor brand of operating control panel. So this is the control device for switch over module, wherein the PRC487 controls the switching element and monitor for open circuit and switching condition. So this is an example of testing of IPS voltage for a vendor IPS panel at Sidra Medical Research Center project in Qatar. So kindly note, this is also the isolated power supply panel from vendor as per IEC 603-64-7-17 for SMRC project. So this is the remote alarm panel at nurse station, and then the remote alarm panel at clinical room. So kindly note the difference between the remote panel at the nurse station and the clinical room. So this is the wiring installation in the hospital. Then another IPS installation in the hospital. This is the components of the IPS panel. So we have the breakers. Then these are the sample of isolated power supply in the operating theater. Then safety through redundant power supply. So what are the redundant power supply? So we have the utility power through emergency generator and UPS power. Remember, whatever be the circumstances, the electrical installation of the hospital must be or must help to ensure patient safety, improve hospital personnel efficiency, and to guarantee electrical service continuity. Okay. Then what to avoid? Avoid connecting non-medical grade equipment with high leakage current, okay, greater than 100 microamps. So we have to avoid connecting non-medical grade equipment. Commercial PCs, monitors, audiovisual equipment may have simple power line filtering circuit that reduce line to ground impedance on one leg. The reduction in impedance increases the leakage current. Also, avoid lighting circuits except those in the patient care vicinity. Safety from explosion in healthcare facilities, like avoid explosion in flammable gas environment, fire and explosions due to flammable anesthesia, minimal arcing effect from first phase to ground fault condition. Then we have the electrostatic hazard in anesthetizing location. avoid electrostatic sparking hazard. Fluorine to be anti-static properties. The recommended limit of electrical resistance of anti-static fluor as recommended by NFPA 99 and standard for healthcare facilities 2005 edition are as follows. Upper limit, the average value shall not be more than 1 mega ohm measured in accordance with NFPA 99 article E6.6.8.27. Then the lower limit, the average value shall not be less than 25 kilo ohms measured in accordance with NFPA 99 also under article E6.6.8.27. Electrical hazards from laser in healthcare facilities is under the American National Standard Institute under ANSI say 13.6.3. Safe use of laser in healthcare facilities outlines electrical safety procedures applicable to laser equipment in healthcare facilities. Testing and maintenance guideline. Testing of new or modified IPS is required by NFPA 99. The following tests includes inspection of installation material and workmanship. Installation resistance greater than 200 kilo ohms line to ground. Okay. Measured line voltage and port assault current. Proper operation of limb. Annual documentation is required. Resistance from ground bus to conductive values of less than 0.1 ohms. Voltage drop from ground bus to conductive surface is less than 20 millivolts. What are the industry trends? Modern isolated power supply are easier than in the past to install. Test and maintain. Incremental cost over normal grounded panel is small relative to the overall cost of construction or renovation. Advanced digital monitoring techniques along with improvements in medical device design has decreased and nuisance alarms. Annual testing maintenance takes on average 15 to 20 minutes to complete. So you can test it within 15 to 20 minutes. Onboard alarm and event logging, real-time network connectivity option enhance users' ability to respond quickly, diagnose fault and document and trend system performance. Code changes and NFPA 99 currently in major rewrite. So to the latest edition or 2012 latest edition will clear up ambiguity on wet location designation. Then conclusion, when properly designed, applied, and maintained, isolated power system can provide a vital layer of protection to safeguard against electric shock, hazard, and unintended shutdown for critical equipment in situations where human life is more vulnerable. With the level of information and benefits to ensure patient safety and service continuity, improve efficiency of operating room personnel, improve efficiency of maintenance personnel, improve efficiency of supervisory personnel, event traceability, innovation has greatly improved functionality and reliability of IPS while reducing the total cost over the life of the system. The highest degree of safety for the patient, doctors, and staff can be achieved when the recommendation of various standards and regulations are practically applied in healthcare facilities and the medical staff are well trained in using electrical medical equipment and devices. Okay, that's all. Thank you.
Thank you very much, sir. Sir Ben.
Thank you.
So now we will entertain questions. There are questions already posted in our question and answer chat box. The first question is, sir, is it better to use one UPS for every medical equipment or big UPS for all equipment? Maybe this is from the previous presentation, but I think you can answer this one, sir.
Yes, it depends on the requirement. For example, depending on the rating, okay? depending on the requirement, depending on the load. So you can use normally in one operating theater, we are using one IPS.
APS, yes. So.
Yeah. Then this IPS can be connected in the UPS.
Okay. Interesting tong topic ni Sir kasi what if may nag-oopera doon at ang power na nawala, di ba? Patay yung pasyente.
Yun ang main ano natin concern. So that is the idea na we don't have any shutdown in power, no? Especially yun nga yung mga operating theater. So kung nag-o-opera sila tapos nawala yung power, so delikado sa pasyente. At the same time, dahil yan under the anesthesia, so kung magkaroon ng electric shock, so hindi makakaano, so baka mamatay yung pasyente natin. Okay.
Oo nga, sir. There's another one question. What is the recommended type of monitoring device in Philippines? Is it IEC, A isolator, or NFPA, LIM?
For my personal view, in my experience, we use this NFPA in my project. Although these are the same. So meron lang pagkakaiba, yun nga, na katulad ng sabi ko, yung isa is resistance, yung isa impedance. Okay? So nagbabari yun dun sa costing din. Pero technically is pareho naman sila. Ang nag-ano kasi yung client. So for me, yung NFPA yung most ano sa akin.
Okay. Another one, sir, the supply source of these panels not the same with NFPP, ECP, and ELSP. I don't know the abbreviations. I'm not in the healthcare facilities. You get the question, sir?
What is this? NPP, ECP, and ELCP?
Yeah. Yung question niya.
Supply source of this panel, not the same. No, this one can be supplied from the existing power. Kaya lang, ang supply nito is through the UPS. Okay? So because like what we have said, cannot mawala yung power.
Walang power, yeah.
Oo. So yung atin naman supply is connected sa normal power, and this normal power is connected to UPS, and then this UPS connected to emergency generator. Yun yung nasa last part ng ano natin. So we cannot afford to lose the power. Kaya ito is special ano siya. Okay.
Sir, meron ditong question na where to install the IPS in the existing hospital without the said device? Yung wala pang yung hospital na walang mga IPS, saan nila i-install daw?
Yung ito usually ini-install to sa pwedeng ito is inside the room ang operating theater, pwede ito doon sa nearby room. Malapit lang ano nito. Depende kasi doon kung IEC siya o NEC standard. Nandun sa aking
mas malapit sa room na may kailangan
yung IEC kasi pwede mo install inside the room. Yung isa is pwede mo i-install mo lang siya doon sa labas ng kwarto. And then yung monitoring din may pagkakaiba. Yung monitoring ng isa is inside the operating theater. Yung isa naman yung monitoring mo is nandun sa isolator, IPS, I'm sorry. Okay?
Okay. Meron pa kang baka merong magtatanong diyan sa may pumasok na isa. May pumasok na isa. Sir, ang IPS po ba for all occupancy po ng hospital or for operating room only?
Nasa ano lang, ang IPS is used for operating room only. Saka yung mga critical care.
Critical kanina.
Oo, kasi ito is we cannot afford to lose power nga. At the same time, kaya gagamitan ng isolated power supply kahit na mahawakan mo yung di ba minsan pag grounded yung mahawakan mo yung kama, merong electric shock, merong ground, di ba? So yon yung yung area na ganon is gina-ground natin yan. Kinakabit natin doon sa isolated power supply. So kaya kahit na magkaroon ng leakage current, hindi mo may experience na ikaw yung mag-ground. Yun ang purpose noon. Kasi pag may ground fault, ang niyan, magti-trip siya. Ito naman hindi siya magti-trip. Pero kahit maawakan mo, maano, especially during operation, imagine may operation, tapos nagkaroon ng
Electric shock.
ng
Circuit
ano,
breaker,
ng ground,
nawala.
di magaground sila, di mamatay yung pasyente. So yun
Patay
yung
yung pasyente.
purpose nun. Kaya makita mo dun sa patient room, merong bedhead panel doon, di ba? Yung bedhead panel na yun, hindi basta nakakabit yun dun sa ordinary panel. Usually sa hospital, ang requirement nun, ikakabit mo yun dun sa isolated o ano, power supply or meron siyang earthing na tinatawag natin. Special yung earthing niya. May earth bar siya na doon pupunta yung ano. Para kung magkaroon man ng fault o leakage current, walang ground na mararamdaman.
Sir, there's another question here. What safety devices you recommend to be part of the electrical design in order to prevent electric shock of the person inside the hospital? Yung kanina siguro yung pinag-uusapan natin na ano daw yung device na pwedeng ilagay doon para
ordinary device din yan. Kaya lang, ang source mo is nanggagaling sa IPS.
Uninterrupted.
Oo, uninterrupted. Kaya makita mo yung sa diagram ko na line to, for example, line to neutral, dalawang phase siya. Pero pagdating sa after nung secondary side nung ano, meron siyang breaker, circuit protective breaker, yung dalawang line. Diba? Pero dun sa incoming line mo, wala siya. Pero after the secondary ng IPS transformer, meron siyang breaker.
Ordinary na lang. Oo. Siguro this is the last question. Sa IPS, sir, IPS are mandatory in facilities with ORs. Kanina nasagot na natin to eh. With ORs only, but not in healthcare facilities. Maybe additional info. So OR lang ba yan o kahit sa ibang
OR only in the healthcare facilities, okay? Siyempre pag lalagyan mo lahat yung ano, magastos. So mga critical care ano lang, areas. Yun yung mini-mention natin dun sa ano. Yun yung requirement. Yun yung basis dun sa NFPA 99. So kung babasahin mo NFPA 99, yun nga yung healthcare facilities. Madami kasing standard eh. So depende sa ano nyo. Meron pang ano yung National Healthcare Facilities na ano, HTM. So yun yung mga ano, mga standard. So example lang to which is applicable sa ano. Kaya nga meron tayong IEC, meron tayong NFPA, meron tayong UL standard, di ba? So yun yung comparison. Kung alin ang mas ano sa inyo. Sa design na gagawin nyo. Depende rin sa, lalo ngayon, marami ng bagong technology. So, as mentioned.
Sige, sir. Meron pa habol dito, sir. Sir Ben Hardy, good morning. What if I'm using RCBO for medical equipment? Well, was it suitable for grounded supply or ungrounded supply? Thank you.
This is for grounded supply, yung ano, RCBO. Kasi yung RCBO, meron siyang ano na papunta sa ground eh. So, dapat ungrounded ang ano. Saka separate ang grounded ng ano ng sa hospital. Diba na kaya yung sa picture na pinakita ko, meron siyang earth resistant bar. So, yun earth resistant bar na yun, dedicated yung para dun sa equipment sa loob ng room. Hindi saka mo i-connect dun sa ano. Hindi siya tatakbo ng ordinary installation, lahat ng earthing wire mo pupunta sa earth bar ng panel. Ito hindi. Meron kang earth bar. So merong yung Megan na tinatawag natin na requirement. Pero standard na Megan ano, standard. So yun yung ano ng ano. So hindi advisable na ano.
Sige sir, ito siguro magandang tanong to eh. Who can install the IPS? Can it be a local electrician? Kaya lang ba daw ng electrician to?
Actually, it can be installed by local electrician under the direct supervision of supplier o manufacturer. Usually, ganun yun. So, mga special equipment yan. So, kung may experience ka at i-allow ka, pwede naman. So, under the direct supervision, siyempre, no? Ano, bago naman i-energize yan, i-test nila. So, yun. Kung may experience ka, why not? Walang problema.
Why not? Oh, yes. So, nga.
Oo, pwede naman.
Basta hindi lang mamatay yung pasyente in case of their there's a fault. Okay, with that, I think wala na sigurong nakapost. If wala naman sigurong nag-ask ng question, So with that,
yung
we'd
soft
like to...
copy po, sir, ipadadala ko sa inyo para kung merong gustong ano.
Oo nga.
magkaroon
Maraming
ng refer-
natatanong ng
merong
soft
question
copy,
dito,
sir.
sir.
Oh, maraming
How do we
natatanong.
get
Just give
soft
it to
copy of
Ma'am Yela
Special
so that we can distribute it to the
Yes,
participants.
ma'am.
Okay.
Coordinate lang sa akin ni ma'am o kayo na ibigay ko yung soft copy.
Sige, sir. Thank you very
And
much.
also the corresponding standard na let's
Oh,
say kung
yun.
kailangan nila about healthcare facilities. So marami po tayong mga references na about the hospital or healthcare facilities.
Okay, so with that...
Okay, so I hope I have answered clearly your question, or you can email me just in case you have another question. Okay. So email ko po, ibibigay ko lang kay Ma'am Yela. Okay, thank you.
So with that, Ma'am Yela, to post the certificate of appreciation for Sir Bernardi Wong.
Yes.
Okay, the Institute of Integrated Electrical Engineers of the Philippines, Incorporated, presents this certificate of appreciation to Bernardi Wong for inspiring valuable insights as resource speaker on the topic electrical safety in health facilities during the simultaneous technical sessions in conjunction with the 46th Virtual Annual National Convention with the theme GAT1 IIEE at 46, Transcending the Challenges in the New Normal by Embracing Resiliency and Complementarity. Held on November 22 to 27, 2021 in Manila, Philippines via Zoom video conference. Given this 27th of November 2021, signed the National Secretary, Engineer Alberto Herrera Jr., the National Vice President for External Affairs in the Exhibit Bureau Director, Roland P. Vasquez, the Vice President for Internal Affairs and Convention Bureau, Engineer Lyndon Baggy, and our National President, Engineer Alan Anthony P. Alvarez. Once again, thank you very much, Sir Engineer Wong.
Thank you so much, Sir Jojo Wong, and of course, to our moderator, Engineer Japet Mapa. So, is our resource speaker ready? Miss Tess, are you ready na po?
Hi, good morning. Yes,
With that, we will be playing a video before we proceed to the next resource speaker. Thank you. Ma'am Tess, are you ready na po? Hello, ma'am?
Yes. Can I share my
To
screen now?
introduce our next resource speaker, I would like to call on our energetic technical sessions committee member, Engineer Brian Pasilan. Sir Bri?
Yes, Yala, is my audio okay po? Am I
Yes, sir.
audible?
Loud
Yeah,
and clear.
yeah. Okay, so once again, good morning to everyone and welcome to our 46th ANC of IIEE. So we have a lot of topics regarding hospital and healthcare facilities. So I think this could conclude. We have been bombarded now with a lot of very good lecture topics about healthcare facilities, and this last one, but definitely not the least, would surely satisfy our cravings for knowing a lot, knowing a lot more about the systems design of healthcare facilities. So to introduce our next speaker, Code 1, and presently the member of IIE Standards Committee, and as the chairman of the Technical Working Group Committee for Hospital Facilities Design, and he's also the member of Career Progression and Specialization Program or CPSP CAPS of PRC, and she is the Vice President for Operations and General Manager of Alternative Power Solutions Incorporated, a part-time instructor of UST EE Department, and she is a BSEE graduate of University of Santo Tomas and a professional electrical engineer and MBA graduate of Laguna Northwestern College 2019 rather. So our next speaker will be talking about the planning and design guide for hospital and healthcare facilities. So please everyone, help me welcome Engineer Marites Pangilinan.
Can I share my screen right now? Can you see my screen?
Yes, Ma'am Marites, it's clear po. Very, very clear.
Okay, so good morning to everyone. So sabi ko nga, my job today as being the last speaker is easier because of the previous speakers nga po na nauna sa akin. So my topic for today is just to tell you about the primer on the Hospital and Healthcare Facilities Planning and Design Guidelines Manual. Wait lang po. So how did it start? So let me tell you that there was a proposal. Bakit nga tayo nagkaroon nitong manual na to? There was a proposal from the PRC, from the Philippine Regulation Commission, to create a committee on health standards for hospitals and health facilities. At that time, year 2020, when it was proposed, there should be a committee to spearhead the authoring of a new manual on guidelines on the design and planning of hospitals and other healthcare facilities. Now, yung last government order that pertained to the health standards for hospitals were for public and private sector was Administrative Order number 2012-0012, which was authored by then Health Secretary Enrique Ona. Now, the manual on technical guidelines for hospitals and health facilities and planning design was published nearly 2 decades ago. That was in 2001. Okay, so what we're experiencing is we are facing a shortage on the hospitals and healthcare facilities across the country as the COVID-19 pandemic continues to remain a serious threat. As what we have heard sa news nga po, some of the countries in the Europe are in a lockdown today, no, because of a new COVID-19 virus. Kumbaga nag-mutate na naman tong COVID-19. So we cannot be sure na although we are at level 2 here in the Philippines and we are now enjoying yung some of the liberty and freedom to go to the malls, we should be still be careful now. So again, for proper facilities dedicated to treating COVID-19 patients are crucial, as there are other illness and diseases aside from this coronavirus that also needs to be addressed. So There is an urgent need to update the above publications because of the numerous changes that have happened between then and now, but more so for it to be responsive to infectious diseases such as the present one that was not accounted for in the said publications. So what do we do? What do we do last 2020? Sorry po. 2020. So as you can see, I've flashed po yung the boards, this board from architecture, board of civil engineering, board of electronics engineering, board of interior design, board of landscape architecture, board for master plumbers, board of mechanical engineering, and board of sanitary engineering. We all come up with our own planning and design guide for hospital facilities, and each of these were combined in just one publication. I'm very happy to inform you that when I presented it to the DOH, Department of Health, and to the PRC board, I was told that last November 15 was the book launching of this manual. So our manual was included in the combination of all of this multidiscipline to come up with one planning and design guide for health for hospital facilities. So let me backtrack. How was the TWG Electrical was formed? So as I've said, I was the TWG chairman at that time. It was on August 15, 2020, when then the National President, Engineer Rodrigo Pecolera, and then PEC1 Chairman Gregorio Guevara led the Zoom and physical meeting at IIEE National Office to create the technical working group, and whose objective is to prepare this design manual for hospital and healthcare facilities. Now, we have invited a series of design consultants, electrical practitioners working in hospital facilities to share their experiences and then contribute to the conceptualization and creation of the manual. The TWG was headed by the Philippine Electrical Code Committee under the able guidance and direction of our Honorable BEE Chairman, Honorable Francis Mapile, and BEE member, Honorable Jaime Mendoza. So in the screen, let me acknowledge po our technical working group. As I've said, yung pong aming manual has already been submitted to the to PRC, and yours truly is the chairman. Engineer Yodi Diaz is the vice chairman. Our members are Engineer Gregorio Guevara, Engineer Primo Beltran, Engineer Noel Pabilona, who was the speaker on yung speaker po natin, yung first speaker po natin. Engineer Manuel de Guzman, Engineer Julius Salacup, Engineer Antonio Guevara, Engineer Joseph Resela. Contributors, we have Engineer Rodrigo Pecolera, Engineer Roland Vasquez, Engineer Eugene Araulio, Engineer Oliver Gagarin, Engineer Benegreg Siman. Most especially po, thank you po kay Engineer Siman, because when we were doing this manual, actually he contracted po yung COVID. Although he was very weak, he attended some of the meetings po namin to be able to contribute to this manual. And then Engineer Joselito Marquez, thank you. And then our advisors, Honorable Francis Mapili and Honorable Jaime Mendoza. Our overseer is VP Lyndon Bage. And of course, to the Secretariat, thank you very much po. Before I forget po, a special mention kay Engineer Silver Navarro, who contributed po for our PB Solar chapter po sa book. So our guide, if you would see po yung cover natin, okay, nakikita niyo po, sir? Am I clear naman po? Sir?
Yes, ma'am.
Okay po. Just checking po kasi yung aking internet po is baka po hindi ko alam, nawawala. So yung guide po natin consists of 7 sections and then 3 annexes. So we have yung section 1 to 7. Yung mga usually na tinatanong po, like yung diniscuss po ng first speaker po natin, si Engineer Villanueva and Engineer Pabilona, he contributed po dun sa ating section 4, alternate power standby electrical systems. And then for the diniscuss naman po ni Engineer Benjardi Wong, nandun naman po siya sa Annex for Electrical Safety. Okay. So let me mention po yung highlights po natin. As I've said na po, sabi ko yung aking job madali ngayon kasi most of the contents po of the book were already mentioned, but let me go through it para po na maalala natin. So as an introduction po dito sa ating planning guide, it was on the first pages po natin sa section 1. The electrical profession is striving to overcome the challenges of COVID-19 by coming up with the electrical design manual for hospital and healthcare facilities that will significantly take into consideration the demand brought about by this pandemic in adapting existing facilities to cope up with the need for additional power, electrical equipment, and devices. For new installations, future electrical systems planning and innovation in the electrical design will be incorporated in response to these challenges. So the purpose of this guide is to provide the general framework for safe environment in hospitals to protect people from the hazard of electricity during these times when patients are most vulnerable and very sick due to compromised or weakened immune system. So the scope of this manual shall apply to electrical design, construction, installation, operations, and maintenance in the criteria in hospitals. So in the section 1, we've discussed yung classification of hospitals. Actually, this one is according to ownership. You have one, it would be owned by the government, which DOH has come up with the another manual which features all of its government-owned hospitals. So, and then you have the B, it could be private, maybe single proprietorship, partnership, corporation, cooperative, foundation, religious, non-government, and so on. And then number 2, classification can be according to functional capacity. It can be a general hospital or it can be a specialty hospital. Okay. So for levels for hospitals, we have yung sa general, it is classified under level 1, level 2, and level 3. For other health facilities, you have the primary care facility, custodial care facility, diagnostic facility, specialized outpatient facility. Now, sabi nga natin, saan namin kinuha itong reference to? In the first few slides na sinabi ko nga is outdated na supposedly yung ating pinagbabasihan or reference, and then the DOH has not come up with another publication, but I found out ditong recent publication nila itong 2020, it's the same. Walang pinagbago yung kanilang reference in accordance with the levels of hospital. So tama po yung inilagay namin sa book, sa manual, I mean, it's the same. So for hospital services, clinical services for patient, you have the level 1. So I will not read it. Naka-tabulate na po yan, and all of this can be found po dun sa manual natin. So for ancillary services, you have secondary clinical laboratory, blood station, pharmacy, first level X-ray, okay, and so on. So examples naman ng specialty hospitals, ito yung very familiar tayo kasi pag pumunta ka sa National Orthopedic, ibig sabihin nagka-problema ka sa buto. National Center for Mental Health usually is for yung paano ko ba sasabihin? Kumbaga, may problema po tayo dun sa pag-iisip. San Lazaro is more of yung mga nakakagat ng aso. So for particular organ, you have Lung Center, Philippine Heart Center, and then National Kidney Transplant Institute. And then for particular patients, we have Philippine Children's Medical Center, National Children's Hospital, and then you have yung Dr. Fabella, very famous po ito sa mga nanganganak. So specialty hospital that specializes in a particular disease or condition or in one type of patient may be devoted to a treatment of any of the following: treatment of a particular type of illness or for a particular type of condition requiring a range of treatment, and then treatment of patients suffering from diseases of a particular group of organs. Now, included po in section 1 po na ating manual, we have quoted or included yung ating mga reference codes and standards. So marami po ito, but I would tell you yung mostly na ginamit po natin is yung with reference to Philippine Electrical Code 1 2017, and then you have po yung NFPA 99, NFPA 101 Life Safety Code, and then NFPA 110 is for Standard for Emergency and Standby Power Systems. So this one are all listed po dun sa ating manual. Okay? So now we go to highlights for Section 2, Electrical System Requirements. Now, for the electrical design criteria for new hospital, it is important that for the selection of components, we have to properly select the system components and their arrangement, because this is critical to providing hospitals with reliable, safe, and economic electric power. So yung kanina nung nakikinig ako, sinabi nga ni Sir Engineer Pabilona, they are contemplating of having another circuit po beside dun sa unang sirkito nila for a more reliable power. That means tinitignan natin ano ba yung gagawin natin, loop system ba tayo, radial system ba tayo, double-ended ba yung gagawin natin sa hospital. So with this type of design, kailangan natin ng proper component selection. So ano ba yung mga components na i-select natin? You have the primary circuit breaker or switchgear and DU metering equipment, distribution unit metering equipment. You have to have yung medium voltage to low voltage main power transformer. You have to have yung normal power low voltage switchgear, and then yung emergency generator for low voltage switchgear for emergency, and then paralleling switchgear, that is for synchronizing switchgear. You have to have yung automatic transfer switches with the manual maintenance bypass if in case po hindi po biglang nag-transfer po because of some reason. And then meron po tayong mga low voltage main distribution switchboard, panel boards, and then auxiliary control equipment and other packages po. So these are the main equipment po that we have to consider when selecting components for our design in the hospitals. Number 2, we have to consider yung safety. That is protection for patients, medical, and maintenance personnel. Bakit we have to consider this? Let's say for medical personnel, because they usually come in contact with medical equipment in their everyday work. So exposed sila for this type of hazards. So yung tanong nga kanina, are we going to put GFCI or are we going to put RCCB or RCBO? So in our consideration kasi, normally yung experience sa akin kasi yung experience na yung nakikita ko na nagpe-prevail, there are some of the designs na naglalagay po ng ground fault protection dun sa upstream, upstream po nung pinaka-load. So kung lalagyan po kasi natin lalo na itong mga RCCB at RCBO, yung pinaka-settings po nila is nasa milliamperes. Just imagine, very, very, ano po ito, kumbaga po reactive. Kapag nagkaroon po tayo ng konting unbalance po sa current, baka ititrip po yung mga breaker natin. RCCB is yung wala pong short circuit protection. RCBO is meron po siyang short circuit protection with ground fault protection. Yun po yung difference nun. So we just have to really look at the design. Saan ba hindi magkakaroon ng nuisance stripping, and where do we want to really protect po yung ating mga personnel. So when it comes to maintenance personnel po, they come in contact naman po with yung ating electrical distribution switch gears, and then as per our code sa Philippine Electrical Code, maglalagay dapat tayo ng GFCI ng ground fault protection, ground fault protection for circuit breakers 1,000 amperes and above. Okay, 1,000 amperes and above. So hindi na po ito talagang nuisance stripping yung tinitignan natin, because yung pinakamababang setting po for the ground fault protection with this type of breakers po is almost nandun sa 300 amperes, and ang pinakamataas is 1,200 amperes. So for ground fault protection, we are looking for yung pong magkakaroon po kasi tayo ng fire, if hindi po natin na-trip itong breaker na to. Kapag po doon na po naka-sense po yung ating breaker ng ganong kalaking fault current. So doon po ang sabi po ng ating code, doon po tayo pwedeng maglagay ng ground fault protection. But doon sa mga mabababa, let's say leakage current po yung tinitignan natin, we have to really think about kung saan natin ilalagay yung ating mga protection. Okay? So for protection of 4 patients, kagaya nitong nasa picture, you have your isolation panel for patients. Sabi ko nga, na-i-discuss na po ito ni Engineer Benjarty Wong. There are a lot of installers na po ng isolation panel and with the LIM po dito sa Pilipinas. It goes back years before, kaya nga lang po, hindi siya popular. When I say hindi popular kasi yung this requirement before was carried by Schneider Electric and then ng ibang brand. So I remember IsoGuard, kung that is the brand. So meron na po niyan sa Pilipinas, but hindi siya popular na ilagay. But this has the protection for patients because as we know, pag nasa OR sila, these patients are most vulnerable to electric shock because of their weakened immune system. So ang ginagawa po nitong isolation panel, kung makikita po ninyo, may transformer po yan. And yung transformer po natin, hindi induction type po yan, hindi po yan nagpapatrip ng breaker, but it gives an alarm doon sa ating let's say facilities engineers to inform them na meron tayong problem or meron tayong fault doon sa system. But since nga po let's say nakasalang na po yung patient, hindi po niya dapat i-trip itong isolation panel. It should not trip yung breaker. It should give information that there is a problem in the system or there is a fault in the system. Okay? Now, for maintenance naman po, maganda rin po yung sinabi tinanong yung unang ng ating dun sa question po natin, kailan tayo nagkakaroon ng maintenance? As per my experience po, napakahirap po talaga for hospitals to give us, although meron po sila na sinasabi na gusto nilang mag-maintain, but for mga older installations po ng hospital, ang nagiging problem is hindi tayo makahanap ng window para dun sa kailan dapat gawin because yung system or yung design na ginawa po nila, there is no room po for redundancy. So basically, kung ano yung ginagamit nila ngayong circuito, ano yung ginagamit nila ngayong mga breaker, yun din po yung kailangan po nila to have yung operation, daily operation nila. So for our design, we have to take into consideration yung maintainability ng ating mga equipment. So yung sinasabing redundancy, meron po tayo yung loop system na if we have a problem dun sa isang let's say protective device, pwede nating i-cambio doon sa ibang protective device. We have a redundancy na mga transfer switches. And then yung pinakamaganda nga sana kung meron tayong separate circuit or substation na pagkukunan, so that while maintaining doon sa other side, meron pa rin pong power doon sa kabilang side. Now for flexibility and expansion, yung design po natin should be flexible enough to have the ability to expand and then change the distribution system. In our picture, we see na we have a hospital who has a solar PV installed po dun sa rooftop nila. So that is one of the flexibility that we have to do. We have to include in our design so that basically, it's not just helping po yung operation natin to cut costs in terms of energy fees. There is a positive effect po ng mga renewables, not only for solar PV, as one of my slides would show you, the DOH has several recommendations for renewables. Now for economics, this is actually lahat po ng design po maganda, but we have to be very pragmatic na we can only do so much kapag meron po tayong binigay ang client for this much po na design. So sabi ko nga is what we do not do without is yung ating pinaka minimum requirements natin, that is yung ating design for a critical care, which I would mention mamaya. So for economics, the designer shall consider both the initial cost and the operating expense of the electrical system. So for electrical systems design, for the exterior, like yung parking, yung anything na nandun sa labas, if you have yung first private pole, it shall conform to the Philippine Electrical Code 1 and 2. Yung 2 po is, alam ko, PEC 2. It has a new publication po, and I think nalabas na po siya. And then yung Philippine Distribution Code of 2017, distribution utility standards and local government requirements. For the interior electrical systems, which covers po yung loob na hospital, we have the overall facility power distribution shall be designed to be safe, reliable, and secure, and shall provide ease of maintenance without disrupting critical and life safety equipment devices. For electrical systems planning, pinaka-importante po is we have to consult with the project architect and coordinate with the other disciplines that would impact our design for the electrical. Like ano po ba yung usual na ano natin is yung mga mechanical for the ACUs, yung mga sa genset din, kailangan po natin yung ano nila, yung input nila, and for the electronics engineers, kung meron po tayong binabalak na maglagay ng mga BMS, okay? So yung ibang mga electronics na equipment or devices. Then we have to get all the information that we need on the specific requirements, constraints and limitations of the plant facility, and then very important po, consult with the local electric power company and also consult with the local government unit. Okay, so this one I think was discussed din kanina earlier, but let me go through it again. So this is an overview of our healthcare electrical system design. Basically, this one comes from the NFPA 99, which is the health facilities code. And then from NFPA 101, the Life Safety Code. And then this one is also adopted by the Philippine Electrical Code 1, 2017. And you can see this in Chapter 5, Article 5.17 of our Philippine Electrical Code. So para po ma-appreciate natin ng maganda, yung paano ba natin pinagsunod-sunod yung ating design. So yung healthcare electrical system is divided into two, yung non-essential system. So pag sinabi nating non-essential system, these are the loads that are not required to be connected to an alternate power. However, yung kabilang side naman, yung electrical system, essential electrical system, this is further divided into 4 categories. So pag tinignan nyo po yung risk categories natin, meron tayong category 1, category 2, 3, 4. So para lang mabilis matandaan, yung category 1, pag nagkaroon ng failure to our equipment or system, it would likely to cause major injury or death dun sa patient, or even to our health practitioners, like yung health practitioners or caregivers. For category 2, meron po tayong can be minor injury to patients or caregivers. Category 3, patient discomfort. So, and then category 4, no impact. So yung tinitignan po natin basically, pag nagdi-design tayo, itong category 1 and type 1 critical. Under category 1, we have the type 1 critical care because it has yung very stringent requirement when it comes to the disruption or failure of equipment. So under this type 1 critical care, we have yung life safety branch, you have yung critical branch, and yung equipment branch. So I know narinig niyo na pa kanina. So ano lang po, pinapasadahan natin para po natin maintindihan lalo. So let me again emphasize category 1, type 1 critical care, because dito po kasi nag-evolve lahat yung ating backup power, yung alternate power na sinasabi natin dito sa tatlong branches na ito. Okay? So for critical care, life safety branch supplies power for lighting, receptacles, equipment, and then to perform the following functions. Again, makikita nyo po to point by point dun sa under PEC 1, Article 5.17, 3.9. So this is yung illumination of means of egress, exit signs, alarm system, emergency communications. Okay? And then the other one, we have yung critical branch. Critical branch supplies power for touch illumination, fixed equipment, selective receptacles, and selective power circuits for areas related to patient care. And you can see that in PEC 2017 Article 5.17.3.10. How about yung equipment branch? So ito sa equipment branch actually is nakikita natin meron siyang mga branches na pwedeng ilagay po natin dun sa non-essential loads, but pag kailangan po natin na lagyan po ng alternate power, pwede naman po na mag-separate po tayo ng ating linya for this one. And before I forget po, yung life safety, yung ating critical care, separate po lahat yung mga linya po nun. When I said separate yung linya, separate po yung mga conductor, separate po yung ating mga conduit. Hindi po siya po pwedeng mahalo doon sa ibang mga branches po natin, like doon sa non-essential load. So again, for critical spaces, ito po hindi rin, let me add po dun sa mga hindi na-mention kanina, meron po tayong tinatawag na patient bed location branch circuit. So kung makikita po natin, it's stated that for each patient bed location shall be supplied by at least 2 branch circuits or more, no? 2 branch circuits, 2 or more from critical branch and 1 or more from the normal system. At least 1 branch circuit from the critical branch shall supply outlet at that bed location. And then another one na kailangan natin maintindihan, the critical branch receptacle shall be identified and shall indicate the supplying panel board and circuit number. And then lastly, the cover plates for the electrical receptacles or electrical receptacles supplied from the essential electrical system shall have a distinctive color. So yun po yung tatlong nakita ko na dapat maintindihan natin kasi pag pumupunta tayo sa hospitals, sabi nga ni Engineer Wong, yung utility na naglilinis ng room, basta niya inaalis yung saksakan at nagkakaroon ng problema yung patient. Maybe there's a lack po ng distinction kung anong klaseng type na receptacle yon. So dito sa picture, makikita natin in critical care area, meron pong color yung ating mga receptacles. So basically, yung mga dito sa left side natin, if you are in the screen, ito po yung papunta dun sa normal panel, while for the other receptacles po, these are to the critical branch panel. So pag critical branch po, ibig sabihin po, this one would be supplied by an alternate power. It could be a genset, could be UPS, and so on. So for patient bed location naman, so we have tackled about the branches. Ito naman po is we have to comply with this requirement na the equipment grounding conductor for special purpose receptacle, such as operation of mobile X-ray equipment, shall extend to the branch circuit reference grounding points for all locations. So X-ray equipment. So ito pong mga pandemic natin, we have seen a lot of mobile equipment na usually hindi naman po siya nadadala sa room because patients are too weak to go to the, let's say, X-ray room. So bali yung mga, we have a lot of mobile equipment na dinadala dun sa room, and one of them is yung X-ray equipment. So I've seen one, talagang malaki siya, but enough or malaki in such a way na ipapasok naman siya dun sa room. Okay? So each patient bed location shall have a minimum of 14 receptacles. So yung mga nakapasok po sa hospital, nabilang niyo po ba kung ilan yung receptacle na nakalagay doon? So and then at least one of receptacle must be connected to the normal system branch circuit as required by Article 5.17, and a critical branch circuit supplied by a different transfer switch not associated with other receptacles at the same patient bed location. So 14 na receptacles. So ito yung mga pwede nating schematic kung ano yung gusto nating arrangement. We have yung single, 2, 4, 6. So meron din siyang marami pong tawag dito yung para po dun sa alternate power, or meron pong itong combination na 6, 6, 8. Basta po baka ano tayo. And then take note po, ang ginamit na word po dito is shall. So ibig sabihin po, as we saw in our PEC, when we make use of the word shall, it should be mandatory. It shall be mandatory. Di po ba? Pag ginamit natin shall. And this was lifted directly from our PEC code. So supposedly, if you are in the critical care area, mandatory po na ganito yung number of receptacles po natin. So let me show you yung picture. This was given to me by my sister. I have 2 sisters in the forefront when they were fighting yung COVID-19 dun sa US, and they have provided me yung pictures galing po dun sa hospital nila dun sa New Jersey. So basically, they have kung makikita nyo, most of their yung kanilang sa bed, this is beside the bed po ng patient natin. So color coded po yung kanilang mga outlets, receptacles. And then meron po silang special outlet for special equipment din po. And then kung makikita nyo, ito po yung mga mobile equipment na dinadala, let's say yung mga IV pump, and then yung mga monitor po for patient, especially when the patient has comorbidities. Yun ho yung napansin namin when we were doing the manual na ano ba yung kailangan dun sa as compared to isang normal na room. It seems na if you have COVID-19 and you have comorbidities, parang kailangan maraming mga gadgets or mga equipment na dapat ilagay sa'yo to monitor yung iyong condition. So yun yung napag-usapan namin during the conception of the manual. Now, for the operating room receptacles, you should have at least, okay, 36 receptacles, 12 of which shall be connected to the normal branch circuit and the critical branch circuit. Okay, yun yung pinakaano natin, 36 receptacles. So the receptacles required shall be permitted to be locking or non-locking type of the single or duplex type or a combination. All receptacles shall be listed hospital grade and so identified. Okay? So meron po tayong mga hospital grade na mga receptacle. This is different po dun sa ating mga normal na mga outlet in such a way na itong mga hospital grade receptacles natin has a marking and at the same time is very sturdy po. Now we go to general care. As compared dun sa requirement po nung ating critical care, we need the same, at least two branch circuit, one from the critical branch and one from the normal system. And then we have supposedly the cover plate has a distinctive color or marking to be readily identifiable. And again, there should be two separate transfer switches on the critical branch and shall not be required to have circuits from the normal system. So each patient bed location shall be provided with a minimum of 8 receptacles. So yung kanina is mas konti ito kapag nandun ka sa general care. Although kasi sa critical care, life and death situation tayo, dito sa general care, maybe major din po yung ating magiging major effect po kapag hindi po nagkaroon tayo ng power failure po. So patient bed location, as I've said, kailangan minimum 8 receptacles. The cover should have a distinctive color and the cover shall have a distinctive color. So let us see yung, ito po is yung actual bed receptacle po sa general care at a local hospital na napuntahan namin. If you could see, yung ating requirement po is dadalawa lang po yung receptacle niya dun sa patient's bed. Pero sabi nga, kung 4 is meron namang 2 dito dun sa magkabilaan. But then again, there are no markings or distinctive color on the cover plate and unsafe due to uncovered receptacle outlet. So yung mga ganon, dapat nakikita din ng mga maintenance natin na pag nagpapalit po ng mga patients, dapat nasasabi din kung ano po yung problema doon sa room. So efficient lighting, based on the energy efficient lighting of whole building guide, lighting equipment selection should be based on a balance between the requirements of the design and an effort to limit the number of fixture types and lamps type in order to have a reasonable maintenance inventories. Now, for according to DOH, the essential electrical system for hospital facilities shall comprise a system capable of supplying a limited amount of lighting and power service, which is considered essential for life safety and orderly cessation of procedures during the time when normal electrical service is interrupted for any reason. In our manual, basically, we have included we have exhaustive table for the minimum maintained illumination per area or task. So nurse station, this is just a representation wherein what a nurse station looks like, and typical hallway for the lighting, and then operating room, and then you have yung patient's bed lighting. Okay, so itong table na sinasabi ko, you can find that in our finished manual po for the hospital planning and design guide for hospitals. So section 3 for the alternate power emergency electrical systems. So dalawa po yung ginawa namin sa chapter 3 and chapter 4. Kung titignan nyo, almost the same, but for section 3, we focus on the having yung genset as the emergency power. Yung emergency power kasi, there is a difference between yung emergency power and standby power, because yung emergency power is connected to ESS, yung EES or essential electrical system, wherein in case of power failure, the generator should kick in no less than 10 seconds. But when you have yung standby power kasi, let's say you want to have a resiliency during your design na kailangan mong maging N+1, okay? So yung isa can be a standby power, pero yung ano po natin, if you have N+1, imagine nyo, you have 2 day tank, you have 2 storage tank. I think itong mga nasa example natin, hindi naman po kasi nasa skid yung diesel po nila. So basically, ito po yung kailangan natin i-put up. And then, as mentioned po nung ating speaker kanina, when it comes to maintenance, kailangan paandarin po natin to as per schedule. 30, ang nakalagay po sa manual namin is at least 30 minutes. Weekly exercise the generator. So yung po yung difference between yung emergency and standby, and then you can put naman yung standby natin if you have yung po yung budget to power up as an alternate backup power dun sa mga non-essential load. But if in case po there is a prolonged let's say prolonged power failure, and as we have said, kapag po yung mga genset po natin, meron din po kasi siyang capacity for the diesel. So pwede po rin tayong mag-load shedding and then make yung mga standby generator natin to help with the load po ng mga essential electrical system po natin. Okay, so the purpose of this section is to provide minimum guidelines on the classification, proper design, and installation of alternate power in hospital and healthcare facilities, complying with standing regulatory requirements. So yung ano po natin dito is yung NFA 110. Okay? The scope, this is applicable for renovation of existing and construction of new medical and healthcare facilities in the Philippines, considering considering pandemic and infectious diseases resistance requirement. So for alternate and emergency power supply diagram, yung nakikita niyo po kasi natin is yung isang genset lang, but by all means we can have parallel genset kapag talaga malaki na yung system natin. So dito po is you have yung normal source feeding yung ating non-critical loads, and then you have yung ating mga other loads po natin na meron po tayong tiebreaker po dito. So in case po na in case po na may problema dun sa isang end, maita-transfer po natin yung load dun sa other other loads. If I may, itong transformer na to, kasi tatlo itong transformer na tinitignan natin. And for other loads po natin, as mentioned po, you can have po yung uninterruptible power system po to be added to other branches po nitong life safety, critical, and equipment branch. In our manual po is inilagay po namin doon, and I know na na-discuss din kanina kung nasaan po yung aming recommended placement nitong UPS. So in another single line, ito po yung ating transfer switch arrangement for 150 kVA, greater than 100 kVA. If you can see, you have two transfer switches, and then for less than 150 kVA, you have just one transfer switch. So for the alternate power system naman po using yung UPS, we discuss in our manual 3 types of UPS. So the purpose of an uninterruptible power supply UPS is to provide emergency power, usually by a lead acid battery, to load when it senses that the input power source has failed. They are different from emergency power systems or standby generators because they provide instantaneous, which is double conversion type, or to near instantaneous protection from power interruption by using a battery, which can be a supercapacitor or flywheel. So the battery itself usually has a short runtime of about 5 to 20 minutes. I think mas meron po tayong mga UPS na ngayon na mas malaki po yung binibigay na runtime. Lalo na po yung mga ginagamit sa mga casino, yun po, mas mataas po yung runtime po niyan. So a UPS can be used to protect hardware like data centers, computers, and other electrical equipment where an unexpected surge SAG can cause serious problems like data loss, business disruption, and even injuries or fatalities. So ito po yung 3 basic types of uninterruptible power supply that you can see sa manual. We have yung offline standby uninterruptible power supply. And then we have yung online double conversion uninterruptible power supply. And then we have line interactive uninterruptible power supply. So this one is contributed by Engineer Noel Pabilona. So as I mentioned, yun nga po yung ating alternative power supply aside from dun sa ating genset, aside from dun sa UPS. The DOH has come up with yung Clean and Green Manual to 2021, just recently na ni-launch din nila. And if I may quote po yung nilagay nila sa book nila, this one is not in our book because what we have dun sa manual is the use of solar and wind. But if I may quote lang po na ito po yung available sa atin. So use of photovoltaic PV solar systems with batteries for on-site renewable energy generation and resilience. Use of wind turbines when appropriate for on-site renewable energy generation. So when water is abundant, use small-scale hydroelectric power systems, and for use of off-site power purchase agreements to provide health facilities with renewable power. So ito po yung mga options na nakalagay po sa Clean and Green Manual of DOH. 2020 publication is 2021. So we are in synergy. We are not in conflict with the book. They know that REs or renewable energies are very important. Let's say lalo na when to curb the operating costs, because hospitals are operating 24/7, and then this can also be used as an alternate power or backup power. So section 5, highlights of power quality. So yung hospitals po natin more and more, as I've said, is using mga mobile medical equipment which are electronics in nature. And as such, these are very prone or vulnerable to a lot of power quality problems. So I would like to mention, not only siguro yung mga medical equipment, yung pinaka-system po natin, you have yung flicker, voltage unbalance, you have sags, voltage dips and swells, voltage transient, harmonics, over voltage interruptions, and frequency deviations. So yung ito kasi each of these has a unique set of problems na kino-contribute po dun sa ating system. Let's say, if I may, yung sa frequency deviations. Kapag ang frequency mo kasi ay bumaba or tumaas, that would affect yung mga motors mo doon sa inyong system, no? So kung paano siya kabilis or kabagal po umandar, yun po yung magiging effect nun. Let's say for harmonics, this one is, it would make it appear that your system is overload. Well, in fact, when you measure it, kumbaga yung neutral mo, dun kasi nagkakarga ng pinakamataas na current, yung harmonic current. So harmonics is a multiple of frequencies. So basically, nag-iinit yung ating neutral bar. So there is a point nga po when when you design a system, if you consider yung harmonics, lalo na kapag ang system mo is 34.5 down to 400 and you have a single phase loads dun sa ating single phase loads sa ating mga circuits, you may tend to have a 200% neutral, or kumbaga meron ka ring option na why not look it on the other perspective na pwede mo ring taasan yung current to be able to curve yung ating taas ng harmonics dun sa neutral. But of course, with the use of software, we can predict yung harmonics content na ating system design, and we can do that now. So over under voltage, ganun din po, it has an effect doon sa system natin. Voltage unbalance, sags, lalo na po yung sags, and then lalo na yung mga medical equipment natin, as I've said, these are all electronics in nature na po, more and more, lalo na po yung mga ginagamit sa ICU. These are all electronics na rin po. So yung power quality standards natin, ito po yung basic foundations of quality. Yung grounding and bonding and wiring natin should be checked. So kanina yung tanong nga nung nakikinig ako is water pipe ba is good for grounding? Meron po kasi tayong sinusunod as per IEEE 5 should be yung pong ating grounding should not be more than 5 ohms supposedly, no? But given po na if the installation is already old, okay, may tendency po na tumaas yung mga resistance po natin. And the 5 ohms is as per NETA. Ngayon po, kapag gumamit tayo ng water pipe, just imagine po, even if yung ang purpose po kasi natin is grounding, if there is a fault, we can drive po yung fault readily dun sa ground. Ang ano po natin, if there is yung lightning, yun po, yung sa lightning, and then if there is a ground fault po, ang gusto po natin is ma-drive po siya kaagad sa ground, or kasi yung water pipe po is not a good conductor po to get to direct yung fault back to the system so that the proper protective device should trip. So ang ginagawa po natin, lalo na pag sa grounding, we have a separate grounding conductor that would direct po yung ground fault back to the system and then trip po the nearest breaker that is nearest to the fault. Pero po yung sa driving po yung grounding sa ground, I think po, if I'm not mistaken, that would be to divert po yung lightning or over voltage po ng system natin to sa ground. And remember po, from doing that, hindi po naman lahat ng lightning is nakukuha papuntang sa ground. So there are other remnants din po nung lightning yon. That's why meron tayong sa lightning protection, 50% of them would go to the ground, and the other 50%, if the establishment would be strike, would go through the to the building. So that's why we have yung ating surge protective device, which are also mentioned in our manual. Okay, so power condition, surge protection, yung mga SPDs natin, ang pinakatrabaho niya is normally naka-open lang po yan, but if it sends a surge of ang tawag po namin, magka-close po yan, and then it would absorb po yung surge nung surge galing po sa lightning. Now for power conditioning, as I've mentioned, as mentioned by Engineer Pabilona, wala ho kasi tayong device na good for all. Itong mga pwedeng yung transient, voltage, lahat po yan na masosolve. So basically, ito po yung kinontribute niya. We have a recommendation what device to put kung meron po tayong ganitong problem, and at the same time, ang pinakamaganda po is to visit our electrical system. Kasi yung po kasing mga under let's say yung under voltage, over voltage, maybe mayroon tayong mga installation, let's say mostly sa grounding po kasi natin, hindi maganda yung pagkaka-ground, and then meron tayong maybe may problema po dun sa incoming natin sa utility po, pwede po nating tignan kung talagang mabababa yung binibigay or sobrang taas yung ibinibigay na voltahe, and we can do that by use of our measuring devices. Meron naman po tayo mga metering para po makita natin. Ang pinakamaganda po nito, pag meron tayong power monitor, nakaka-capture na po lahat yung mga data na yon, so that we have evidence and we can have yung meron tayong data logging to know if this type of problem is recurring, no, nakikita natin. So meron pa tayong mga devices ngayon na pag inilagay natin, nakaka-capture niya kahit na transient voltage pa yung tumama po dun sa system natin. The response is very quick. So yun po yung mga gadgets na available sa atin. So highlights of building monitoring system and power monitoring. So kanina po sinabi ko na building management system is tied to power monitoring system collectively to supervise and monitor all of the hospital's facility, namely HVAC, security, lighting, and energy. So yung purpose po ng designing, incorporating yung intelligent technology infrastructure for a hospital is to serve the needs of the patient, staff, and healthcare organization to realize the following advantage. You have improved energy efficiency by closely monitoring and controlling energy sources. So 24 hours po nag-ooperate. So basically hindi natin kailangan natin malaman ano ba ang wastage natin, and most of the bulk po ng electricity is more on dun sa mga air conditioning units po natin. So baka po meron po tayong wala naman po talagang kailangan na hindi siya naka-on. Makikita po natin yan. So, kasi with the use of yung power monitoring system po natin, malolocate natin kung anong area po yung talagang nagko-contribute ng napakataas na cost for the hospital billing. So yung pong paglalagay naman po niyan is by feeder naman po. So if gusto naman po natin na mas dun sa pinaka malocate natin yung tama is dun sa pwede din natin ilagay sa circuit. Let's say yung pinaka dun sa mga mga equipment natin, pwede natin dun ilagay yung ating metering na with capability of giving data logging with the capability of to give information when it comes dun sa kilowatt, na hindi lang basta nililista, talagang ida-download mo na lang para talagang ma-analyze mo yung ating usage of energy. So Section 7 highlights operation and maintenance. Okay, so as I've said, maintenance procedures have to be set up to be compliant with standards, rules in the healthcare industry, and ensure that each device and key component in the reliability process maintains its performance throughout the life cycle of the system, and be able to give information to help with maintenance records and regular testing and reporting. In our manual po is naglagay kami ng maraming, let's say, tables which can help you in your monitoring of a schedule for maintenance. Let's say, ito po, monthly for automatic transfer switching, ang recommendation po na NFPA 1110 is for a monthly testing. Testing must occur every 20 to 40 days. Testing involves operating each switch. Operation consists of electrically transferring switch from primary position to alternative and position and back, and testing results shall be documented. And then when it comes to sa emergency power supply monthly test, so nakalagay din po kung ano yung gagawin natin, mga readings. But of course, it depends nga po dun sa hospital yung kanilang redundancy, kasi po hindi naman tayo po pwedeng mag-transfer basta-basta ng mga equipment. So it would take a good design po na magawa po natin lahat itong recommendation as per code. If I may po, yung kanina sabing nakalagay, generators must be tested for a minimum of 30 minutes under the criteria defined in NFPA 110. So yun po yung nakalagay. So for annexes, ito po yung isang idinagdag namin kasi for the healthcare facilities, as what we've mentioned, there was no inclusion of yung how do we tackle yung mga infectious disease like what we have now. So yung sa mga conversion of arena, as what we have in this picture, ang target patients po natin dito is yung mga category 3 patient, which is not really non-acute. So for electrical, inilagay po namin, even though it is just a converted space, we have to follow po yung as per code installation of electrical system. It should comply with PEC 127, provide NFPA 1110 type 10 level diesel generator, like safety, and then transfer switch on a flatbed or in a pad with skid mounted tank and weatherproof enclosure. And then provide exterior switchboard with an automatic transfer switch, connect the switchboard to generator power, and site normal power to create an NFPA 99 type 2 essential electrical system. So if an arena has an emergency generator supplying NFPA 101, yun po yung life safety code po natin, emergency lighting and alarm alerting systems, confirm if this system qualifies as part of the life system branch. Yung pong kanina, whether kung yung generator nga po is pwede po bang, ano po ba yun, yung fire resistant, lalagyan po natin. Kasi ang pagkaintindi ko kanina dun sa question, kailangan ba na lagyan natin na parang yung volt? Yun po ba yung tanong? Meron na po kasi tayong mga genset po na meron po siyang sariling housing. Now, as per yung fire suppression po, nagkakaroon lang tayo ng fire suppression kapag po meron po tayong mga potential exploding agent dun sa loob. So sa genset po, if it is covered with a skid, may skid po dun sa ilalim, nandun yung tangke natin, I think first and foremost po, kung talagang hindi available, napaka ano po kasi yung requirement na lalagyan po natin ng tawag nito, ng parang vault. And then yung exhaust naman po kasi ng genset nakalabas naman po. So I don't think na magagawa naman po ng paraan, not really enclosing po ng that very thick na CHB, kasi po for you to be able to comply with yung 1 hour na fire protection po is dapat makapal yung mga CHB. Siguro there are other ways para doon. Pwede tayong maglagay ng other fire suppression, or the genset should be yung with enclosure. Para po, and then you have another protection po dun sa paligid po nung genset. And then kung nasa parking po siya, yung mga nagpa-park po doon, pwede pong ilayo po natin. So ang sa akin is enough protection para po, not just the protection of yung genset, but yung protection po nung most and primarily protection of the people around it. Lalo na pag umaandar siya, because syempre po yung yung exhaust yung CO2 na emitted by the genset, yun din po ay hindi po maganda para dun sa mga tao. And then yung ingay din po, so that is one of the criterion din po. So during COVID-19 pandemic, there is a serious need for temporary medical facilities. Ito po yung mga tents po natin. Hospital capacity has reached a tipping point, and then temporary medical facilities are built outside of the hospital. So yung mga lighting solutions po natin, meron tayong tinatawag ng mga design ng DOH, hindi po yung string lights yung ginagamit nila, but tent, not really, parang malaking tent na po siya. So basically, hindi na po ito yung ginamit nila. But for those very small tents po, pwede tayong gumamit ng mga string lights. But somehow po, we have to follow din po as per temporary installation as mandated po dun sa ating Philippine Electrical Code. So ito rin po yung isang na-discuss during yung mga temporary lights, isang technology with disinfectant technology, yung mga may UV rays, UV light. Basically, it does not kill COVID, pero it kills bacteria. So kung meron nagko-consider nito sa design nila, maybe you can put it dun sa isang room wherein magkakaroon po tayo ng para po dun sa mga patient with really very sickly. Just make sure po, kasi yung UV light din po has a kumbaga has a criterion. Meron po kasi nga yung malakas po yung spectrum niya, ay malakas po yung UV light niya, and it could cause discomfort kahit po hindi po siya nakikita. Now for solar PV health facilities, this is in our manual, in our annex, and this was discussed thoroughly. We have yung project preparation, system design, project implementation, and PV operation. So we chose this to be our to give emphasis yung PV system installed in their not only on the hospitals but also in their homes. So ito po din discuss po namin. So salient points of the manual. Number 1, ito po yung important points. We want to ensure continuity of service for critical care. As I've said, yung critical care includes yung critical branch, limited number of receptacles, you have automatic switch, life safety branch. Wiring must be entirely independent of all other loads and branches of service. And then it has an automatic transfer switch on its own. Equipment branch loads, not EES or essential electrical system, should be connected to other ATS. For non-essential load must be shed so as not to cause the generator to overload when it enters overload condition. Number 2 salient point, identify appropriate standby provision and develop a contingency plan for backup capacity to enable continuity of supply should a main power failure occur. Number 3, deploy infection control procedures to protect occupants until power and systems functions are restored. Yung common forms of control are eliminating or controlling the reservoir, essentially keeping the microorganisms out of the environment, killing by sterilization, reducing their number by disinfection or sanitation, creating an unfavorable environment for growth, and disrupting or eliminating the means of transmission. So for us, working in the hospital, basically we have to be really mindful of our dressing. Sabi nga, most of the virus ay pwede po nandun sa ating pananamit. So basically, we have to change and be mindful of our hygiene when we go to work, and we go, lalo na if we go in contact with other patients and other caregivers. Number 4, provide a backup emergency power to air handling and pressurization systems to maintain filtration, pressure differentials in protective environment, P rooms, operating rooms, and other critical care areas. Number 5, identifying electrical requirements in the conversion of spaces to provide treatment to patients with both non-infectious and infectious diseases. Yung na-mention ko kanina, ang dami-daming mga mobile medical equipment na pinupunta sa room because patients are very weak to go to the area itself. So isang magandang ginawa is para dun sa mga rooms na kino-convert is to put a portable HEPA filter. Yung HEPA filter natin is basically it makes yung room natin have a negative pressure. So that is high efficiency particulate air filter. So sa mga ventilator, yung mga nahihirapan huminga, lalo na sa mga COVID patients, ito po yung mga inilalagay sa room. So just imagine if you have a lot of monitoring, a lot of medical equipment in your room. So yung sinasabi natin kailangan ng mga receptacles. Actually, as per my sister, ano na sila yung dun sa pinaka peak nung COVID, puro mga extension outlets na ginagamit nila kasi sobrang dami po yung pinapasok sa isang room. So conversion of spaces. So when we convert spaces, just as I've said, is 2017, lalo na if we have yung exposed. And then yung para sa life safety is we should have an emergency generator at hand. And then for dun sa mga outlets po natin kung saan ipa-plug in natin yung or waterproof and lockable so that it would not be, there's no, if meron pong na mangyayari, hindi po siya mahuhugot kaagad. And for cable protectors, we also provide tripping because kung makikita nyo po is very visible to at makikita ng mga dumadaan, lalo na if the cord sets are crossing po yung daan. So number 6, incorporating operation and maintenance of electrical equipment as a way of prolonging lifespan and avoiding downtime of the equipment. So yung sinabi nga is we have visual inspections, titignan natin if infrared thermography, this is non-invasive, and we do this when our load is peak. So basically, before we do our maintenance, we have now a good idea where are the hotspots in the equipment. For ultrasonic listening, we detect yung arcing dun sa ating linya, lalo na sa mga medium voltage. And for the energized maintenance, this is where we do yung ating scheduled maintenance. So in summary, the ultimate goal of this guide is to allow healthcare organizations to deliver effective healthcare by providing the design, performance, operation, maintenance, and testing guidelines for safe and reliable electrical systems in healthcare facilities. So thank you po, and that's my presentation po.
Thank you very much po, Engineer Pangilinan. So it was a very, very informative lecture about design guide for hospital and healthcare facilities. So thank you very much, Roman. And if you may allow us, there's a few questions here in the Q&A box.
Mr. Moderator,
Okay,
can I have one, sir? Can I be recognized, Mr. Moderator?
Yes, is this Sir Jun?
Yes.
Lopez?
Yes, sir.
Okay. Okay, go ahead, Sir Jun. You'll be the first to.
Good morning. Good morning.
Sir.
Yes, Marites. Good morning.
Hi, sir.
Very nice presentation. Very nice presentation. I just like to ask, when can we avail of this manual? When can we avail of this manual?
Actually, sir, nilaunch ko po kasi ng PRC yung combined manual po ng all of the disciplines last November 15. So we have to get, hindi ko po alam yung kung authorization, if we can print separately itong manual po natin. Because the work was commissioned by PRC.
Okay, thank you very much. I'm very much interested in having one. And it will really greatly help.
We can do that separately po. Yun po.
Oh, sige. Thank you very much. That's all. Back to you, Engineer Brian. Thank you
very much, Sir Jun. Thank you
Yes, Sir
po.
Jun, thank you very much. So, yes, marami po talagang interested doon sa manual, ma'am, no? So, it would be good na it could be released.
Sir, sana nga po may release. Actually, if I may say, sir, the manual was finished way back 2020 and we were just given, actually, if I may just share, almost just 3 months po to complete yung manual. So you could just imagine po yung pressure for all of the contributors and mga tao po behind po dun sa manual. That's why I thank them. I thank them in the at the start of the presentation, because yun nga po yung pressure sa amin was really that high kasi to come up with the manual. Pero we're just waiting siguro dun sa advice sa amin. Tapos na po ito, and sabi ko nga is na-launch na po ito ng PRC noong November 15 combined with the other disciplines po. So every discipline has its own planning and design guide, pero dedicated dun sa nila discipline po nila, and then we contributed po yung sa atin sa electrical.
Yeah. That will be a very big help po, ma'am, no? Especially the design of healthcare facilities is oftentimes the one really put into much importance, no? Just like treating it like residential, common residential or commercial building. Okay. So thank you for that.
May I add po, yung isang kasing hindi nasagot siguro yung sa lightning arrestor. Opo. Yung sa lightning arrestor po, sir, basically as per our Philippine Electrical Code dun sa... Can you hear me, sir? Hello?
Yes, go ahead. Very loud and clear po.
Apo. As per our Philippine, kasi ang question is, what is the type of lightning arrestor to be used? So our Philippine Electrical Code is definite on that. We leave that to the designer to choose po. So meron po kasi tayo for the lightning arrestor na pwede po yung aerial na kumbaga yung natawag po namin na yung meron po siyang zoning. So must ang design. And then meron po tayong area, yung pinaka-ground rod po na inilalagay po natin sa gilid. So because the PEC this did not enumerate po yung mga new technologies or include yung new technologies when it comes to the lightning protection. It says dun sa PEC natin that they leave it to the designer to choose yung best LPS that is best for the design, his design.
So yung early streamers po, it's designer's discretion na po.
Yes, sir. Nakalagay po yun sa PEC. Yes, sir. So basically, yung mask po kasi yung usual na nakikita natin when it comes to lightning protection, but it should be combined with the surge protection device. As explained to you, yung pong lightning kasi is hindi naman nadadump sa ground 100%. Some of the percentage goes to the building itself. So it should be a coordination between the LPS and the surge protection device.
So Kirchhoff's law pa rin po.
Nag-prevail.
Kirchhoff's law po. Yeah, so yes, thank you for that insight, ma'am, no? At least naklaro na yung in that aspect po what to specify, no, lightning protection system. Okay, so ito po yung pinakakuha na question, ma'am, no? From Engineer Fabrio, no? So which agency talaga yun, no, yung mag-enforce o mag-implement ng standards na ito, ma'am? So supposedly it's OBO dapat, ma'am, no?
Yes, sir.
Effective.
Kasi they have yung power po talaga eh. Oo. Sila po yung pwedeng magpa-stop ng installation, sila yung pwedeng actually even yung mga planos po signed po by PEs are reviewed po ng OBO din eh. Yun po yung nangyayari ngayon. Yung enforcing, meron po kasi silang enforcing authority.
How about sa may ibang department po ba yung Department of Health, no, na may guidelines kasi din po sila, especially doon sa grounding, no?
Yeah.
Grounding.
Actually, when we look at yung bagong labas po kasi nila, it's most of that is parang it really does not zero in when it comes to the electrical. And then yung pong kinuha po nila na reference po, it's not the new Philippine Electrical Code. So kumbaga part lang po yung mini-mention nila as I've said po dun sa nagme-mention po nila, let's say for the renewable, ganyan lang po yung pagkaka-mention nila, but they do not tackle it in detail. Yung ginawa po natin for the manual, we allot a section or a chapter for each of the topic para po mas maganda po yung explanation. And then if there are any addition po dun sa manual po natin, nilagay po natin yun sa annex as we see it fit because of the pandemic condition that we are experiencing right now.
Okay. Yeah. So thank you for that, no? We move on to our next question, no? So Engineer De Guzman is asking, no, about for the existing facilities, those loads that have not been segregated, no, to a critical essential system. So what do we do with them? Should we do a complete rewiring to be compliant?
So lahat po kasi, kaya nga po we go back again dun sa Philippine Electrical Code, nakalagay po dun sa Article 5.17, meron po kasi if we want to segregate po yung mga EES or yung essential electrical system, ang sinasabi po dun, if there is a time para po mabago lahat yun, let's say, di po ba sa receptacle, sabi natin dapat ganito yung number, ganito yung color, ganito yung covering. But the PEC is very clear on that if there is a time for you to do the renovation, yun po, kailangan sundin natin as per yung code. Kasi ano po ba yung purpose ng code? For safety. Yun po. And then if we truly value po yung life, kasi yung lalo na sa mga life safety, critical branch, tsaka equipment, failure of equipment would mean death or major injury to the patient. So do we want to wait on that? So hangga't maaga magplano tayo when to do yung renovation kasi capitalization kasi yung importante po dyan eh. Even if we want to do yung renovation kung wala pong budget. So how do we start? Yan, sir.
Yeah, so,
So,
you have to balance out, no?
yes,
You have to
sir.
balance out.
So, kung mababasa po niyo sa PC, hindi sinasabi na you have to do this immediately. If you have the time for renovation, yun po yung ang pagkakalam ko exact wording po doon. Then you have to replace yung mga receptacle natin to hospital grade, to really separate yung mga ES natin kasi that's the only way that we would be ensured that we in case of power failure protektado po yung ating mga patients.
Or if I may add po, do the works phase by phase, like start with the moisturizer system, no? If the budget allows, then later on the horizontal works, no, per floor. So I think the preparation, so proper management lang siguro po to how to do the works. To manage
Yes,
the
sir.
costs.
Yes, sir.
So another question by anonymous attendee. I hope we still have enough time, no, for marami pa kasing ibang questions, ma'am. So yes, regarding po
So
for
what
RHUs. Yes po, ma'am. Go ahead.
So kung meron po ding questions, I would take it na lang po so that my colleagues po on the TWG could really answer din po para baka meron po kasi silang ibang thinking or para po at least masagot ng tama po yung mga questions. As I've said po, yung sa grupo po namin, some of the attenders are here.
Yeah. Regarding po pala dito sa next question, ma'am, for government hospitals, RHUs, MHOs, and barangays, no? So required pa din po ba yung 4 COs each from ECP and NPP?
Actually, yun yung pinag-anuhan namin na sabi nga natin, what does it take para po meron po kasi tayo dun sa PEC po, sa PEC po rin natin, yung mga 150 kVA and below. And then yun nga po yung nakalagay for critical care. I take it into dun sa advisement na lang kasi mahirap sumagot na hindi pwede kasi pag sinabi kong hindi pwede, you are not compliant, magkakaroon tayo ng problema yan. So basically, for mga maliliit na hospital, I would think na basically, yung gagawin po natin is yung minimum compliant na meron ka talagang receptacle for EES. Kasi hindi mo kasi alam alin ba dyan yung EES at alin ba dyan yung hindi. Di po ba? O pwede kasi in the near future naman kasi kung hindi naman talaga kailangan na 4 na receptacle, depende po dun sa ating area. I don't know po kung ano yung pinakamaliit na area for let's say sabi niyo po barangay hospital. Barangay, that is a healthcare unit po ba? O maliit?
Yes.
Oo. Yung pinaka-minimum requirement po natin, let's say, kasi po sa mga maliliit na hospital, if you would notice, sasabihin nila hindi kami capable na mag-treat ng ganito. Di po ba? Hindi pinapapunta po siya sa isang maliit, mas malaking hospital. Whatever it is yung pinaka-minimum na kailangan po natin, we have to start somewhere. Pero po, as for now, if we build a hospital, we make it na talagang sustainable itong ginagawa natin. So siguro yung mga maliliit na mga treatment center, I would say na treatment center, yun hindi pa siguro mare-require sila ng ganon because yung classification nila I don't know if they would fall into a hospital category. Kasi pag hospital is merong mga minimum number of equipment na kailangan.
Okay. So, yung ma'am is under the kwan pa, no? Under discussion pa po ba yung sa mga maliliit na health?
Kasi, yes sir, kasi we cannot do away with that pag nag-design tayo. And of course, sabi nga namin, mga maliliit na mga, let's say yung mga government hospital, ang unang tinanong sa amin is dapat 100% ba yung genset? N+1 pala, dapat N+1 sabi nga namin. Wala nga tayong tubig dun sa ibang mga hospital. Nagje-genset pa tayo, and yung genset nga is, sabi ni Engineer Pabelona, 99% idle po yung genset. So we might as well do take equipment that is very important for us today kaysa yung mag N+1. Yun nga, meron naman tayong mga genset na kung maliit lang yung load mo, bakit hindi? Ba't hindi portable genset na lang? Yun na lang, that's the way I look at it, sir.
Okay. Okay, so yung last two question lang siguro, no, short question. So si Engineer Claro po is questioning, may problems kasi I think for interference in X-ray machine connected in the same system. So kailangan bang i-separate?
Alin
Kabilang
po?
system? Station X-ray machines po, ma'am, na nagko-cause ng I think interference or problems with operation, no, when connected in the same system. So needed ba to separate the power supply like transformers and gensets?
Actually, sir, kasi nasa maintenance din kami. Meron kasi kaming na-encounter na mga ganyan na mga interference. Basically po, parang feedback yung nangyayari po doon sa feedback doon sa na-experience niya. I think what you have to do is ang pinakauna po kasi sa to solving any problems is to go to the root of the problem. Di po ba ang ano natin step by step, one by one? Pag tinanggal ko ba to, ito ba yung problema? Baka kasi iba yung nagkukos tapos ang tinitignan natin is yung machine. Yun po kasi yung the way we solve at yung pagdating sa mga maintenance, step by step, one by one, inaalis po namin yung mga kasama dun sa problem. If we see the circuit, tignan natin pag nakatanggal ba itong X-ray machine ba, sir? Pag nakatanggal ba itong X-ray machine, gumagana ba sila? Kung ito lang yung X-ray machine na nakakabit, tinanggal ko yung ibang load, nagpa-function ba siya? So parang process of elimination kasi, sir. So it's not really na i-separate ko kagad. Maybe it's not the right thing at the moment. Pwedeng tignan natin at the step-by-step solution po nung solving yung problem.
Yeah. Before doing anything drastic po, ma'am.
Sayang yung effort, sir. Kasi ganun na kasi parang sa amin sa maintenance, may problema sa circuit breaker. O dala ka na lang ng bagong circuit breaker para mabilis tayo. Palitan mo na lang kung hindi yun ang problema.
Blanket solution po ang tawag.
Pero yun ang kumbaga, it's, lalo na kapag if you're going to another place na malayo, yun talaga yung dapat mong gawin. Kasi you go to step by step pa rin na, ang tanong mo, ba't nagkakaproblema yung breaker? Baka kasi something is causing that breaker. Let's say, yun nga po, lalo na dyan sa hospital, yung mga GFCI or RCCB natin, prone to talaga tripping yan kasi milliamps lang po kasi yung rating niya. So very sensitive po. So kung talaga pong tignan natin na hindi naman po kasi siya nagko-cause ng problem doon, let's say wala pa tayong nakikitang problem, it's gawin natin yung mga RCCB, RCBO to be localized doon sa equipment na kailangan o isasaksak natin. Not included dun sa mga panel board. Kasi pag nasa panel board dyan, it would affect other circuits.
Selective one application or CBO.
Hmm.
So yes, ma'am, thank you. And for our very last question po, ma'am, before we take a break, no? So from Engineer Conrado, future revisions of the manual, can we consider or adopt IEC 60374-7-710 medical installation? So if so, then we could propose the adoption of the standard as Philippine National Standard under BPS TC77. So is it possible pa po, ma'am?
Siguro answer ko, I'll answer you when I get there kasi hindi pa nga po napag-publish ng separate yung manual natin. Nasa PRC, alam ko nasa PRC pa po. So what I plan for the manual is to publish it separately for the electrical engineer practitioner para po at least pag nabasa is makita natin ano pa po ba yung improvement na pwede natin gawin. That is how we want yung manual po na in the future po, let's say, I know po there are a lot of IEC products being used now. And then if you would, you can see naman po dun sa inclusion po natin ng mga codes and standards to be adopted, nakasama naman po doon yung IEC. So yun po, sir. So I think there would be no problem, and kapag naging ganun po is I would get you po as a member po nung future TWG.
Okay. So that would be a very reassuring po, Ma'am Marites, no? Na
yes, sir.
there'll be future steps, no, to address these proposals. Anyways, as much as we would like to address all the questions, but we have limited time. But as Engineer Marites told us, he'll be answering those questions, no, in the proper time or the other time. So we move on now to the presenting of the certificate of appreciation. So, Ma'am Yela, can we flash on the screen? Okay. So, IIEE presents the certificate of appreciation to Engineer Marites Pangilinan for imparting valuable insights as a resource speaker on the topic planning and designing guide for hospital and healthcare facilities during the simultaneous technical sections in conjunction with the 46th Virtual Annual National Convention with the theme GAT1 IIEE at 46, transcending the challenges in the new normal by embracing resiliency and complementarity, held on November 25 to 27, 2021 in Manila, Philippines via Zoom video conference. Given this 27th day of November 2021, signed by Engineer Alberto R. Herrera Jr., National Secretary, Engineer Roland T. Vasquez, National Vice President for External Affairs and Exhibit Bureau Director, Engineer Lyndon R. Bagay, National Vice President for Internal Affairs and Convention Bureau Director, and Engineer Alan Anthony P. Alvarez, National President. Thank you for very enriching and informative lecture. A round of applause, please. Resource B. Thank you po, ma'am.
Thank you.
Yeah. Well wishes. So at this juncture, we'd like, yeah. Go ahead po, ma'am.
Yung pong nagre-request nung presentation, sir, ibigay ko na lang po kay Ma'am Yela.
Okay, noted. Thank you for that, Ma'am.
Thank you.
So at this juncture, I think for a short break, and we'll be turning over to Ma'am Yela. So, Ma'am, please take it away.
Thank you, Engineer Tess, and of course, thank you, Sir Brian, for awarding of certificate and facilitating our Q&A portion for today. So, sit back and relax. So after 5 minutes, we'll be back po because we have another resource speaker. So 5 minutes po, we'll see each other again virtually. Thank you. Amen. 5 minutes. And we are back, everyone. So I hope refresh na po ang lahat. So to proceed with our next presentation, may I call on again, of course, Engineer Brian Pasilan. Sir Brian?
Yes, Mamiela, good noon to everyone. We are now back for next juncture of our program. So, to introduce our next presenter, so this is a sponsored technical presentation by the BCP, and to present their topic. So, knowing today what will never happen tomorrow, electrical safety in hospitals, critical care units. So for our speaker for this next lecture, may we call on Mr. Vincent Jason D. Peñalosa.
Wow, talagang may applause pa tayo, ah. All right, good afternoon, ladies and gentlemen, and thank you for attending this session right here. And yeah, I know it's lunch, so we'll try to make this as engaging as possible. Yes, it's under BCP Trading, but my presentation is going to be under Wesco Electrical and Equipment Corporation, but that's all good. So the title basically is Leveraging Technology for Safe Handling of Power. Go ahead and share my slide, please. All right, can I ask Ella to please pin my video, whatever, because I'm not sharing my screen. Everything's coming from our feed. So basically what we're going to be talking about is leveraging technology for safe handling of power, and it's basically insulation monitoring and fault location for hospital critical care units. Did we actually share the screen already, Gab? Yeah, let me just do that one more time for you, huh?
Yes. You can see the screen po, Sir Vincent.
Yeah, yeah, but I think it froze there somewhere.
The first page, first slide.
Yeah, the first page. All right, let me just try that again. All right, Gab? Give me 1 second. All right, but anyway, first off, I'd like to thank my esteemed panelist, co-panelist a while ago for touching on a lot of things that I'm supposed to be talking about, which saves us a little more time, really. Okay, Gab, you ready? All right, put me back in. There you go. Mm-hmm. All right. So while my video is trying to work, I'd like to know how many of you guys are actually using isolation transformers or isolated power supplies in your facility. Now, I'm pretty sure that a lot of you here are hospital engineers. No? You can use the chat box to go ahead and answer that, and we'll try to answer a few of those things later on. As you can see in my background, I do have a couple of demo units that I can show you, so we can have a little more of a more engaging thing going on, right? So are we ready, Gab? All right, Ella, can you take over? I will have to disconnect real quick. Can you take over for me, Ella? You there?
Sir Vincent.
Yeah.
I think Yella is taking a break po.
All right. Can you take over real quick? 30 seconds. 30 seconds. I will reconnect in a little while, if you don't mind. Sorry.
Yeah, no problem. No problem.
All right. Okay. Thank you. Thank you.
So we'll just wait for a while, no, for Sir Vincent to little adjustments. And I'm pretty sure that we won't really mind, as this is a very engaging and interesting presentation by Sir Vincent Peñalosa. So just sit back and relax and watch our presenter's video for a short while.
All right. Yeah, now I guess I am ready. So I hope you guys can actually see my screen.
Yes. Yeah. You can see your first slide na po, Sir Vincent.
Yes, sir. Visible po.
All right. So you guys are going to have to pin me at one point. All right. So again, the topic is all about leveraging technology for safe handling of power. Let me just check the chat box now unless you guys have a message for me. All right. So just give me a thumbs up if you guys see my screen. All right. Here's a couple of things that we've actually heard from partners and customers. Now, one of the things is we have a suspected ground fault, but we don't know where it is. Nag-trip yung GFCI namin, tinaas na lang namin yung setting para wag mag-trip. Not exactly the best idea. Laging nagtitrip yung ground fault relay namin, tinaas namin yung setting para hindi mag-trip. Again, not a very good idea. Nung tinaas namin yung setting, this is a follow-up actually, nung tinaas namin yung setting, nag-trip sa main, nag-shutdown kami. Yep, pretty much that's what's going to happen. Now, the last one, since it's pretty much on healthcare, whenever we use a dialysis machine, what happens is that we experience the sensation of getting electrocuted. So we don't want that happening. So why is that happening? It's probably because of a ground fault somewhere in the system. So since we're on the subject of healthcare, right? Since we're on the subject of healthcare, what actually happens? Now, how important is your electrical system, in your hospitals? Now, I'm pretty sure that your demands on your electrical system is very high. May it be manufacturing, may it be for healthcare, your business, your facility require round-the-clock operation. And this allows for very limited time for preventive maintenance. As mentioned by the previous speakers, very limited na ang magiging preventive maintenance program natin. And this is where the proliferation of NDTs or non-destructive testing comes into play, similar to the ultrasonics or thermal imaging cameras. But thermal imaging camera, sorry, I am a level 1 thermographer, by the way. Thermal imaging cameras is just part of your toolbox. It isn't the final say. There has to be some more out there after the fact that you've already captured something. Okay, so whenever we fail to acquire all this predictive, preventive maintenance data, there's going to be a huge amount of problems, right? So we should have some form of modern monitoring system to ensure safety, reliability, and efficiency of your power system. Now, any continuous operation can result in premature aging of electrical components. And of course, failure to acquire predictive and preventive maintenance data can result in catastrophic process and economical impacts. We have to admit, at the end of the day, it's all about economics. What happens when something fails in your OR? That's money. What happens if someone dies because of an electrical shock? That's even worse, right? So maraming pwedeng mangyari. Now, what are the typical effects that we have for deteriorated insulation? We can have short circuits, we can have short circuits to ground, we can have short circuits to exposed conductive parts, so on and so forth, right? Now, there are a few statistics. This is based on the NFPA, but this is a little older, I think way back 2004, but this is the one that I chose to put in here just because this is one that's a little more significant. Now, the fixed wiring, the ones inside our walls, make up for 34% of those electrical faults. The cords and plugs, 17.2%. Lighting fixtures, but this is quite limited to, and they mentioned this, for high-powered lighting with high-powered ballasts, and switches and receptacles. And what are the common fault influences? Of course, we have the electrical influences. Whenever you have overvoltage, overcurrent, harmonics, lightning, magnetic and inductive influence, aka bad power quality, then this can also introduce insulation faults and other safety issues into the electrical system. You can also have mechanical influences whenever you have shock, impact, installation flow, penetration of foreign bodies. That's another thing. Environmental effects, temperature, moisture, chemical influences, pollution, pests. Now, there is a common joke among our engineers here in the office na whenever they measure PD, ang tawag nila patay na daga, right? So it's usually those rats that actually crawl up into your electrical system. Equipment aging. Not all our equipment are brand new. No, well, whenever an equipment ages, of course, insulation deteriorates as well. And lastly, similar to these guys, unsafe practice. So I guess you guys will agree with me that insulation resistance would probably be one of the deciding factors for a safe, reliable, economical, and continuous operation of any electrical system. Now, insulation faults should therefore be, number one, detected. Unfortunately, easier said than done, right? Lalo na for those high ohmic resistance faults. Even worse sometimes is if your boss tells you, okay, you found it, locate it. The easiest thing to do is to actually eliminate it because something already happened. Unfortunately, we don't want to reach that point where something actually happens and compromises the safety of your facility and your patients. Okay, so you're probably going to be hearing a few things from me. No, it's going to be either IT system or which is ungrounded system. IT is isolated Terra, not information technology, or a grounded system, Terra, couple Terra neutral, so on and so forth. That's a couple of IEC terms. So what's the main difference? In an IT system, basically, there is no direct connection between live or current carrying parts. So we can have a Y secondary on your transformer without you bonding the neutral to ground. You are still on an IT system. It is still, quote unquote, a floating system. However, this is what we commonly see in our country, where the neutral conductor, and ground conductor are connected at start point. So that would be the main difference right there. So the question becomes is which one is actually safer? Most of the people that I ask would say it's grounded system. They're absolutely correct. There's nothing wrong with it. But however, maybe the more politically correct answer would be it's application dependent. Especially when we're talking about healthcare, operating theaters, critical care units, right? And it is already in our standards. It's already in Article 5.17 of our Philippine Electrical Code. It's in the NFPA 99, which we referenced back in 2005. And it's already also in IEC 60364-7-710, where they actually point out that those critical care units may be Group 1, Group 2, Group 0, Group 1, Group 2, should be on an isolated power supply, isolated by an isolation transformer, monitored by either an insulation monitoring device or a line isolation monitor. So it's already dictated there that, hey, yeah, it has to be floating or it has to be ungrounded, right? Now, why does it have to be ungrounded? Because the fault current in an ungrounded system or an IT system is quite low in an event of a first fault. I mean, with all things being equal, all things being perfect, although we know for a fact that there is no perfect ungrounded system, there will always be leakage capacitance. But whenever there's a fault in an IT system, there will just be a voltage shift of ground, and supposedly the protection device will not open, right? Sometimes, but it depends on a lot of factors like system size, leakage capacitance, so on and so forth, right? Now, for the grounded systems, probably why they don't recommend a grounded system for critical care units is that there is a higher risk of current passing through the body, right? And this is something straight out of IEEE 0.5, which is what we call the threshold of perception. And your typical insulation monitoring devices and line isolation monitors start monitoring and measuring at 0.5. In fact, the newer insulation monitoring device can start detecting 0.1 milliamps already. 5 milliamps is what we call the let-go threshold, and this is also the absolute limits, as mentioned by Engineer Wong a while ago. This is the absolute limit. You cannot go beyond the 5 milliamp range. Now, at about exposure to about half a second of about 20 milliamps, you get respiratory paralysis, fatigue, and pain. And depending on your body impedance, exposure to about 70 milliamps, 70 milliamps, about half an amp, exposure time of about 70 milliseconds, ventricular fibrillation. Now, However, the last part beyond 1 amp isn't exactly in the IEEE, but I was reading somewhere that they were creating research on what happens to the human body beyond 1 amp of exposure, right? They say that it sustained myocardial contraction, burns internal organ damage, and loss of muscle ability. Now, I did ask a doctor what a sustained myocardial contraction is. It's actually where the heart contracts and does not uncontract, so it does not pump. So we kind of know where it goes, right? Now, how do we protect ourselves? How do we start monitoring for IT systems? Now, there's a couple of ways. There are old ways and there are newer ways. The newer ways, of course, since the title of the presentation anyway is leveraging technology, what we use are insulation monitoring devices, or IMDs, according to the IEC. You can use line isolation monitors, according to NFPA. You can use RCMD, residual current monitoring devices. Now, maybe later, if we have time, we can discuss how a residual current monitor actually, the measuring principle behind it, we can discuss that as well. You can use insulation fault location systems to pinpoint which particular circuit you're having a problem with. You have your overcurrent protective devices. You can have RCDs. In Europe, they call it the RCD, the residual current device, or in the US, is the GFCI, or the ground fault circuit interrupter. Now, why do we monitor in the first place? According to the IEC, straight out of the box, this particular slide right here is geared towards more on the industrial side of things. Out of the box, any insulation monitoring device will start measuring. The first alarm is at 40 kiloohms, which is what we call our predictive data. Now, the second alarm is set at 10 kiloohms, where personal protection, plant protection, or fire protection is already compromised. And this is what we try to avert. Right? This is the averted fault. And the difference between your 10 kiloohm alarm and your 40 kiloohm alarm is basically your advantage at time where you can schedule maintenance. A lot of people have asked me, sir, paano pag kinagat ng daga? Well, yung daga, they nibble. They don't sever the cable right away. So if you want to look into your monitoring device, you will actually see a steeper slope going down if your insulation is actually deteriorating. Now, I did mention that there are older technology in measuring insulation, and these are what we call monitoring heritage. We have the 3-bulb method. We can still see this in some of the azucareras out there, right? Now, the whole measuring principle behind it is if there is an insulation fault, whether on line 1, line 2, line 3, lumalabo or namamatay yung isang bombilya. In fact, this was the main measuring principle of Walter Bender, the guy who invented the insulation monitoring device, right? Yun yung kanyang na-imbento. Now, Walter Bender was a mining engineer during Nazi Germany. He was monitoring 40 transformers in a mining facility, which was of course ungrounded. Now, the thing was, legend has it that he was lazy. He didn't want to walk around the mining facility and check up all on the light bulbs. So what he did, he came up with the idea na, hey, if I had a pulse generator carrying voltage, what's left? Current, voltage, what's left? Resistance. No? So Ohm's law pa rin pala. So it's still there. Now, the same way when you have light bulbs, you can use your power energy meter, right? And use a voltage method. If there is a voltage shift to ground, then may isang pase na babagsak ang voltahe. And there you go. That's another Mickey Mouse way of doing an insulation monitor. Now, the typical insulation monitoring device, the measuring principle is quite simple. It takes into consideration one ohmic resistance fault and measures the sum of all ohmic resistance fault, measuring it in true RMS. Now, let me just take out my blur in my background real quick. So you guys can see my, there we go. All right. So this is the typical block diagram of a insulation insulation monitoring device, maybe for vendor, for whoever develops an insulation monitoring device. You have a pulse generator which carries a voltage, a DC voltage of no more than 25 volts DC. It has to be able to measure its own internal resistance, and I'll explain why later. You have low-pass filters to take out the noises and take out leakage capacitance as well, measure leakage capacitance, and coupling resistors to create a superimposed DC loop in there. Now, I did mention about the internal resistance. Why do we need to measure internal resistance? If you take out all those components right here, all those blocks, what it is, it's just a short circuit. So the device has to be able to measure its own internal resistance. And that is also the reason why you only need one, you can only have one insulation monitoring device for one system, not unless you have a redundancy device, which has to switch over, right? Otherwise, if you have, yes, go ahead.
Sir, mukhang nag-freeze yata yung slides natin.
Oh no, I haven't clicked it yet.
Okay.
Yeah,
Okay,
it's okay.
Sorry.
No problem. No problem. I haven't clicked it yet. Going back, if you have two monitoring devices, both of them cannot be connected together. Otherwise, one or the other will detect one as a fault just because you have a galvanic connection to ground, right? So there. And I kind of jumped myself. You can have a copy of this if you want. All right. Now, I did mention a while ago about DC leakage capacitance. Why is this important? Just because we are in the modern times and we have a lot of frequency variation, we have a lot of switching power supplies, so on and so forth, right? It's great if we can measure in a pure AC system, but we know for a fact, and as mentioned a while ago, we have a lot of harmonic and power quality problems. So we have to be able to measure the 50, 60 hertz section. We have to be able to measure and consider the DC intermediate section, like in this case, the motor area. Okay. Oh, now it froze. There you go. So we have to be able to identify if there is any form of interference, and the usual interference will be coming from this place. You will have DC influences in your AC system, and this is where you start having a little bit of harmonics and so forth. Yeah, right. So there you have your 0 to 100 hertz interference rejection as well. Okay, now I will be jumping. This is basically the measuring principle of how they start measuring leakage capacitance using the insulation monitoring device, right? When you think about it, it's kind of like an active harmonic filter, similar to an active harmonic filter, where the system will actually look into the waveform and then re-inject that only in reverse polarity. That's pretty much how active harmonics filters work. And why is consideration of leakage capacitance important? Now, before we go into that, let's identify the causes and sources of leakage capacitance. You have the natural capacitances, which is like, cables, wires, insulation, design, system size. The larger the system is, the higher the leakage capacitance. Now, and that's also one of the reasons why, in accordance to IEC 60364, that your isolation transformer should be no more than 10 kVA. Now, when I thought about it the first time, what the heck can I put in a 10 kVA little transformer, right? Apparently, even the OR lights is a different transformer altogether. Okay, and maybe we can talk about that later on, just because this is predominantly because of leakage capacitance. Now, going back to this slide right here, is you also have artificial capacitances, you have the anti-noise capacitor, quote-unquote passive harmonic filters, and EMC filters for higher frequencies. Now, this is the importance of being able to measure leakage capacitance. The higher the leakage capacitance, based on this little formula right here, the longer it will take for the monitoring device to be able to give you a measurement. Somewhere in the IEC standards, they say that at least for industrial applications, you should be able to give out a result, a measurement within 30 minutes. That's quite a while. That I don't think that's going to work in hospitals. No, it has to be a little shorter than that. Although, like for the purposes of Bender as a brand and as a product, they were able to come out with new devices out there, even in high leakage capacitance systems, that they can actually give out a measurement in about 8 to 12 seconds. So it becomes pretty fast for them. No? So as you can see here, just plug in the numbers. The bigger the capacitance, the longer you have time to be able to measure. Now, insulation monitoring also works for DC, not just for your AC system, right? But differentiate that from cars where you have the negative as to also your ground. No, so it doesn't. That's a grounded DC. Now, in DC systems, basically what the IEC requires under 61557-8 is that an insulation monitoring device should be able to discriminate between symmetrical and asymmetrical faults. That means it should be able to tell you whether it's on the negative side or on the positive side. There you go. Now, what are the effects of these DC leakage capacitances and extraneous DCs in the AC system? Number one, DC faults render RCDs and GFCIs unreliable, right? They can increase exposure of fault currents of up to 50% of the set point of your GFCIs. The extraneous DC voltages can appear in the fault path, creating a false insulation resistance measurement. Extraneous DC fault current beyond 10 milliamps can falsify reactions of sensitive PLCs, and failure to isolate these DC faults can result in pre-magnetization of relay contactors and can affect the reliability of the AC protection system. This is, of course, for extreme instances and situations. Now, those DC faults that I've been talking about, they would usually come from. Sorry, go ahead. Okay, it's okay. Anyway, now these DC faults are, they're usually influenced by a lot of those thyristors reactors. Quote unquote variable frequency drives. So you have that. Now the most common sources of DC faults in variable frequency drives are the RFI noise suppression systems. No, the noise suppression filters inside the VFDs. That's where they usually come from. Now here's a conceptual model of an insulation monitoring device. This is for a small three-phase system. This is an older insulation monitoring device that I have here. So let's assume that there is a fault somewhere in the system. Something burns. Your insulation monitoring device should be able to give you a measurement right away. So as the screen says, it's at 10 kilo ohms. So that's the second alarm already. So becomes critical fault. Now, what if this was a slightly bigger system? And then, okay, great, you found, you know that there's a fault, find it. And this is where we start using insulation fault location systems, right? These little boxes basically are connected to zero sequence CTs, which is proprietary to Bender, where you have all three phases inside the CT. And then remember, I did mention a pulse current that flows there for hospital systems. Did I hear you say my name? Sorry.
Sir Jack, there are some comments. Your slide is not moving po, sir.
My slide is not moving? Really?
It's stuck on common things we hear. Yeah. Thank you, sir.
Stuck on common things we hear. Are you serious? Let me just reshare that. You guys see my slide? My slide now?
On my answer, still stuck on common things we hear. I don't know on the other participants.
Really?
Yeah, it's the same here. Also, common things we hear.
We're still at common things we hear. That's like the second slide.
Yes,
all right. Okay. Now, screw it. Forget the slide. Forget the slide. Never mind about the slide. It's okay. Here's what we're gonna do now. This is what we're gonna do instead. Okay. You guys see my video though, right? You guys see my video?
Yes, sir.
Yes.
All
Your
right.
video is coming fine, sir.
That's what we're gonna deal with now. If I start doing if I start doing this, what do you guys see? Do you guys see a screen that I share?
There you go, sir. It's COM460 IP.
Now you see it. Anyway, all right, it's okay. No worries, guys. We'll make it as fun as possible. Now, I am going to have to stand up and show you something at my back. Gab, can you focus on this little thing right here? Okay, so what we have here is a, give me 1 second. I know you probably can't hear me well. You guys hear me?
Yes, sir.
All right, great. Okay, so what we have here is something that we actually built for demonstrations and displays for. This is specific for hospital systems. Although I don't have an actual transformer inside, no, but what you can see here is basically, at least on the diagram, you have a transformer. It has a CT because the insulation monitoring device will also have to measure the loading of your transformers. It has a temperature sensor because, of course, more loading, more heating. So it will measure insulation monitors as well as the loading of the transformers and the temperature of the transformers. I also have a fault locator here and a gateway. Now, with the IEC system, you basically have your transformer, an insulation monitoring device, and an annunciator, right? So basically the annunciator is the one that's seen inside the OR. Now that's the only thing that's seen in the OR. The transformer and the IMD doesn't have to be showing up there. Now, one of the main differences between the LIM, the line isolation monitor, and the IEC insulation monitoring device is that the LIM has to be mounted in front of the panel, close by the transformer, and that's the reason why it's a little cheaper than the IEC system, right? Because with the IEC system, you can have the transformers further away in an electrical room somewhere on the same floor, no, and only having this show up in the OR. No? So it becomes that. Now, what I am going to do is come up with a few things. I'll be pressing a few things. So you should be hearing an alarm. And then next thing I will do is actually share my screen again. Share my screen again and show you what I mean with monitoring. Now, you actually see this, the one that actually turned red, the ISOMED 427. If I click on that, you will actually see that I have warnings in terms of lower insulation. I have a load warning of the transformer of about 109%. I have over temperature and I have an insulation fault, right? Now, with the insulation fault, I can actually start determining that on the EDS 151. That is my fault locator. And you will see that it actually measured like 500 microamps. So it becomes very sensitive. Okay. So now, usually what happens is that the medical staff don't really mind what these things are. They wouldn't mind what these things are. They just know that there's an alarm. They're going to tell the facilities guys that, yeah, I do have a problem somewhere. Now, what we did here is we connected this via a small LAN network. It doesn't require any form of internet connection. As you can see, I'm on Google Chrome. No, I'm on Google Chrome, and then I just connected. The software is already included in the device, and I can access it. Even the facilities guys can start looking into their system, having that monitoring thing going on for them. Okay, so well, since you can't see my slides a while ago, I'm gonna have to conclude this soon. Now, in terms of the conclusion, insulation monitoring devices, any monitoring devices out there, may it be for power quality, no, or safety, takes out the guesswork in our system. We can identify immediately by measurement alone that we have a problem. No, we can identify that. We can pinpoint where it's coming from. That's the whole idea of monitoring advanced information. No, we have to be a little more proactive in terms of the maintenance and the maintenance of our system, and less reactive. So that would be the main goal right there for insulation monitoring devices, pretty much. Okay, just to give you an idea, for grounded systems, we also have what we call residual current monitoring devices, RCMs. I do have a pre-alarm here. We did mention about harmonics a while ago and power quality. It's loading right now. No, we did mention about that. Now with residual current monitoring systems, what we can do is we can actually identify leakage current due to harmonics. That means now we can identify the kind of loads that's actually giving out these kind of problems. All right, so I will end it there. And if you guys have any questions, I'll be more than happy to answer them if I can, right? That's it for me.
Yes, Sir Vincent.
Sorry about the slides though.
Yeah, but anyways, you more than made up for those technical glitches po. We had a very, very interesting presentation then, no?
Thank you.
Demo unit of the IPS po, no? So, yes, if you may po, we have, I think, let's see in the chat box. So, ito kay coming from Engineer Roel Pancho, no? Hi, sir. All of these leakage detection tools advisable to be utilized for substation monitoring for tender personnel only?
Well, for substation monitoring, it's a totally different scenario altogether, no? For substation monitoring, we can use this for the DC circuits, no? For the DC power supplies. Okay yun. But if we're talking about transformers, then there's a couple more different things that we can use. You can have bushing monitors, you can have online dissolved gas analyzers and things like that. But for specifics of insulation monitoring, no, let's say you have a delta secondary, kunyari, and it's no more than 25 kV, then yeah, we can measure that, no problem. We just have to use a coupler. But if you want to fault locate, because the CTs will only have I think up to 1 kV, 690 or 1 kV, depends on the model, 690 or 1 kV insulation level. So we cannot handle the more than that. So mas magiging problema siya rather than a solution. But for the DC circuits, definitely we've done that a lot already, no, for the DC circuits.
Okay.
Yeah.
So so it's for DC circuits. I have a personal question po.
Go ahead, sir.
Vincent, this insulation monitoring, do you have portable types po?
Yes. Yes. But the portable ones isn't exactly an insulation monitor. No, the portable one is actually a fault locator, which is a handheld fault locator. I should have that. Yeah, it's right over there. It's at the back. Gab, do you mind grabbing that for me? Yeah, it is a portable fault locator. It kind of looks like a clamp meter. No, it kind of looks like a clamp meter that you just clamp on all three faces. It comes with a flexible unit as well. Can you just lie it down here for me, Gab? Thank you. Yeah. So they kind of look like this. I have a bigger CT. No, they kind of look like this. It works on both. It works on a couple of things, both grounded and ungrounded systems. For for ungrounded systems, for us to be able to determine where the fault is, now you can use either residual current method or a pulse generator. No, in this case, I can use either a 10 milliamp pulse or a 25 milliamp pulse. Although switching between 10 to 25 milliamps, we have to be careful. As I mentioned, if there's a lot of PLCs in the system, you don't want to go 25 milliamps. However, if the fault is still medyo high ohmic resistance fault, and you're just for the whole system, you're just like 30 kilo ohms pa, or 36 kilo ohms, 35. It's pretty hard to find it with 10 milliamps lang. No? So sometimes what we would do is we would use a residual current. The way residual current works basically is the way a GFCI would work. No? So I1 plus I2 plus I3 dapat 0. But since there is no perfect insulation anyway, depending on your protection goals, we measure yung residual current. So pretty much the same way a GFCI would start measuring. Yeah.
Okay. So again, okay. I think there are no more other questions po.
Any budgetary cost, sir?
Budgetary cost for what system? A hospital maybe, or
Yep, for monitoring in the OR.
monitoring of OR? Yeah.
Hi, Jack. This is June Lopez.
Hello, sir. Kamusta ka? I miss you. Hi, June. Anyway, the typical budgetary cost for a relatively small system, without the fault location, would be somewhere in the region of about roughly, I think definitely less than 750,000.
Okay.
Yeah.
So, ballpark figure. Okay.
That's a
Thank
ballpark
you.
figure. Yeah. Thanks,
Thank you very
June.
much. Bye.
All right, June.
So in my understanding, Sir Vincent, these devices are applicable to those who have isolation systems, the
Yes.
hospitals.
Yes.
And grounded, isolated systems.
Yeah. Well, a lot of times the hospitals would usually be grounded, right? They would definitely have neutrals there somewhere, and that's the purpose of the isolation transformer. Is that we isolate the OR from the noise of that ground right there. No, so that's the purpose of that isolation transformer. Yeah, so it will require an isolation transformer, an insulation monitor, at least for the IEC system, an insulation monitoring device, and that little annunciator. But for the LIM, the line isolation monitor, you would have the whole panel inside the OR. No, it's quite similar naman. It's quite similar in the sense that you can actually measure loading and whatnot. The only difference kasi is that the LIM measures ground impedance, and it calculates also the AC sine wave that goes with it. And that's sometimes the argument between IEC and NFPA. The IEC says that we are a direct measurement. No, we are a direct measurement. You're a calculated measurement. But both things work. I guess depends on the kind of standards that we follow. You know what? In terms of standards, I'm gonna call someone here. Come here, quick. I have someone here just to talk about the standards because he knows better. There.
Okay. Yeah.
I'm here.
Oh, it's your dad.
Standards. I don't want to get caught into the standards. He does that.
Yeah, he knows very well po, standard.
So not unless you have any questions for him.
Yeah. My question lang po, another personal question is, yung LIMs natin, sir, are they not susceptible to leakage ground currents that are produced by nonlinear loads? Maybe because of frequency, to change, it would increase leakage current.
Can I take this real quick?
Sure.
They will be in extreme instances. It is assumed, it is assumed that the isolated power supply is already a little clean. No, not unless we have a lot of noise. Because a lot of the big equipment also, if you have a hybrid OR, the big MRIs, the big X-ray machines would have their own transformer. And dapat medyo malinis na yon. But we've seen insulation monitoring devices fail because of noise. And a lot of them, the noise, kasi may nakita ako in one of the provinces where for some strange reason, sa likod nila is a transformer, galing ng utility, I think they own it. Parang ang kwento is that may partial discharge na yun, and the RFI produced by that, tamaan na yung IMDs. So it kind of failed on that, and it wasn't measuring properly.
So what would be?
Well, if I can add, it's something like this. What is important to see is that when we have this kind of noises, we have the kinds of noise. So that means the line or the equipment itself generates a lot of noise. Now, when we measure the harmonics of the lower orders, like from 3rd to about 64th order, that's okay. But sometimes we do not actually eliminate practically all of those harmonics present. Now, if you look into, say, X-rays or even MRIs, the noise is quite high. So even if we reduce or I would say, mitigate the harmonics level generated by those instruments or equipment, sometimes it requires more higher, I would call it higher noise mitigation. And that is also part of filtering. So iba ang solution doon sa higher noise, which is nasa gigahertz, and yung isa naman nasa megahertz. Kaya kuminsan may dumadating sa aming questions, what do we use then? Meron kaming ginamit dati niyan, which is good. Kaya lang medyo mahirap itatawagin nating justify because sasabihin nila, bakit nakakabit na itong aming filter dito? My unit still having some sort of problems. Now, upon measurement, that's why meron kami pang measure ng higher level of noise. Apart do sa lower, di ba, Jack?
Yeah, beyond the 63rd order.
Yeah,
because the typical power quality analyzer will measure up to maybe the 51st, 61st. We have this device that can measure beyond the 63rd, the one that actually affects the hysteresis of your sinusoidal waves sa AC waveform.
Ano yan, medyo malawak siya. Kaya magandang pag-usapan yun sa hospitals because most hospitals that we have visited, talagang meron silang tatawagin ng deficiencies. Tapos hindi nakikita ang importance ng isolation transformers design. Ang kanilang transformer, akala nila pag naglagay ng isolation transformer, the bigger the better. Hindi laging ganun yan. Mayroong maximum allowable capacity in order to minimize the leakage current or leakage reactance or capacitance of the entire system. Kaya yun napaka-importante doon. Yeah. Ang most hospitals na bisita namin are walang ganyan. So ang ibig sabihin sa design pa lang, meron ng deficiencies. Kaya ngayon ang sinasabi namin sana, and we are the only country in the world, I mean in Asia, that does not follow IEC standards, practically.
We're following NFPA.
NFPA. And kasi American standard na ating utility. So ang talagang ginawin NFPA, which is also good, but makikita nyo ang approaches nila sa computational aspect is different. Kaya sa buong mundo, lahat ng hospitals, lalo sa Asia Pacific, are compliant sa IEC standards. Lahat ng hospitals na pinipresent sa amin sa Asia Pacific,
China, Indonesia, Hong Kong.
Yeah, lahat sila IEC. So, ang protection natin para sa NFPA is also good, but we are not compliant to IEC. Yun ang kailangan siguro nating ayusin kung pwede natin gawin yan.
So it will be work in progress siguro po.
Yeah. Yeah. Nasa design aspect eh. Nasa design aspect. Lalo doon yung application ng mga devices in order to kasi I'll tell you one story that we have actually did. We have one client who had called several service providers, and this is a ano ito?
Dialysis.
Dialysis.
The one in my
yung dialysis. You know, so they called us up after talking to so many service providers, and when they tested the entire network of that dialysis clinic, said, ang problema nila is hindi nila ma-determine kung anong problema. So when they came to us, we told them, okay, we will measure it based on sa aming analysis, at nakita namin ang measurement ng leakage current. No one ever measured the leakage current of that network. None. All of them were using IR or insulation resistance.
And the thing was that system was grounded.
Exactly.
So dialysis minor invasive grounded system.
Lahat ng kanilang pasyente, pag nai-injectionan sila nung ang pakiramdam na para sa electrocuted. So we measured the leakage current of the entire network. And we measured it to be high. Nasa ilan, Jack? Ilan yun?
At an average about 230 to 240 milliamps.
Ang taas nun, pwede ka talaga mamatay doon. And so,
grounded.
And no, what we found out, that the owners told us that there was flooding in one of those times, and I think most of their wires are
nasa floor,
nasa slab, below the slab. Eh, hindi nila alam yon. So for such a time, siguro water penetrated and some of the wires had been deteriorating, kaya tumaas ang kanilang leakage current. Now we told them to replace all of them, and then put up all the wires, push in a raceway, and change the whole thing. Then we measured after that. Ano naging measurement, Jack? One?
Definitely less than 5 milliamps.
Less than 5 milliamps. So that means after that, wala na silang nakita electrocution feeling. So ang ibig sabihin niyan talaga, insulation measurement is not purely on IR. We have to measure something like the leakage current, which is very, very important. So, and we have that capability to do it. Yun ang naging diferensya nung pagtingin. Kaya right now, when we are doing this kind of measurement, we can also measure insulation resistance of a network online without having to disconnect. That's like what we do before. We have to disconnect, we have to measure the IR, and so on and so forth. Now, we don't need to. We only measure the leakage current, and once the leakage currents go beyond the accepted level of safety, then sasabihin namin, I think your insulation is already deteriorated or deteriorating. So alam na namin na pwede namin sabihin na, okay, please replace this, or you might have some problems. And also that becomes already a problem of having your system on fire. Yun ang nagiging malaking issue dyan. So yun ang aming palagi nire-recommenda. Kaya nga, when I heard that Jack is speaking on this kind of a talk, I told him, pwede ba ako sumingit? Kaya nakasingit ako, ha?
All right. I mean, I think we're taking up too much time of the next speaker. Sorry.
Worth it naman po.
Yeah, we can wrap this up.
But it was really worth it po. We had Chairman Rudy here, no, to enlighten us further, no, about the alliance.
Pandagdag lang yun. Pandagdag lang. All right, Jack.
Oh, that is it for me. Gentlemen, thank you for spending your lunch with us. And IIE, thank you. Yeah, and to my esteemed colleagues who spoke before me, thank you very much for laying the groundwork for me.
Yeah, and if you have some questions that you will want to know from us, write us, call us, and we'll help you.
Okay, so there you have it, the chairman himself, no?
Thank you.
Thank you, guys.
Thank you po.
Bye.
Twin Towers. Okay, so at this juncture, may we have the privilege to present our certificate, no, of appreciation to our presenter, Mamiela, and we have that on screen. Okay, not so clear at my end, anyways. Okay, so IIE presents this certificate of appreciation to Vincent Jason Peñalosa for imparting valuable insights as sponsor technical presenter on the topic, Knowing Today What Will Never Happen Tomorrow, Electrical Safety in Hospital Critical Care Units. During the 46th Virtual Annual Convention with the theme, Got One IIEE at 46, Transcending the Challenges in the New Normal, by embracing resiliency and complementarity, held on November 22 to 27, 2021 in Manila, Philippines, by a Zoom video conference. Given this 25th day of November 2021, signed by Engineer Alberto R. Herrera Jr., National Secretary, Engineer Roland T. Vasquez, National Vice President for External Affairs and Exhibit Bureau Director, Engineer Lyndon R. Bage, National Vice President for Internal Affairs and Convention Bureau Director, and Engineer Alan Anthony P. Alvarez, National President. So with that, may we give Engineer Sir Vincent a round of applause, please. Thank you, sir.
Thank you very much, guys. Have a good afternoon.
Okay, thank you very much. So at this juncture, may we, I will give you back to Ma'am Yela for our next part of our program. That's it for me, Yela. Take it away.
Thank you so much, Sir Jack, and of course, to our very energetic member of the CPDC and Technical Sessions Committee, Engineer Brian Pasilan. So while we are waiting for the next resource speaker, we'll have a short break.
The nation erupted into scenes of chaos.
Action! na lang. Sige lang, ma'am.
Hello, good afternoon. What an electrifying afternoon to everyone. So welcome to the second half of our technical sessions. So without further ado, I would like to introduce our resource speaker for today. He is currently the Assistant Director of the Energy Policy and Planning Bureau of the Department of Energy. He supervises the formulation and updating of the Philippine Energy Plan and regional and provincial energy plans and programs for major islands and provinces, including the energy demand and supply outlook, as well as the conduct of policy research and studies. He had also worked with the Asia Pacific Energy Research Center based in Tokyo, Japan, as a visiting senior energy economist for more than 3 years. His primary involvement was in the formulation of the APEC Energy Demand and Supply Outlook, specifically handling energy investment, renewable energy, and the Philippines Energy Outlook. He was likewise designated as the project coordinator for the APEC Oil and Gas Security Initiative, covering the conduct of research and studies related to oil and gas security, and simulation or exercise on oil and gas supply disruption and emergencies. He also spent his career in the academy with 10 years of teaching experience handling economics and taxation projects. Ladies and gentlemen, let us all welcome our resource speaker from DOE, Mr. Michael Sino Cruz. Sir Michael, good afternoon.
Yes, good afternoon. Thank you for that kind introduction. Good afternoon to everyone. So I'll be sharing my presentation. So can you now see my presentation? Excuse me.
Spotlight there.
Is now okay? So can I now start my presentation?
Yes, sir.
Okay.
Visible.
Okay. Thank you. So good afternoon again to all the participants of this IIEE's 46th Annual National Convention, and allow me to present before you the recently formulated Philippine Energy Plan. We just completed this and now uploaded in our website last October. So my outline, my presentation will cover 4 parts. I will start by defining what the PEP is and the policy frameworks considered in its formulation. I will also highlight the 2020 energy situationer and then the 2040 energy outlook, as well as the sectoral plans and programs, and lastly, the required investments as indicated in the plan. So the Philippine Energy Plan, or what we call the PEP, serves as a comprehensive roadmap of the Philippine energy sector that embodies the country's major plans and programs in consideration of energy trends and development, as well as the action agenda to respond to emerging energy challenges as well as issues. And what we currently have right now is the PEP 2020 to 2040. So the PEP is anchored on our goals of the Philippines or of the country, the ambition natin 2040 or our aspirations for 2040, which represents the collective long-term vision and aspirations of the Filipino people for themselves and for the country in the coming years. And in support of this aspiration, we have formulated the 9-point energy agenda, which focus on providing access to electricity for all Filipinos improving the reliability of the country's electricity supply, promoting energy efficiency, and establishing a pro-consumer framework, among others. Likewise, the PEP supports the United Nations Sustainable Development Goals, or what we call SDGs, specifically the SDG 7 on affordable and clean energy. So as you can see here, energy is at the core of the SDGs as it connects and support the other goals such as the addressing poverty, economic growth and development, infrastructure, industrialization, reduce inequality, and climate change, among others. So this is just showing the major contents of our recently formulated PEP. So let me now discuss with you our current energy situation, the 2020 current energy situation of the Philippines. The Philippines' total primary energy supply, or the amount of available energy used to generate electricity, mobility, to process heat, among others, in 2020, already considered the impact of COVID-19. And in 2020, our primary energy supply reached around 56.4 million tons of oil equivalent, or what we call MTOE. This is about 6.2 lower than the 2019 level of 60.1 MTOE due to the country's or economies slowdown as a result of the pandemic. Our self-sufficiency level, meaning in terms of the share of our indigenous energy resources to total energy supply, in 2020 was at 53%, representing the share of our local energy resources. So with the 34% share of RE in 2020, so the Philippines remains as the highest, or with the highest RE share in the primary energy supply among the ASEAN member states. And this puts us as at the forefront of the sustainability policy in the region. So let me now go to the total final energy consumption. So in 2020, the country's total final energy consumption was recorded at 32.4 MTOE. This was a decrease of 10.4% from the 2019 level of 36.3 MTOE. On a per sector basis, sa left side of the slide, only the household sector and non-energy use posted an increase in 2020 at 3.3% and 11.2% respectively. And on the right side, on per fuel basis, all fuels exhibited a decrease in 2020 when compared to their 2019 levels. So with regard to power sector, the country's total installed generating capacity in 2020 increased by 3%, reaching around 26.3 gigawatt from 25.5 gigawatt in 2019. So the additional capacities here that augmented the existing supply came from new coal and renewable energy power plants. However, our power generation declined by 4%, as shown in the here sa right side of the slide, in 2020 at 102.8 terawatt hour. So this was attributed to the decline in electricity demand in 2020 as a result of the pandemic. Let's now go to the outlook. With the slump in energy demand experienced in 2020, so the country is now looking at or anticipating the increase in its energy consumption in response to economic trajectory until 2040. And as such, under the reference scenario, because under the Philippine Energy Plan, we formulated two scenarios, one of which is the reference and the other one is what we call the clean energy scenario. So under the reference scenario here, the total final energy demand increases at an average rate of 5.8% annually from its 2000 or 2020 level of 32.4 MTOE. It will reach to 100.3 MTOE in 2040. Transport and the industry sectors will account for the bulk of the increasing demand between 2020 and 2040 and will register the fastest growth rates, followed by services and then the agri sector. By 2040, the petroleum demand accounts for the share of 57% in the energy mix by 2040, while electricity increases its contribution to around 26% in 2040 from 22% in 2020. So given the expected gains from the energy efficiency and alternative fuels, because under the Philippine Energy Plan, specifically for the clean energy scenario, we set a target for the renewable energy to reach 35% share in 2030 and then 50% share in 2050 in our generation mix. Aside from the RE targets, we also set a target on additional energy savings from our energy efficiency and conservation measures as a result of the recently promulgated Energy Efficiency and Conservation Act of 2019. And aside from that, we also included a target on the penetration of other alternative fuels under the clean energy scenario, specifically the electric vehicle. So given all of this, the impact of such would be there will be a 5.9 MTOE difference between the reference and the clean energy scenario. So we'll have a lower energy demand for under the clean energy scenario as an because of the impact of as I mentioned earlier, the energy efficiency, the penetration rate of alternative fuels under the clean energy scenario. So here, the transport sector contributes bulk of the decrease at around 56% or 3.3 MTOE of the 5.9 as the level is reduced by 9%. While the entry of alternative fuels such as electricity, natural gas, and higher biodiesel blend coupled with the energy savings in the consumption of oil products, it will contribute to an aggregate reduction in oil demand of around 8.6% between the reference and the clean energy scenario by 2040. So this results in a considerable volume of diesel and gasoline being displaced by alternative fuels for transport, specifically biofuels and electricity. On the other hand, electricity will increase its share to in the final energy consumption with more electric vehicles in our transport sector. It should be noted here that the reduction in electricity consumption from the 5% energy savings as targeted here in the Philippine Energy Plan is to be offset by the increase in the transport sector's demand for electricity because of the penetration of electric vehicles under the clean energy scenario. So when it comes to power, the aggregate RE capacity here dominates the capacity mix of the country in 2040, both under the reference scenario and clean energy scenario, driven by the significant capacity addition from hydro, wind, solar across the planning period. While natural gas here also figures predominantly or prominently in the capacity mix. So as a result, the dependence on coal power plants is effectively reduced. We issued a coal moratorium, I think in 2020, to be able to to facilitate the entry of more flexible fuels and more of renewable energy. So in this Philippine Energy Plan, because of that coal moratorium, we only considered here the committed coal power projects, because under the coal moratorium policy of the Department of Energy, there will be no issuances of or approval of new greenfield coal power plants projects. Only those committed and indicative or committed power projects, as well as the indicative ones with substantial progress when it comes to permitting processes, or they have already secured other certificates, among others. So that will be exempted from the coal moratorium. So given the capacity addition under the reference scenario, the total gross generation here, as you can see here, sa left side of the slide, this is the generating capacity. You will notice here that under the reference scenario, the required capacity, total capacity addition will reach around 95.7 gigawatt from only 26.3 gigawatt in 2020. So with regard to clean energy scenario, the capacity addition, the total capacity is about 30% higher compared with the reference scenario. We will be requiring around 118.6 gigawatt for the clean energy scenario. So why? This is because of the entry of more renewables, specifically variable RE, solar and wind. So given the capacity addition under the reference scenario, the total gross generation increases by 6.6% a year, from 101.8 terawatt hour in 2020 to around 364 terawatt hour in 2040. So under the reference scenario, the natural gas here contributes the bulk of the country's power generation mix, about 40% share of natural gas in 2040. Meanwhile, the aggregate share of RE is at 35%. In this scenario, under the reference scenario. While the generation under the clean energy scenario registers a 6.5% average annual increase. This is due to the impact of our clean energy efficiency. So our requirement would only be 357 terawatt hour compared with the 364 terawatt hour in reference scenario. So despite the slowdown here of our generation vis-a-vis the reference, the mix of energy resources significantly changes under the clean energy scenario in 2040, specifically expanding the share of RE to 50% of total generation mix. And as you will notice here, right side of the slide, the pie chart, from the share of coal of more than 50% or 57% in 2020, under the reference, it will go down to almost 25% under the reference scenario, and it will further reduce to 23% in the clean energy scenario. With all these targets that we included in this plan, it will bring us closer to our goal as outlined in our Philippine Energy Plan, which is towards a sustainable and clean energy future. So we can see here that the transition from clean to clean energy scenario will come in as early as 2027 or 2028 under the clean energy scenario. If we go to look at the regional landscape, the Asia Pacific Economic Cooperation, or APEC, has also set an aspirational target to reduce aggregate energy intensity by 25% in 2030 to 45% by 2035, based on 205 as the reference period. While the ASEAN, they have this ASEAN Plan of Action for Energy Cooperation, or what we call APAEC. So 2021 to 2025 also sets a target on the reduction in energy intensity of 20% by 2020 and 30% by 2025. And as you can see here, the Philippines is able to achieve these reduction targets for both scenarios, reference and clean energy scenario. The ASEAN APAEC also recognizes the importance of RE. So there is also a target on RE under this ASEAN APAEC, and the target is 23% RE share in total primary energy supply and 35% share of RE in ASEAN installed power capacity by 2025. If you're going to look at the right side, the bar chart here, our RE share for 2025 indicates that we have or we will able to exceed the target under the ASEAN. So our 2040 target is clear. We must be able to have a sustainable, stable, secure, sufficient, accessible, and reasonably priced energy. And the achievement of this goal lies on the development of the 6 major energy subsectors identified in this slide. So when it comes to RE, although we have issued a coal moratorium, we are still keen on expanding our indigenous energy reserve and production of petroleum and coal. As I mentioned, while we issued a moratorium on coal, we still consider coal and oil as vital energy resources in the country's energy supply security. We also must admit that so we must also admit that the Philippines is an energy hungry nation, that we have yet to achieve the energy security, supply security. That's why we are open to all available resources and technologies to be able to enhance our energy security. However, we are also considering the environmental issues surrounding these energy projects, as we are now encouraging hybridization of conventional energy plants with the clean energy plants, clean energy such as renewable and natural gas, to balance the effects to the environment. For downstream sector, both oil and natural gas, we do have a plan to possibly establish a strategic petroleum reserves, which will help the country in times of oil volatility in pricing and supply. We are now forging partnerships with several institutions to foster cooperation and information exchange, as well as reconciling data initiatives. Such we have now a partnership with the Bureau of Customs and BIR to be able to prevent oil smuggling as well. We are also banking on the establishment of a world-class, investment-driven and efficient natural gas industry in the Philippines. We see that natural gas is the fuel of the future. And we hope that the facilities being put up in the country right now will help us attain energy security, and that we can still make our country the next LNG hub of the region, the Asia-Pacific region, given our strategic location. And in preparation for this, we are revisiting existing standards and coming up with new standards to ensure safety in operating gas facilities and maintain the quality of gas products. We do have the what we call the Philippine Downstream Natural Gas Regulation, which is being enforced, and we also have this gas policy development project, which shall be implemented to provide various technical assistance to the government and increase awareness on the natural gas industry's role in the energy development. So, so to further propel the country's energy transition towards a clean energy future, no, the government continues to accelerate and the development and utilization of renewable energy. So the DOE will implement the National Renewable Energy Plan or NREP covering the period 2020-2040, which will be launched within the year. And this plan seeks to increase the 1% renewable portfolio standard, or the RPS, to meet the target of 35% and 50% share of RE in our total power generation mix by 2030 and 2040 respectively. Likewise, the open and competitive selection process will remain a regular activity to identify areas suitable for RE resource development. So the DOE will continuously implement relevant policies under the Philippines Renewable Energy Law, which include the RPS for both grid and off-grid, enhanced net metering program, the green energy auction program, the green energy option program, and then the renewable energy market, among others. So we have continued our collaboration with local and international development organizations to pursue this initiative in renewable energy, and in recognition of the vital roles for knowledge exchange and promoting the development and utilization of renewable energy. On power, we need to establish a more flexible and interconnected smart grid for all the areas in the Philippines, so we can have an optimized energy system across the different island grids across the country. This is part of our commitment to ensure 100% electrification for all our households in the country, so that no one will be left behind with the advancement in the energy industry. And to achieve this goal, the DOE shall continually improve its existing electrification strategies, utilize advanced and emerging technologies, and adapt to innovative solutions. On energy efficiency, we must also ensure that energy being produced will be utilized efficiently. Thus, the need for a good demand-side management, which is incorporated and specified in the Energy Efficiency and Conservation Law of 2019. So we have been implementing energy conservation practices for a long time as the government's energy policy making body. We aim to fit to mainstream the efficient utilization of energy across all sectors. So aside from the usual programs like the energy labeling, energy performance standards, and rating systems, we are pushing for a digitized energy consumption monitoring and evaluation process, as well as the development of green infrastructure investment and incentives. For alternative fuels, we gear towards our future by expanding the development and utilization of our alternative fuels through the specifically for the transport. So the deployment of applicable alternative fuels and emerging technologies for transport will provide the people access to cleaner and efficient technologies for better environment. So we are currently undertaking the current activities that we are undertaking right now include the electric vehicles, hybrid vehicles, increased biofuels blend, and including hydrogen and even nuclear. So to promote and develop the domestic EV industry, we issued a policy in 2020 for an equitable, non-discriminatory, and open access to all manufacturers, importers, distributors, and dealers of EVs and EV charging stations. We also issued a policy providing the guidelines for the development, establishment, and operation of EV charging stations in the country. So the potential for utilizing clean energy sources such as nuclear energy and hydrogen is also being explored and studied. The DOE is looking at hydrogen as another viable alternative fuels and clean energy source of energy for the country. And as a jumpstart, we did a study in 2020 regarding the hydrogen potential development of hydrogen in the country. We also have entered into a partnership with two private companies, one company in Australia and another company in Japan, to co-work in exploring the use of hydrogen as a fuel for both for power generation and for transport. And for nuclear energy, we aim to develop a comprehensive strategic communication plan that addresses stakeholders' issues to effectively mitigate the negative perception on nuclear energy, which is still prevalent despite the present technology and access to information. So with all this, the energy sector, the scenarios under this Philippine Energy Plan, as I presented earlier, so we will require an overall energy investment of about 153 billion. This is under the clean energy scenario. And this estimated investment will finance the upstream, downstream, and then the power sector infra facilities requirement. Specifically for the construction of additional power plant here, we will be needing around 115 billion US dollar. And I think 80% of this investment in power generation is for RE. And as you can also see here that the share of power sector in the total investment requirement that is needed by the country is around 80%, followed by the upstream 15% and downstream 5%. So given the capital intensive nature of the energy sector, we anticipate a more active private sector participation and even a public-private partnership to help us finance and bring in these infrastructure facilities to be able to meet our targets as is stipulated or included in this Philippine Energy Plan. And as my last slide, while we have encountered challenges in the past, specifically during this pandemic, we believe that the plan we have set for the country will enable and support the Philippines' goal for a strongly rooted, comfortable, and secured life for the Filipinos. And with that, we'd like to invite our partners from this association in this journey towards a sustainable and clean energy future. So thank you very much. And for your information, the Philippine Energy Plan, you can access this plan from our DOE website. Again, thank you very much and stay safe.
Hello, sir.
Yes.
Thank you very much, Sir Michael, for that wonderful presentation for today. Sir, are you open for questions po?
Yes, yes. Definitely.
Okay, sir. So there are 3 questions in the Q&A chat box, sir. Allow me to read the first one. Is there a bill or an act that supports for the use of renewable energy? There are many industries that affect climate change. One is a coal power plant. Are there new power plants that will be installed other than the coal power plants?
Okay, so thank you for that question. As I presented earlier, we issued a coal moratorium. So the coal power plants that will be coming in the coming years will only be those committed projects. And even the indicative, some of the very few indicative projects which already achieve some progress in their permitting, so gumastos na sila. So therefore, we need to allow them to build and operate the plant. So in replacement for the coal, so we'll be expecting more renewable energy to come in as well as natural gas. So we need natural gas as a transition fuel to be able to support the entry of more variable RE. So we all know that when you talk of solar and wind, there could be an issue on the reliability because of lower capacity factor, lower capacity credit, among others. So and then we are continually studying the possibility of introducing hydrogen for power generation and transport. But some experts would say that using hydrogen right now for power generation is still expensive, not unless we do have a cheaper source of electricity to be able to produce hydrogen using electrolysis. And we are also looking at nuclear, if we can still reintroduce nuclear energy in our mix. There is a NEPIO right now, the Nuclear Energy Implementing Organization, which was established way back, I think, in 2017, to be able to look at the requirements, the 19 infrastructure requirements as under the International Atomic Energy Agency. So this is a requirement that we need to satisfy these 19 infrastructure requirements before we embark on nuclear energy. So one of which is yung human resource, our siting, our waste, the community involvement, among others. So dapat masatisfy natin yung 19 infrastructure requirements na tinatawag ng IAEA, the International Atomic Energy Association Agency rather, before we embark on our nuclear energy program. Thank you.
Thank you very much, sir. So proceed to our second question. Sir, is there a plan for reviving, or we say to activate, the Bataan Power Plant?
Well, we received several proposals to be able to revive the Bataan Power Plant, but right now, we cannot decide yet because we are still waiting for the executive order coming from the Office of the President approving the nuclear energy program for the Philippines. Once this said EO is issued by the President, then we can entertain these several proposals that we have received to be able to revive the Bataan nuclear power plant. We received a proposal from Russia, Rosatom, looking at reviving the nuclear, the Bataan. We also received a proposal from KEPCO, Korea, although there was a feasibility study before done by KEPCO of Korea way back in, I think, 2012, 2013, or 2014. I forgot the year. So it was specified there that the Bataan nuclear power plant can still be rehabilitated, but the cost of which would be around $1 billion to be able to revive the Bataan nuclear power plant. So that was before, that was the result of the feasibility study conducted by KEPCO way back in 2012 or 2013. Thank you.
Thank you so much, sir. So proceed to another question. What is the plan of DOE on the depleting reserves of Malampaya plant?
So we have right now LNG projects right now. So this is two of these LNG projects are now on the construction stage. So we are expecting two of these LNG receiving terminals to be operational by next year, 2022. And these terminals will provide the supply requirement of our existing natural gas power plants. So, meron pa tayong 4 na other projects that will be coming in hopefully within until 2025. So this is in anticipation of the depletion of the Malampaya. And the service contract will end in 2024, but we can still get some natural gas production from the wells, but until 2027, I think. So the total depletion of Malampaya will be around that year, 2026, 2027. Thank you.
Okay, so next question, sir. If we are going to build another nuclear power, how efficient it is for today's technology?
So right now, it is more efficient than before the Fukushima, because the technology right now, there's additional measure put in place to be able to address yung mga accidents, just like what happened in Fukushima. So if you're going to look at the levelized cost of nuclear, it's now expensive than before because of additional security features of the current technology. It's more efficient. We all know that nuclear is the most efficient energy sources for power generation. And because of the added, as I mentioned, because of the added security features of the current technology, the cost now of nuclear is much more higher than the cost before.
Okay, thank you, sir. So another question, are there incentives for those residential houses investing or installing solar PV system?
Okay, so there is a net metering program of the Department of Energy. So you can install RE, a solar rooftop, up to 100 kilowatt. So the excess of which you can sell it to the grid. So you can install it only up to 100 kilowatt, the capacity of which. And if you have excess generation, you can go to the distribution utility and sell the excess generation from your solar rooftop.
Okay, sir. So last 2 questions that we will entertain for today, sir. So how about tidal energy?
So tidal energy, we are looking at the tidal energy. May mga demonstration project pa lang ho tayo. Even in other countries, hindi pa siya commercially available, the ocean technology, the tidal technology, because right now it's still expensive. As you before yung FEED, we implemented the feed-in tariff for renewable. Actually, we included the ocean tech technology, but we were not able to provide the fit for that because it's still expensive. So, ang tinitignan nga namin noon way back in 2015, around 22 pesos and more per kilowatt hour. Mahal. So, until now, we're still on the demonstration phase, even in other countries. Kasi the technology is still expensive.
Okay, sir. This is our last question for you. What is our instance on the last COP 26?
What is it? I didn't get it. Sorry.
What is our stand siguro to, sir, no? On the last COP 26.
COP. For the energy sector, we will not yet go for, they are calling for the net zero right now until the target of which is, I think, 2050. But for the Department of Energy, we are not yet looking at the net zero. We are just looking at the transition. So making the clean energy sources to have greater share than the fossil fuel. Because we are primary focus right now is on energy security as well as the affordability of our energy resources. So that is our primary concern. And our position during the COP26 is that we need to impose the Article 8 of the Paris Agreement on the compensation. So we are always saying that we need to push for the climate justice, because for instance the Philippines is only 0.3%, 0.03% ang share natin sa total GSG emission globally. And yet, we receive the parang greater impact of the climate change. So yung ating mga typhoons ngayon are now stronger than before. So dapat the developed countries should compensate the developing countries being affected by the climate change, considering that the contribution to GSG emission is very little. That is our position, the climate justice.
Okay, sir. So again, Honorable Michael Sinacruz, thank you for gracing our event today. It was a pleasure having you for the presentation and of course for giving us time for the question and answer portion. Now we proceed to the awarding of the Certificate of Appreciation. The Institute of Integrated Electrical Engineers of the Philippines Incorporated awards the Certificate of Appreciation to Honorable Michael O. Sino Cruz for imparting valuable insights as a resource speaker on the topic Philippine Energy Plan during the simultaneous technical session in conjunction with the 46th Virtual Annual National Convention with the theme GAT1 IIE at 46, Transcending the Challenges and the New Normal by Embracing Resiliency and Complementarity, held on November 22 to 27, 2021 in Manila, Philippines via Zoom video conference. Given is 27 of November 2021, signed Engineer Alberto R. Herrera Jr., National Secretary, signed Engineer Roland P. Vasquez, National Vice President for External Affairs and Exhibit Bureau Director, signed Engineer Lyndon R. Bage, National Vice President for Internal Affairs and the Convention Bureau Director, and last signed by our National President, Alan Anthony Alvarez. Sir, for a photo op, can we have your presence po?
Okay.
Yan, sir. And the count of 3, 1, 2, and 3. Again, Honorable Sino Cruz, thank you very much for gracing our occasion. It is a pleasure with you having in these sessions today.
Okay, and then please share my presentation to the participants. Thank you.
Yes, sir. We'll be sharing your presentation po. Okay, so thank you again, Honorable Sino Cruz. So from one speaker to another, allow me to introduce the second speaker for today. He is a certified public accountant, a life member of the Philippine Institute of Certified Public Accountants. He is also a licensed real estate broker and a member of the PhilRes Quezon City chapter. Tax partner of E.B. Tarobal and Company CPA Services. Provided are the following: external internal audit, company registration, BIR SEC, local government, mergers and consolidation, BEZA registration, incentivized locators, preparation of protest and position papers for tax deficiency assessments, independent CPA witness, court of tax appeals, tax cases, and installation of computerized accounting system. Without further ado, let me call on Mr. Maurito Tarobal, CPA. Sir Mau?
Thank you very much for that very wonderful introduction. I would like to convey my apologies for having gotten lost in the mix. No? I entered the wrong plenary, plenary 2. I was waiting there since 8 a.m., not realizing that there are 2 plenary sessions pala. So ngayon lang ako nakapasok. So again, my sorry for that mix-up. No? So anyway, are you able to see already my presentation?
Yes, Sir Mau.
Okay.
Visible.
Sige. Thank you. So good afternoon to all the electrical eagles of the Philippines and of the whole world. I was able to listen to some of the lectures on the other plenary, and I was so amazed with the presentations there, especially on in answering the pandemic, no? Because the topics there geared on discussing the EES for hospitals, no? And it was wonderful learning session for me, having gotten lost in that plenary too. No? I should be here in plenary 1. Anyway, so here goes. This is a virtual seminar on VAT and percentage tax, no? But I added withholding tax because I was advised that this is going to be attended by practitioners. So I added withholding tax for the guidance of those who want to practice. No? So we all know that the legal basis of our taxes is the National Internal Revenue Code. Republic Act Republic Act number 8424, or the Tax Reform Act of 1997. It amended previous National Internal Revenue Codes, which was approved on December 11, 1997. So as early as 98, when I attended the first VAT seminars, no, this VAT was already originally imposed at the rate of 10%, which was subsequently increased to 12% under the current law. No? So what are the current governing laws on VAT and percentage tax? These are the so-called train law and the create law. Okay. So the currently applicable regulations on VAT is Revenue Regulations 13-28. RR 16-2005 was the original consolidated value-added tax regulation, no? And this was further amended under Republic Act 10963, which we now know as the train law. Okay, so what is the create law? The create law is, or the comprehensive recovery and tax incentive for enterprises, seeks to assist businesses as a response to the pandemic, no, with retroactive provisions and lower tax rates. Specifically, percentage tax was reduced from 3% to 1% up to June 30, 2023 only, as a reprieve for the pandemic losses that we have sustained for currently, no? And we and are continuously suffering from right now. So this is a welcome development for particularly for small practitioners like us, CPAs and electrical engineers alike, no? Reduced from 3% to 1%. So the 1% started in July, and the percentage tax is filed quarterly using BIR form 2551Q. So it is due on the 25th of the month following the end of the quarter. There is no requirement for filing of the monthly. No, it is only quarterly. Now, we hasten to ask: do we do VAT or percentage tax? No, and we have to ask ourselves the questions: which is more economical tax-wise, easier to comply with reporting-wise? Can we afford not to hire an accountant to do the reporting for us in order to save on bookkeeping costs? And then what happens to our business as electrical engineers if we will be bothered by accounting activities of which we are not too familiar with? No? So anyway, we have a tip here: graduated rate or 8% income tax rate. Before delving into business, you are required to register and choose the registration or the option that you want to avail of. No, it's either you do the graduated income tax rate, or if you choose the income tax 8% income tax, then you will no longer be required to file BIR form 2551Q. No? So that is one thing that you need to consider. Okay, filing of income tax returns can be tedious, no? And you can save a certain amount of money in your tax remittance by tax avoidance, no? Unlike tax evasion, tax avoidance is a legal way for businesses to minimize their tax liabilities, no? And this includes the selection of income tax rate if applicable. Okay, in our country, individuals earning from self-employment or practice of profession have the option to either avail of the graduated rate under RR 8-2018 or 8% tax on gross sales and receipts. No? The most commonly used income tax rate for individual taxpayers is the graduated income tax. Okay, it follows a set of tax rates which increases as the taxable amount rises. This is also known as progressive income tax. So here's a table that shows that 250,000 is exempt or zero tax, no? But take note of the 35% top rate here, which is the highest rate imposed on individual practitioners, no? Pag-isipan niyo ito dahil you might want to ask yourselves the question, would you rather do business as a corporation where the current tax rate is 25%, or it can even go down to 20% in under some conditions, versus 35% top rate under the graduated rates? So you ponder over this in deciding on the type of business that you want to indulge in as either an individual practitioner or a corporate setup, because now one-person corporations, no, can already be registered. Okay? Pag-isipan natin yan. So the special tax rate was effective as early as January 2018. Okay? It is computed based on the total of the gross sales or receipts and other non-operating income over 250,000. No? So this is the exempting amount, no? Instead of the graduated income tax and percentage tax. So who can avail of the income tax 8% income tax regime? Individuals earning from pure business or professional income earners, like consultants, practitioners, electrical engineers, no? And then mixed income earners, like individuals earning income from compensation and self-employment. So may mix yan, provided that your gross receipts will not exceed 3 million. Because if you breach that threshold, then you will be converted into a VAT taxpayer, no? So which we will discuss further later on. So who are the exempt individuals? Non-individuals like partnerships, corporations, cooperatives, partners of general professional partnerships, since their distributive income is already net of cost and expenses, no? And then individuals earning purely income from compensation. They are the VAT registered, of course, are exempt from the 8%. No, taxpayers subjected to other percentage tax, especially assigned in the purpose of business and exempt individuals. Okay, we must signify our intention to file under the 8% option, no, for the year applicable. Tandaan natin to, before the filing of the first quarter ITR, because this choice is irrevocable. No? If not, we will be considered as having availed of the graduated income tax rate, which may result in higher taxes. But we have here samples also of comparative tables showing if the rate is higher in percentage or higher in 8% regime. So where can you save? So in availing the 8% option, you may save money, but this is a misnomer using the because it mostly depends on the flow of income, and expense, as could be gleaned from the presentation here, In this first example, the graduated rate shows a lower income tax due, total tax due than 8% flat rate. The 30,000 here in income tax under graduated rate is based on the table, plus the percentage tax that you pay. So there is 36,000. So a total of 66 compared to 76,000, which is the 8% of 950,000. So in the next example, however, baliktad naman, mas mataas naman yung graduated rate na taxes compared to 8% flat rate. So to be sure, consult with your accountant to determine the more economical option. Okay? Konting pencil pushing lang yan. Tax planning siguro. So would you rather do VAT or percentage tax? Okay, here are the parameters. Sa VAT, 12% is applied on the gross receipts above 3 million. Also, it is applied on gross receipts below 3 million if you opted to register as a VAT taxpayer despite only earning less than 3 million. Nasa inyo po yung choice na yan. Okay? And then sa percentage tax, if your gross receipts is 3 million and below, so you are covered by percentage tax. Okay, so percentage tax is a business tax that regulated in the Philippines that is imposed on individuals. Again, without being redundant, it is based on amount not exceeding 3 million, and you are not VAT registered. Anyway, the tax that you pay, the percentage tax that you pay is treated as an expense. Before the CREATE law, the percentage tax rate was 3%. Again, reiterating that we have a reprieve, 3% naging 1% hanggang June 2023. After that, balik tayo sa 3%. Now, is the percentage tax reduced from 3% to 1% applicable to individuals? Yes. It is applicable to non-VAT registered taxpayers with annual gross sales of 3 million. Again, redundant na naman tayo dito. I just want you to take note of that, And starting July 1, 2023, we will revert to 3%. Now, how do we calculate quarterly percentage tax? Simple, multiply your quarterly gross sales or receipts by 1%. Now, what does gross receipts mean? It means all earnings or revenue you have actually received from your client or business. Now, assuming that you have a sales of 1 million service invoice, actually collected 800. So what is your percentage tax? It is only 1% of the actually collected revenue. So it's not 10,000. Okay? So in the case of VAT, magsa-segue tayo ng konti, you multiply your quarterly sales and receipts. Again, gross receipts, ganyan. Assume sales on credit of 1 million. Okay. Actually collected is 800. Now, take note, the official receipt is a valid source of input tax. This is the only time that you are supposed to pay VAT when you issue the official receipt. Okay, it is not during the serving of the service invoice on your client kasi hindi pa natin na-kolekta. Remember, we are in the service industry as practitioners. Okay. So even though you recorded your revenue as 1 million, because delivered na yung contract, complied na yung inyong conditions of completion. So it's only when you collect that you will be made to pay the VAT. Okay. In our case, 800 is you pay VAT of 85,000, which is calculated by dividing 800,000 by 1.12 and multiplying it by 12%. Now, of course, the VAT due, from the VAT due, you deduct input taxes available arising from your purchase of goods and services. Okay. Okay. Reminders lang for percentage tax registered taxpayers. Again, the percentage tax option must be reflected in your certificate of registration, BIR form 2303. No? You indicate this when you file your application for registration by filling up BIR form 1905. No? So again, there is a showing here of how you calculate your percentage tax, paulit-ulit, 1% lang. Okay? Now, when do you file your percentage tax returns? If you are on a calendar year basis, then you file your percentage tax returns on a quarterly basis, observing the calendar quarter. So the first quarter having ended in March, you pay it on the 25th day of the month, no, following, which is April 25, and so on, no, as July, October, and December. 25th of December is actually a holiday, so you pay it on the 26th or the next business day. Now, if you are doing a fiscal year basis accounting, magkaiba yan. It depends. If your fiscal year ends on May 31, therefore your first quarter would start June, and then the next month, July, August. So ang due date yan is on the following month, which is September 25. And so on moving forward. No? Now, ito, inulit lang ito, no? To highlight the fact that if you have chosen the 8% income tax rate, then you will no longer have to file 2551 quarterly VAT. Okay? So, yon. Anyway, 1701Q is also used for filing your quarterly income tax. So that's the difference between 2551Q and 1701Q. Now, if you exceeded 3 million threshold in revenue, automatically you're elevated as a VAT taxpayer. So you should start reporting as VAT taxpayer, but you are advised to change your status from percentage taxpayer to VAT taxpayer by amending your certificate of registration, no? Using BIR form 1905. No? Okay, ano yung mga babaguhin natin? So, what do you input in the form 1905? Under item G, you have to input this. No? What are the changes that you are going to make? Indicate lang yung percentage tax, the form type, and the effective date of change. With the new one, the value-added tax, it's either 2550M or monthly, or 2550Q quarterly VAT return. Again, indicate the change of effectivity. There are other reportorial requirements. Now, when you are registered as a VAT taxpayer, you are also required to file 1701Q, quarterly income tax. Also, you have to file your annual ITR. And in some cases, you might be required to have your FS audited, no? Or certified by an independent CPA, where applicable, once you breach the income threshold. Okay, I forgot the income threshold, but I will include it in the revised. I will indicate here later on the revised in my revised presentation before it is sent to all of you. Okay. The where applicable there is the income threshold. Now, from percentage tax, we now discuss VAT. VAT has two components. One is the output VAT, which is the VAT on your revenues and receipts. And then the second one is the input VAT, or the VAT on your purchases of goods and services. So the formula for calculating your VAT payable is simple. You simply deduct input VAT from output VAT to determine your VAT due, or if there is an excess, then it is excess VAT or refundable. No? So assuming you have 100,000 output VAT less 75 input VAT, so your VAT payable is 25,000. Now, will there be an occasion when there is an excess input VAT? We will highlight how the BOI registered enterprises or the PESA registered enterprises can have VAT zero rated sales amounting and then resulting in excessive input VAT, no? That they can thereafter file for refund. Okay, so when sales are zero rated and purchases are VATable, thereby generating input VAT, yung zero rated sales less input VAT on purchases would amount to refundable of, say, 75,000 in this case, in this presentation, because you have a VAT of 75, VAT output, no? VAT input of 75 with against zero sales output VAT. Okay. So again, PESA locators and BOI registered enterprises are VAT zero rated on their sales revenue. With zero rated output VAT, VAT taxpayers who pay VAT on their purchases will be loaded with lots of creditable or refundable input VAT. Okay. So in this case, the PESA locators will be awashed with input VAT. Now, if they have local sales, they can deduct the input VAT that they claimed. No? But this is very seldom because based on their certificate of registration, they are mandated to report 100%, no, of all of their products. Okay, to export 100% of their products, resulting in zero rated VAT. So just the same, they will still have excess input VAT. Okay, and so the remedy there is to seek refund of excess input tax with the BIR. But filing refund with the BIR can be cumbersome, no? But then if you want, pwede rin naman, no? Ayun, magse-segue lang tayo. PESA locators are also required to pay income tax on their local sales, no? So in this case, this is a client of mine who has export sales of 96 million, and these are tax exempt. This was called from the notes to their financial statements. And then they have a local sales of 1.840. Okay. Now, this is also their cost of goods manufactured and sold, which is the total cost of goods of manufactured and sold for both local and imported. So we need to extract the local cost of sales, no, from these combined amounts. Okay. And then after identifying that, you might be required to have a separate set of books for your local sales, no, and the related expenses that you that have been spent for generating these local sales. So in this case, nagbayad lang yung taxpayer ng 78,000, no, which is the based on the taxable profit. Okay. So after paying 18,400, meron pa siyang tax due na 78,641 because the calculated tax rate here is 97,000. Okay. Okay. What is a situation where large input taxes may be accumulated? Okay. I have currently a PESA registered enterprise that is venturing into an expansion of its plant. No? So during the construction of plants to be utilized by the PESA locator, entitlement to zero-rated purchases is effective only upon commencement of commercial operations. No? So let's say yung expansion plant niya, ngayon pa lang itatayo, and we are still applying for a PESA registration. We are given a window of 3 years from issuance of the PESA certificate of registration, no? Within which to commence business and generate the necessary zero-rated sales. No? Because construction costs are vatable, no? And they amount to millions of pesos. I have experienced here one renewable energy locator who had 78 million of accumulated input VAT from construction of their facilities. They were able to refund that eventually, but it took them 1 year, I think, from completion of the plants. No? 3 plants located all over the Philippines, and that is only when they had their zero-rated revenue that they were able to claim for VAT refund. The word here, the operative word here is attributed, no? Attributable to actual zero-rated revenues. Okay? So, rule on VAT refund, you have to file it within 2 years after the close of the taxable quarter when the sales were made. Okay? And apply for a refund of credible input tax due on paid or paid attributable to the zero-rated sales. Okay, so these are the conditions for attribution of zero-rated sales. The following requirements must be complied with. No? Okay, so nakalagay dyan, taxpayer is VAT registered, there are zero-rated sales, input taxes were incurred or paid, and input taxes claimed are attributable to zero-rated sales. Now, the input taxes have not been applied against any output VAT liability, and the claim was filed within the prescribed period. No? So 2 years, okay? With regard to the fourth requirement, that input taxes claimed are attributable to zero-rated sales, there was a recent case in the CTA wherein the tax court held that the PESA registered entities claim for VAT refund should be denied because the input tax claimed were not proven to be attributed to zero-rated sales. No? It involved a PESA registered enterprise who enjoyed VAT zero rating on its export sales. The PESA registered enterprise incurred input VAT in the construction of laborers' row houses, foreman's duplex, dormitory, bus terminal, and airport runway. According to the tax court, these purchases are not related. Again, the word is related to the export sales and hence should not be refunded. But there was a dissent. The dissenting opinion of the same case, the presiding justice opined that the input taxes claimed are attributable to zero-rated sales. It noted that the construction of the above-mentioned facilities were necessary in the pursuit of the PESA registered activity. So, taking into consideration that the PESA registered entity was located in a remote area. So ito, maganda naman yung dissenting opinion. Pwede natin gamiting pang argument ito when we do our own VAT refund, assuming that we will be denied the VAT refund. No? So the burden of proof is on the taxpayer, no, for the tax refund. Considering that taxpayers have a daunting task to prove their entitlement to VAT refunds, it would be a welcome development if guidelines can be set. Okay, pag-aralan po natin ng maigi yung mga guidelines na ito, no? Because based on the wordings of our petition, baka magkaroon ng technicality because misuse of one word may amount to a denial. So it is best to consult with your lawyers or accountants in pursuing your VAT zero rated sales refund with the BIR. Okay. Again, I'm reiterating this, no? Reminders for refund of excess. You must have commenced commercial operations. You have excess input VAT. Indicate in the VAT returns that the excess input VAT will be refunded. May provision po dun sa VAT returns that it's either you refund it or carry it over to the next quarter or period, no? When you intend to do a refund, make sure to click on the for refund instead of for carry over. Okay. Of course, we must follow strict requirements under BIR rules on VAT refund. Additionals, observe these rules strictly. Follow strict bookkeeping requirements. Okay. Dito po, sumasalya tayo when we do our bookkeeping. Sometimes we take it for granted, no? Or most of the time. Based on my experience, no? Kasi ang dami ko pong kliyente na inayos ko ang kanilang mga reporting system bago sila nakapag refund ng maganda. Okay? Invoicing requirements. Ito, importante po ito. Indicate the following in the invoice or receipts, no? Name of supplier, address of supplier, or TIN of supplier, which are already indicated in the printed OR. More importantly, when you are filling up, when the customer is filling up, lalong-lalo na yung collector, no? You must ask the collector to put the full name of your business, your complete address, your TIN, and they must indicate that the VAT is a separate item in the invoice. Because the absence of one information shall render the invoice as not entitled to input VAT. So this may jeopardize your VAT claim, okay? Because input taxes shall be disallowed because of these errors in completion of the invoice or receipt. So tandaan po natin ito, no? Anyway, you will be sent this seminar material. Gawin nyo na lang pong kodigo ito or reference, so, as a reminder. So accounting treatment, magda-delve tayo ng konti sa accounting. Assume an invoice of 100 with VAT of 12, total of 112 was spent for the payment of a seminar venue. Now, how do you treat this in your books of accounts? What will be your accounting entry? So in the case of percentage tax, simply lang, you debit the expense of seminar venue, 112, then cash in bank, 112. Debit what you receive, credit what you give away. Okay? So you've given 112,000 in payment for the seminar venue. And then explain your transaction. Okay? So in the case of VAT, ano naman ang journal entry natin? Ito po yung journal entry. Okay? The seminar venue is only 110,000 because the 12,000 is recognized as an asset to be deducted from your VAT output. Okay? So, how much was the expense? Sa percentage tax, 112. Sa VAT, 100. Okay? The input VAT of 12 is recorded as an asset to be deducted from your output VAT, as I mentioned earlier. Okay? Now, how do we utilize the input VAT? Simple. Assuming that you have a sales of 500,000 with a 12% output VAT. So, you debit cash, 560. Credit sales, 500. Then you have an output VAT of 60,000. So, it's a liability on the credit side. So you explain the transaction, and then upon filing of your VAT return for the month or the quarter, you simply say output VAT less input VAT, then you have your VAT payable. of 48,000 net. Okay? How about percentage taxpayers? How do they record the sales revenue? Well, they cannot bill VAT separately. So, ito lang yung kanilang magiging journal entry. They are limited to 500,000. Okay? Now, how about the percentage tax that they need to pay for the month? Pay 1% of 500,000. Percentage tax expense, 5,000. Then cash, 5,000 to record payment of percentage tax. Next challenge, reportorial requirements. Monthly VAT or percentage tax returns, monthly expanded withholding tax, BIR Form 160619E. Monthly withholding tax on compensation, covered by 1601C. So ito po yung mga hassles ng business, but they are necessary, no? Or else you will be subpoenaed by the BIR for not maintaining your books of accounts. So you have to file your quarterly income tax as a minimum, and then also your annual ITR, plus many more like annual information return, etc., etc. No? So, do you wish to employ an accountant or not? Kayo po ang magde-decide niyan, no? But you must find a reliable accountant or bookkeeper to avoid penalties and surcharges due to lateness or non-compliance. Worse, penalty comes with imprisonment. It can come with imprisonment, no? Although wala pa akong nabalitaan na may na-imprison na, no? Yung susunod na slides are just tutorials how to file your VAT returns and percentage tax returns, no? So we just need to follow these step-by-step procedures available in the BIR website for EBIR forms, which can be downloaded from the BIR website. Now, gamitin po natin yung version 7.9, which is the latest, no? 7.9.1 pa yata or 0.2 na ngayon, no? Now, when you are doing your returns, you have to input your TIN number in the BIR form facility, no? EBIR forms facility. And then enter the RDO code. Okay? Yan, yun ang nakabilog na po yan. Say in my case, I file my returns in RDO 42 of San Juan. Now, makikita nyo to, 1, 2, 3, 4, 5, 6, 7. Yan. Tutorial lang po ito. Balikan nyo na lang po, no? How to enter the website when you're filing your returns. Okay? So you will be required to enter line of business, name, address, etc., etc. No? Either 2551Q for percentage tax or 2550M for VAT. Assume that you are a percentage taxpayer, so you select 2551Q. Ayan po. Okay? And then after selecting 2551Q, click fill up. And then input your TIN and email account to proceed. Okay? And then click submit. Then the system will confirm and save your information. Then you click OK. Then once the form appears, fill in the calendar or fiscal year. Okay? Dito. And the applicable quarter dito. After filling up the quarter and number of sheets attached, answer item 13 if availing of tax relief under a treaty. Okay? And then proceed to part 2. Okay? So, once you have selected that, you will be asked to choose PT010 for practitioners to, no? Persons exempt from VAT. And then click OK at the bottom of the form. and then fill up the taxable amount, and then tax due is automatically calculated. Click validate, and then BIR will respond if successful or not. Okay, in this case, it was successful. Then you can save your work or click submit final copy kung sigurado na kayong magbabayad na kayo nung or okay na yung information that you have inputted. Otherwise, you can edit your work afterwards, no? So BIR will then send a confirmation via email that you have filed your tax return. So print your return while awaiting the BIR confirmation. Then attach the BIR confirmation to your percentage tax return. Proceed to pay to the accredited bank under the jurisdiction of the RDO where you file your tax return, or through other facilities. Pwede po ang GCash, Paymaya, meron ding BizLink, ang Land Bank, and other banks, among others, no? So these are information are all available in the BIR website. Okay? So filing of VAT returns, pareho lang din po yung procedure niyan, ano? So to gain entry into form, click Schedule 1, okay? And then click the ATC it stands for applicable tax code yata. Then click OK after selecting the proper ATC. Okay? Yun. Now, select VB10 or VAT on Business Services in general. Ayun po. Okay? Then click OK. Then enter amount of sales or receipts for the period, and output tax for the period is automatically calculated. Yun po. Okay? Click OK. And then fill in other revenues, exempt, etc., and other pertinent items that generate input VAT. Okay? And then to be able to determine total input taxes. Okay? After that, tax is still due and payable is then determined. Ito po yun. Then click validate. Okay? If successful, save your work. Again. Ano na lang yan? Procedural na lang po ito. Use this when you start to tinker. Oh. Okay? And then,
sana, ganang-giling na ako. Nakapunta ako duman, mahal.
Meron yatang paki-unmute yung ano. Technical, baka meron yatang na. Okay? Click submit or final copy. Now, the same, BIR will send a confirmation via email. No? Now, may siningit lang akong withholding tax, no? Applicable to practitioners and corporations. Okay? So, let me get back to that. Okay? So, andito po, basahin nyo na lang po ito, no? Yung ating applicable withholding tax in the interest of time. I was originally given 1.5 hours but naging 45 minutes lang. Okay? So, income tax payment subject to creditable withholding tax. Ito yon, individual payees. If gross income is for the current year, it did not exceed 3 million, 5%. If gross income is more than 3 million, 10%. Okay? Now, for individual payee, if gross income for the current year did not exceed 3 million, 5%. And then if gross income is more than 3 million, 10%. For non-individuals, if gross income did not exceed 720, magkaiba po yung threshold, ha? Sa mga corporate, 720 lang. And then if it exceeds 720, then 15%. Okay? So, individually engaged in the practice of profession, 5% or 10%. So, dito kasama po ang mga electrical engineers. Okay? Ito, partnerships in general, okay, 15% if the gross income of this current year exceeds 720. So parang ito lang, reference na lang po ito, no? Because I know maraming nalilito, anong rate ang i-apply sa withholding? Is it 2% or 1%? We have here specialized engineering knowledge, nakalagay, no? So we are subject to, as electrical engineers, you are subject to 2% withholding. Okay? So you need to submit sworn declaration also by January 15, in the following year. Those who are engaged in practice, together with a copy of your certificate of registration. And you have to furnish this to all your clients, or payers withholding agents, not later than January 15, or at least prior to the initial payment of the professional fees, commissions, talent fees, etc. Okay? In order for you not to be subjected to a higher rate, you should submit talaga yung sworn declaration. Okay? For non-individuals, the authorized officer is required, for the wrong spelling, required to provide all its income payers with withholding agents with an authorized sworn statement to that effect. Okay? So together with a copy of the company's COR, in order for them not to be subject to 10%. The 15% higher rate shall be applied if the payee failed to provide the income payer with the sworn declaration, or the income payment exceeded 720,000 already, despite the submission of the sworn declaration. So may counterpart declaration din yung income payers o yung mga ating mga kliyente, no? They will be required to submit a declaration also, and they need to do that on January 30. Okay? So gentle reminders, observe bookkeeping regulations strictly, comply with within the deadline set for filing tax returns to avoid penalties and surcharges, and avoid the fate of Al Capone, who was convicted in 1931 on 5 counts of tax evasion for failure to file tax returns and was imprisoned for 11 years. Because this was based on his impression that you cannot tax dirty money. But he was wrong, no? So it pays to know how you're doing in your business by employing good bookkeepers or accountants, no? And sabi ni Elon Musk, invest in technology. Okay? So you can focus on your core business as electrical engineers. Now, last word, who is a true leader? He has the confidence to stand alone, the courage to make tough decisions, and the compassion to listen to the needs of others. He does not set out to be a leader, but becomes one by the quality of his actions and the integrity of his intent. In the end, leaders are much like eagles. They don't flock. You find them one at a time. So, yun. That is the end of my presentation. Medyo sumobra tayo ng konti. Maraming salamat po. Congratulations, IIEE Eagles, on the holding of your 46th Annual National Convention. I'm very thankful to have been invited to share in your wonderful occasion today. This is Mau Tarobal po at your service. Any questions that you may want to ask, andito po yung aking mga contact numbers and email. God bless po everyone, and thank you.
Thank you so much, Sir Mau. So now we proceed to the awarding of the Certificate of Appreciation. The Institute of Integrated Electrical Engineers of the Philippines Incorporated awards the Certificate of Appreciation to Maurito Tarubal, CPA, for imparting valuable insight as resource speaker on the topic VAT and percentage tax for EE practitioners during the simultaneous technical sessions in conjunction with the 46th Annual National Convention with the theme GAT1 IIE at 46, Transcending the Challenges in the New Normal by Embracing Resiliency and Complementarity, held on November 22 to 27, 2021 in Manila via Zoom video conference, given this 27th of November 2021, signed National Secretary Engineer Alberto R. Herrera Jr., National Vice President for External Affairs and Exhibit Bureau Director, Engineer Roland Vasquez, National Vice President for Internal Affairs and the Convention Bureau Director, Engineer Lyndon R. Bague, and of course, the National President, Engineer Alan Anthony Alvarez. Once again, Sir Mao, thank you for gracing our event. It was a pleasure working with you today. So, in the count of 3, sir,
Yes.
let's have a photo op. Okay, sir.
Thank you, Yael. Thank you.
Thank you, sir. Thank you very much po. 1, 2, 3. Okay, sir. So
Okay,
thank you very much po, Sir Mao.
Salamat po. It's a pleasure. I'm honored.
Thank you so much, sir. So
Okay.
from one speaker to another, I would like to call on the member of the Technical Sessions Committee, Engineer Jonathan Medalla, to introduce our next resource speaker for today. Sir Jonathan. Okay. Since Engineer Jonathan is not in the session room, allow me to introduce our next speaker. Ladies and gentlemen, allow me to introduce a public servant whose impeccable work ethic and tireless dedication to serve his country made him one of the most hardworking lawmakers in the Philippines. As a chairman of the Senate Committee on Energy and Committee on Economic Affairs during the 17th Congress, he stirred both committees with a goal in mind: to protect and empower the Filipino consumers and support small and medium businesses to generate jobs. He strove toward the passage of several key measures aimed at fostering a competitive, investor-friendly, and red tape-free environment in the energy sector and in the Philippine economy. He has successfully stirred the passage of pro-consumer legislations that have been signed into law. Among the laws he has authored are the following: Murang Kuryente Act, Electric Cooperatives Emergency and Resiliency Fund Act, Energy Virtual One-Stop Shop Act, Energy Efficiency and Conservation Act, Anti-Obstruction of Power Lines Act, Philippine Innovation Act, Community-Based Monitoring Systems Act, Islamic Banking Act, and the Mobile Number Portability Act, wherein consumers now have the freedom to change their mobile numbers without the need to change mobile service providers or subscription plans. His bills under the Energy Committee, the extension of lifeline rate subsidy and electricity bill for low-income households had been signed into law on May 27, 2021, while the LPG Act, which aims to remove unsafe tanks from circulation, was enacted on October 14, 2021. Another bill that had authored, the Microgrid Systems Act, which seeks to accelerate the full electrification of all households in the country, is now close to becoming a law following its ratification on November 9, 2021. Indeed, his commitment to genuine public service continues to drive him in pursuing his promising vision of a better Philippines. Ladies and gentlemen, Senator Win Gatchalian.
of the Philippines, headed by President Alan Anthony Alvarez, all regional governors around the country, members and guests. It gives me a great pleasure to be here with you to talk about sustainable energy initiatives. Growth in the renewable energy sector has an increased demand for a wide range of engineering skills. The expertise of electrical engineering professionals is a vital source in striving to establish environmentally friendly practices. Malaki ang papel at kontribusyon ng mga tulad ninyong electrical engineers sa pagsulong natin ng renewable energy. Katuwang kayo ng bansa sa pagdiskubre ng mas marami pang teknolohiya sa industriya upang mapalawig pa ang paggamit ng RE tungo sa mas malinis at abot-kayang enerhiya. When we talk of RE, there are trends that we should watch out for. First is the net zero targets of countries and companies. Here at home, there are some companies that have started to implement initiatives aimed at achieving net zero greenhouse gas emissions. As the Energy Committee Chairman in the Senate, I'm planning to file a bill with a net zero target for energy by 2050, which balances energy security, equity, and a just energy transition for displaced workers and affected sectors. I've also funded an energy transition study in the DOE budget, 20 million pesos for fiscal year 2021 and another 10 million pesos for 2022. Another RE trend is the phase out of coal-fired power plants. The Philippines, along with 40 other countries, have agreed to a deal seeking to phase out the use of coal-fired power plants. In fact, in 2020, the government has declared a moratorium on new coal-fired power plants. This should also be backed up with moves that would lure investors in putting up a more sustainable power system, which could even prove to be a cheaper option for consumers. The recently concluded 2021 UN Climate Summit in Glasgow called for ending all coal-fired power plants, achieve clean power by 2030, zero emissions vehicle by 2030, and affordable, renewable, and low-carbon hydrogen globally available by 2030. The Energy Committee in the Senate, which I chair, has been working for clean energy solutions that will lower consumer energy bills, create jobs, and build our economy. I'm proud to share with you our most recent accomplishment, the ratification of the Microgrid Systems Act, which I authored. Senate Bill number 1928 seeks to provide reliable electric services to every household and accelerate electrification in areas with no electricity access, no distribution system lines, or no connection to any microgrid. This measure, which is one step away from becoming a law, mandates the priority use of indigenous and RE microgrid systems. I would also like to announce that the consolidation of the Senate and House of Representatives final version of the proposed Electric Vehicles and Charging Station Act is already in the works. This measure, which will provide the national energy policy and regulatory framework for the use of EVs and the establishment of electric charging stations, aims to ensure the country's energy security and independence by reducing reliance on imported fuel for the transportation sector. Under the bill, all public and private buildings constructed after the enactment of the measure shall be required to have dedicated parking slots for the exclusive use of EVs, and these will double as charging stations to further widen the nationwide network of charging stations. Large industrial and commercial companies, public transport operators, and government agencies and instrumentalities will also be required to adopt a minimum 5% share of EVs within their respective fleets, while local government units are also tasked to create green routes for electrified public utility fleets. Gasoline stations will also be required to install charging stations. Sa ngayon, may kamahalan ang EVs kung tutuusin. Ngunit pasasaan ba't dadating din ang panahon na magiging abot kaya ang halaga nito kapag naging commercially available na. Ngayon ay patuloy na rin ang pagbaba ng presyo ng ilang components nito tulad ng baterya. Promoting the use of renewable energy will lead to improved competitiveness and will bring in tangible results such as the reduction of the cost of electricity in our country. Rest assured that there will be no let-up in our efforts to come up with needed policies to provide direction towards achieving sustainable energy resources. Thank you very much and stay safe.
Thank you so much, Honorable Win Gatchalian, for that wonderful message about renewable energy. So allow me to read the Certificate of Appreciation. The Institute of Integrated Electrical Engineers of the Philippines Incorporated awards a Certificate of Appreciation to Honorable Sherwin T. Gatchalian for imparting valuable insight as resource speaker on the topic renewable energy during the simultaneous technical session in conjunction with the 46th Virtual Annual National Convention with the theme GAT1 IIE at 46, Transcending the Challenges in the New Normal by Embracing Resiliency and Complementarity, held on November 22 to 27 in Manila via Zoom video conference, given this 27th of November 2021. Signed, National Secretary, Engineer Alberto Har Herrera Jr., National Vice President for External Affairs, Exhibit Bureau Director, Engineer Roland Vasquez, National Vice President for Internal Affairs, and Convention Bureau Director, Engineer Lyndon R. Bague, and National President, Engineer Alan Anthony Alvarez. Ber, video muna, video.
The nation erupted into scenes of chaos.
Good afternoon again. We are down to the last speaker for today's technical sessions. Our next resource speaker has over 25 years of experience in the electrical engineering industry. Experience includes operation and maintenance, erection, installation, test and commissioning, construction supervision, and management. Has comprehensive knowledge in the field of electrical engineering applications such as substation, automation systems, SCADA EMS, high voltage electrical equipment, power metering, high and low voltage transmission and control systems, as well as fault clearance systems. He is also familiar with the Electrical Industry Reform Act, RA 9136, the Philippine Grid Distribution Codes, and WSM rules. A member of various working groups in the preparation of tender documents and technical evaluation of bid documents of various bidders under NPC, Transco, and NGCP. Has established connections and networks in the electric industry, such as Department of Energy, National Power Corporation, National Transmission Corporation, National Grid Corporation of the Philippines, Philippine Electricity Market Corporation, electrical utilities, electric cooperatives, and electric manufacturing plants, traders, and distributors. Very active member, fellow member of the Institute of Integrated Electrical Engineers of the Philippines, and was the 2006 National President. Has been a recipient of various recognition, award, and citations during his professional career, including Presidential and Philippine Civil Service Commission awards. Currently, the Vice Chairman of the Professional Practice Committee and the Chairman of the Legal and the Legislation Committee of the Institute. He is currently employed with the National Grid Corporation of the Philippines as a Chief Engineer for Substations, North Central Mindanao Area, Mindanao Operations and Maintenance. Ladies and gentlemen, let us all welcome Engineer Leo Cabasad. Sir Leo?
Hello? Hello? Do you hear me?
Sir, medyo mahina po yung audio natin, sir.
Klaro ba? Hello? Klaro ba yung audio?
Yes, sir. Clear.
Okay,
Yes,
okay.
sir.
So let me share my presentation for this afternoon. So I am cutting short of my presentation because of due to time constraints. So I have to give only the highlights of our proposed engineering law. So let me start. Nakita na ba yung presentation? Kita
Yes,
na
sir.
ba?
Yes, sir. Kita na.
Kita na. Okay, okay. Bakit hindi ito mag-move? Okay, so good afternoon again to all the participants of our 46th virtual annual national convention. So again, what we have at the moment is House Bill 6314 and Senate Bill 1210. And this seeks to introduce into the EE law several new substances as follows. What are the significant changes of the proposed new law from that of RA 7920? So highlights number 1. This is the declaration of policy.
note that RA 7920, there is no declaration of policy. In this bill, declaration of policy states that the state recognizes the importance of electrical practitioners in nation building. Towards this end, the state fosters, develops, and nurtures a pool of proficient and quality electrical engineering practitioners whose standards of practice shall be outstanding, honorable, and globally competitive. The state shall provide rational regulatory measures that are responsive to the growing needs of the electrical engineering profession, considering the advances in technology and globalization. Highlights number 2, wider definition of terms used as reference in regulating the practice of the electrical profession. The proposed new law manifests more comprehensive definition of terms surrounding the profession. From 15 terms defined in RS 2920 to 59 in this proposed law. This new set of definition of terms will help clear the ambiguity of scopes, coverage of practice, specific systems or processes to differentiate other disciplines and to eliminate misinterpretation. You can see it on section 3A to 3SS. So these are the terms being defined under this new law. So we cannot, we will not be discussing one by one because it will take so much time. So these are the, we really defined already what is an institutional building, capacity of industrial park, capacity of electric power plant, power grid or grid system operations and control, distribution system operations and control, substation, system nominal voltage or voltage, kVA or MVA, kilowatt or megawatt, watercraft, electric locomotive, and safe installation and safe design. Philippine Electrical Code is very well defined here. Electrical plans, as-built plans or as-built drawings. Office of the building official is also defined here. Certified electrical system inspector, certified electrical plan inspector. These are supposed to be employed with the local government, distribution utility or DU, electric cooperatives or SC, electrical firm, continuing professional development. So these are all 59 terms being defined in this proposed law. And some of the example of this, like electrical engineering. Electrical engineering is being defined, refers to the profession of the art and science of conceptualizing, planning, designing, and creating electrical systems to include but not limited to the operation and maintenance of equipment and machinery, electrical processes of all types of buildings, commercial complexes, factories or industrial plants, electric plants, variable renewable energy or VRE, energy storage, transmission, distribution, electric locomotives, watercrafts, construction and commissioning of electrical projects, manufacturing and distribution of electrical products, teaching electrical subjects, and other related facilities or processes in accordance with the principles and safety of safety and reliability. Another definition, practice of electrical engineering. This refers to the professional act and the practice of responsible character in performing electrical engineering services in the form of electrical consultancy service, in the form of authoritative assessments, investigation, examination, appraisal of electrical system design or existing systems, specifications and construction processes, providing oral or written advice and direction on technical issues, decisions and recommendation or evaluation on technical audits, in-depth system analysis, and other services requiring expert electrical engineering knowledge, engineering calculations, and application of engineering data principles. Number 2, on the practice of electrical engineering, professional design service refers to the preparation of electrical plans, calculations, designs, studies, specifications, and estimates for electrical systems as generating plants, including conventional and renewable, transmission and distribution systems, power substation, electrical equipment and machinery, network system protection, switchboards and switchgears, electrical systems of dwellings or residences, buildings, facilities, industrial plants and factories, industrial parks, commercial complexes, mining operations, airports, seaports, economic zones, watercrafts, electric locomotives, and other related electrical works, processes, or projects. Number 3, management, supervision, or taking charge of the construction, erection, installation, alteration, testing, and commissioning of projects involving all kinds of electrical systems. Number 4, management, supervision, or taking charge of the tending, operation, maintenance, and control of electrical systems, of electric power plants, grid systems, switchers, transmission and distribution systems, network protection and monitoring systems, electric utilities, watercrafts, electric locomotives, factories and industrial complexes, commercial buildings, government buildings, institutional buildings, healthcare facilities, airports and seaports, and all other facilities involving electrical processes. Number 5, management, supervision, or taking charge of the manufacture, fabrication, repair, testing, and commissioning of electrical components, equipment, and devices, including switchgears, switchboards, control gears, transformers, generators, electric motors, controllers, appliances, lighting fixtures, apparatuses, and other related processes. Number 6, management, supervision, or taking charge of the sale, supply, and distribution of electrical equipment, including industrial equipment and its control systems, controllers and devices, power electronics, industrial robotics, instrumentation and automation, and other related equipment or components requiring application of electrical engineering data and principles, interpretation of technical specifications of electrical products. Number 7, teaching of basic and professional electrical engineering subjects in government-recognized engineering schools, including allied sciences, the electrical engineering law, the Philippine Electrical Code, and international electrical standards, and their application into the electrical industry. Number 8, employment in national, provincial, or local government units, agencies, or in government-owned and controlled corporations, government financial institutions, as a professional electrical engineer, registered electrical engineer, or registered master electrician, if the nature and character of his work is in line with the profession requiring knowledge and expertise of electrical engineering, including certified electrical system inspector and certified electrical plants examiner. So another sample of definition of terms refers office of the building official, refers to the office forming part of the local government unit but under the administrative control of the appropriate government agency whose primary role is to oversee the full implementation of the National Building Code and its revised implementing rules and regulations to include various referral codes and all other relevant laws. One of the referral code is the Philippine Electrical Code, of course. Who are authorized electrical engineering practitioners refers to a person professionally and academically qualified, registered and licensed to practice electrical engineering as defined in this act, with a certificate of registration by the Professional Regulatory Board of Electrical Engineering and a valid professional identification card issued by the Professional Regulation Commission as professional electrical engineer, registered electrical engineer, or registered master electrician. So those are some of the definition of terms that I just pick up. So we will go to highlights number 3. More substantive provisions for the field of practice of responsible character of electrical practitioners. The practice of electrical engineering refers to the professional act of responsible character of performing electrical engineering service in the form of consultancy services, professional design services. Those enclosed in parentheses are the sections you can find in our proposed law. Management, supervision, or taking charge of electrical construction or projects, operation, maintenance of electrical systems and processes, manufacture, fabrication, or repair of electrical equipment, sale, supply, and distribution of electrical equipment and components, teaching of electrical engineering subjects in colleges and universities, employment in government offices as electrical engineers. By responsible character, the provision on the field of practice are enhanced with the civil accountability as follows. A professional electrical engineer who authored the plans and design as electrical system designer on record with the office of the building official shall have full civil liability over the plans, designs, specifications, and contract document bearing his signature and seal for a period of 15 years. A professional electrical engineer or registered electrical engineer who is directly responsible in the supervision of an electrical construction in compliance of the plans and designs on record with the office of the building official shall have full civil liability over the quality, workmanship of the installation process for a period of 15 years. So ang isa, designer, itong isa naman is the actual na nag-supervise doon sa construction or whatever. Item 3, moreover, the proposed law requires the faithful compliance to the Philippine Electrical Code and the Philippine recognized international standards for system design and installation methods or processes. Highlights number 4, clearer mandate on who are authorized to practice electrical technology and electrical engineering profession. A more purposive characterization on who are authorized to practice electrical engineering is better defined. Note that passing the board examination, registration with the PRC as professionals, and taking the professional oath are not enough. In this proposed law, the professional is not allowed to practice unless his professional ID is valid. He may have the license for a lifetime, but without his valid identification, his practice would be a violation. Authorized electrical engineering practitioner refers to a person, binalik ito. I have already stated this kanina. So we'll go to highlights number 5. Clearer mandate on who are authorized to teach electrical engineering courses in colleges and universities. A more purposive characterization on who are authorized to teach in the electrical engineering course. Teaching electrical engineering is one scope of practice of electrical engineering since history. This is since Republic Act 184. Teaching without the authority to practice electrical engineering as defined in this proposed law would be a violation. In this proposed law, the minimum requirements for the field of practice of teaching electrical engineering shall be for basic electrical engineering subjects and allied sciences, a registered electrical engineer or a professional electrical engineer are allowed to teach. For professional electrical engineering subjects, professional EE or registered EE with master's or doctorate degree related to electrical engineering are the ones authorized to teach. For basic electrical technology subjects, registered master electrician can teach. Let's go to highlights number 6. The much improved employability amongst licensed electrical practitioners as embodied in the provisions for the minimum complement of licensed practitioners in power plants, industrial plants, transmission, distribution systems, and commercial complexes. A wider and more comprehensive field and coverage of the practice of the profession, introducing the concept of KVA capacities as a measurable reference for the minimum requirements of complement of licensed personnel is one of the highlights of this proposed law. Note that the reference to KVA or MVA capacities as vis-a-vis requirements of complement of personnel is not covered by both Republic Act 184 and Republic Act 7920. Please note that in Republic Act 7920, the REE is allowed to practice the full scope of the profession without limits as to voltage and capacity, including design, except ceiling. This means that regardless of how small or how enormous the power plant or the grid or the industrial or commercial complex is, RA 7920 only requires one REE per shift. In several instances of reality, this provision is physically and technically illogical or impractical, but sadly compliant to the law. That is why, in this proposed law, the concept of KVA capacities as measurable reference vis-a-vis the field and coverage of resident manning complement of electrical practitioners inside the industry, utility grid, commercial complexes, and other establishments is one of the major features of this proposed law. By capacity, it means capacity of industrial plant, commercial establishment, process, or work project. Refers to the rated capacity in KVA or MVA of electrical works or projects or industrial or commercial establishment for the purpose of this act shall be the total KVA or MVA rating of all the generators and transformers wherein which are installed to make available the capability to provide certain amount of power for use as electric supply equipment in such works, projects, or plants or establishments, whether in operation or not, or without regard to the connected loads requiring power from power sources. The extensive focus on the minimum personnel requirements has been broadened in more specific terms to include that of the registered master electricians. This complement of authorized electrical practitioners will not only help ensure public safety and preservation of lives and properties inside public or private establishments, but also enhances and strengthens the employability and dignity of the profession. Section 35A of this proposed law, minimum personnel required for industrial and commercial complexes. So 150 kVA up to 300 kVA. One resident RME as authorized electrical practitioners responsible and civilly liable as to the integrity and safety of the electrical systems to include any changes, alteration, addition, subtraction of any parts of the electrical system thereof, provided that every factory, building, or commercial complexes in this category operating in more than one shift in every 24 hours shall have the minimum personnel of one RME per shift. So again, we increase the 300 kVA to 750 kVA. One resident registered master electrician as authorized electrical practitioners, responsible and civilly liable as to the integrity and safety of the electrical systems to include any changes, alteration, addition, subtraction of any parts of the electrical system thereof, provided that every factory, building, so kung may shifting na, one RME per shift and one resident registered master electrician, one resident registered electrical engineer as head, whose scope of responsibility includes operation and maintenance. So merong isang RME per shift, tapos may isang overall head. So above 750 kVA to 5,000 kVA. So the number of manpower complements increases. Naging dalawa na. So above 5,000 to 20,000 kVA. So again, it increases the number of manpower complement for the minimum personnel required. Above 20,000 kVA to 60,000 kVA. Again, it increases. This is still for the industrial and commercial complexes. So above 60,000 kVA, there are 5 resident registered master electricians and 3 resident registered electrical engineers and 1 resident professional electrical engineer. If operating on 24 hours, there will be 5 resident registered master electricians and 3 registered electrical engineers per shift, and 1 resident professional electrical engineer in charge as managing electrical engineer whose scope of responsibility includes overall operation and maintenance. Let's go to power plants operating more than 1 shift. So the minimum personnel required up to 20,000 kVA, 1 RME, 1 REE per shift as resident complement, and 1 PEE in charge as managing electrical engineer whose scope of responsibility includes overall operation and maintenance. From 20,000 to 60,000 kVA, the number of personnel, minimum personnel required per shift increases from 60,000 to 200,000 kVA. So again, the number of minimum personnel required is increases. So above 200,000 kVA. So there will be 6 registered master electricians and 3 REE and 1 PE as head of shift operation per shift as resident complement, and 1 PE in charge as managing electrical engineer whose scope of responsibility includes overall operation and maintenance. For power substation of grid and distribution utilities, this is for manned substations up to 75 MVA in specific inclusive area or location, 1 RME, 1 RE per shift as resident complement, and 1 resident PE in charge of managing electrical engineer whose scope of responsibility includes overall operation and maintenance. For 75 MVA up to 200 MVA. So the number of minimum personnel required for power substations of grid and distribution utilities increases. So above 200 MVA, again, it increases. So for grid system operation, regardless of the size and complexity of grid system operations, all resident authorized electrical practitioners in this category shall have a minimum requirement of at least registered electrical engineers or professional electrical engineers during shift operations, and 1 professional electrical engineer as head for managing electrical engineer for every department, division, or section as the case may be. Further, that the grid system operations shall have operational control over unmanned, automated substation of all types and sizes under its control. Furthermore, that additional qualified personnel shall be employed to ensure safe operation and safeguard public welfare commensurate to the size and complexity of operation. For distribution system, this is more or less the same with the grid system operation. For electrical construction works or projects, for electrical works or projects under construction, the installation, erection, wiring in an electric system in residential, institutional, commercial, and industrial buildings, power plants, substations, shipbuilding, and other electrical projects, 150 kVA up to 750 kVA, 1 RME as electrician in charge, and 1 REE as project engineer in charge, and 1 PE as project manager or consultant. From 750 kVA to 5,000 kVA. So again, the number of minimum personnel required increases over 5,000 kVA. So again, it increases. So So section 41A and B, minimum personnel required. Electrical equipment manufacturing plant. The minimum personnel required for this type of plant shall be covered under section 35 of this act. Provided, however, that full-time professional electrical engineers shall be mandatory for the designing section of the plant, overseeing, supervising, and ensuring over the design of special equipment as transformers, motors, switchgears, switchboards, control gears, motor control centers, power panels, and panel boards, and the like. For watercrafts and locomotives, up to 750 kVA with voltage not exceeding 600 volts. One registered master electrician or one registered electrical engineer. Above 750 to 5,000 kVA. So one registered master electrician and one registered electrical engineer or one professional electrical engineer. Above 5,000 kVA, again, it increases the number of minimum personnel required. Other provisions for complement of electrical practitioners, provided, however, that in all the aforementioned cases, to include the case of clusters of buildings or factories or facilities, grid or DU substations, or switching stations, where physical presence or supervision of the minimum personnel required is impossible for reasons of geography, distance, and or density or electrical equipment, additional qualified personnel shall be employed to ensure safe operation and maintenance of the electrical system and to safeguard public welfare, lives, and properties. Other provisions for complement of electrical practitioners provided further that in case of operation, maintenance, or construction projects, a registered master electrician can technically supervise the activities of fellow registered master electricians or non-licensed personnel, but assumes the full responsibilities and accountabilities as to the scope and limitations mandated in this act. Registered electrical engineers can technically supervise fellow REEs, RMEs, or non-licensed personnel, but assumes the full responsibility and accountabilities as to the scope and limitations mandated in this act. A professional electrical engineer can technically supervise fellow PEs, REEs, and RMEs, or non-licensed personnel, but assumes the full responsibility and accountabilities as to the scope and limitations mandated in this act. This section shall not apply to any installation which has a connected capacity of less than 100 kVA and employs voltages of not more than 250 volts, and for installation that do not require resident personnel for their safe operation. Provided, however, that for every changes, alteration, revision, addition, and as-built plans of any parts of the electrical systems, the plans and designs shall bear the signature and seal of an authorized professional electrical engineer. Provided further that a yearly assessment will be conducted and certified to be in a safe operating condition by a professional electrical engineer or registered electrical engineer or registered master electrician. So what is highlight number 11? New provisions for foreigner practitioners authorized to practice in the country. More provisions for the practice of foreign professionals, especially for project consultants and or installers involved in technology transfers and in the mutual internationalization accords. Highlight number 12, new provisions for prohibitions relative to the practice of electrical engineering. Highlight number 13, new provisions for prohibitions relative to the practice of electrical engineering involving others. Highlights number 14, more substance in the licensure examination to ensure a pool of quality licensed electrical professionals. Note, the role of licensure examination is supposed to screen candidate professionals for quality output. Thus, the examination shall not only cover theories, but also technical applications of the profession. Reality is that whatever is the fabric of the board exams, the preparation of the schools and learning centers follows. In fact, the nature of the board exam will also trigger the change in the curriculum of more relevance. Note on the improvements on the qualifications of the would-be licensee professional. This way, it can help bridge the gap between the academe and the industry. This will also make the young engineers worthy of their licenses and be near to be internationally ready. Note also that the licensure examinations in this proposed new law had considered the effect of the K-12 program of the government. Examination and registration. Certificate of registrations for the practice of electrical engineering shall be of 3 grades or categories as follows: professional electrical engineer, registered electrical engineer, and registered master electrician. These are still the 3 categories or grades of licensing. So these are the for PE, the qualifications is under section 17A to 17G. The scope of exam is under sections 20AI to 20AV. For REE, section 18A to 18F are the qualifications. And the exam are on sections 20B1 to 20B5. For registered master electricians, section 19A to 19E, that's 5 the qualification. And for the scope of exam is 20C1 to 20C3II. Highlights number 15. Imposition of penal provisions to violators of this law, to include violations by the impostors of the profession. Some new substance of the proposed new law on penal provisions. Any person, whether private or public, Filipino or foreigner, who shall violate any of the provisions of this act shall be guilty of misdemeanor and shall upon conviction be sentenced to a fine of not less than 10,000. This is the old proposal, and the red fonts are the new proposal, 50,000, nor more than 50,000, or that is 500,000 already, or imprisonment of a period of not less than 3 years, nor more than 6 years, or both of the discretion at the discretion of the court. So these red fonts are our new proposals. Penalties for violation by persons in the roster of licensed electrical engineers of the Commission who shall violate any of the provisions of this act shall be guilty of misdemeanor and shall upon conviction be removed from the registry, his license revoked, and shall be sentenced to a fine of not less than 100,000 on the red font, nor more than 1 million, or imprisonment of a period of not less than 6 months, nor more than 6 years, or both at the discretion of the court. So mataas-taas na, 1 million na. Penalties for violation of sections 35, 36, 37, 38, 39, 40, 41, 42, and 43 by heads of government agencies or officers of private entities. Any head of government agency or officers of a private firm institution who violates these sections of this act shall be punished by a fine of not less than 100,000 to not more than 1 million, or both at the discretion of the court. These sections are the minimum personnel required. Gross, deliberate, and repetitive violations of this act or its rules and regulations by entities, government offices, or agencies, or private companies and establishments or operators, the Commission, through the Board of Electrical Engineering, shall impose a maximum fine of not more than 500,000 annually until such time that the act have been complied with. Further, that for purposes of the application of the fines, the BEE shall prepare a system of penalties based on the violator's ability to pay, degree of willfulness, and degree of negligence, history of non-compliance, and degree of recalcitrance. Provided further that in the case of negligence with mitigating circumstances, the first-time offender, to the discretion of the board, may be imposed a stern warning. May only be imposed a stern warning. So hindi natin pinasara yung isang company kung nag-violate siya of not hiring the minimum personnel required, but they are fined for 500,000 per year until such time that they can comply. What are the benefits expected to be derived from the proposed new electrical engineering law? Number one, it will generate more jobs and more meaningful opportunities amongst electrical practitioners. Number two, it will strengthen the assurance of public safety and industry and the preservation of lives and properties. Number three, it will enhance the quality of Filipino electrical practitioners to international standards. Number four, it will promote the culture of responsible practice, honesty, and accountability. Number five, it will address the gap between the academe and the industry and will produce better graduates for licensure examinations. Number six, it will create a pool of proficient and quality electrical engineering practitioners whose standards of practice shall be outstanding, honorable, and globally competitive. Number seven, it will promote the value of the profession that are responsive to continuing growth in competence. So how far we go? During the year 2010 to 2014, we have successfully filed the bill in both houses of the 16th Congress. House Bill 5826 being authored or sponsored by Honorable Edgardo Masungsong, Peter Onabia, and Rinaldo V. Umali. While at the Senate, it's Senate Bill 2963 being sponsored by Honorable Senator Paulo Benigno Aquino IV. But again, inabutan ng eleksyon, hindi lumusot yung dalawang bill natin. So where are we last 2016? That is from 2014 to 2018. The team again successfully refiled our bill to the proposed new electrical engineering law in both houses of the 17th Congress. It's evident na. So these are our filed bill, House Bill 1622, being sponsored by Honorable Congressman Eugene Michael De Vera. That was filed on July 18, 2016 during the 17th Congress. And Senate Bill 1127, again sponsored by Honorable Paulo Benigno Aquino IV, filed last September 16, 2016 during the 17th Congress. Again, hindi nag-prosper. Inabot ng eleksyon. So where are we now in 2020? With our continuing consultations and committee public hearings to the stakeholders, we have again submitted a consolidated substitute bill with the same title and content to both houses under the 18th Congress. This is now current, the 18th Congress. So our House Bill is 6314, sponsored by Congressman Honorable Julian Jam Baronda of Iloilo District, filed last February 18, 2020 during the 18th Congress. And Senate Bill 1210, sponsored by Senator Panfilo Ping Lacson, filed last September 27, 2019 during the 18th Congress. And mind you, Senator Lacson is now running for president. If somebody has contact with him, mas maganda kung ma-push natin ito. We say that we need a law that ensures the achievement of the fundamental intent of licensing professionals. Why do government impose licensing to individuals in the practice of a trade, a skill, or a profession? Drivers, pilots, watercraft officers, nurses, midwives, doctors, engineers, etc. Why are they licensed? When lives, properties, and public safety are at stake, resulting from the acts of an individual in the performance of his trade, we need a purposive licensing of responsible professionals who are allowed and permitted by law to perform as such. What is our target today? That our proposed bill shall become a law by 2022. So we need your help because these are already pending on the committee of Congressman Freddy Xiao sa Civil Service in the House of Congress. Then at the Senate, it is pending at the Committee of Civil Service again and Professional Reorganization, chaired by Senator Bong Revilla. So pending siya for the second reading and ultimately for the third reading before the bicameral of the two, then for the signature of the president. Hopefully before election comes, lalabas ito for third reading para maging law ito before May of 2022. We therefore pray for your support on this bill. We really need it. We are truly yours, Institute of Electrical Engineers of the Philippines Incorporated. May God bless us. Daghang salamat. Thank you very much, moderator. It's your turn now. I'm done.
Leo? Hello, Sir Leo?
Yes.
I am now turning over the floor to Sir Japet for the question and answer portion po.
Sige, sir.
Okay. Mr. Japet, how are you?
Okay na, sir.
How's Bacolod?
Kumusta?
Ayos lang. Still alive and kicking.
Yes. Sige, I think maraming gustong magtanong dito tungkol dito sa bagong proposed electrical engineering law.
Okay.
Actually, marami na dito nagtatanong sa group chat natin. One of the question is, Sir Leo, is it possible that the terms referring to LEPs be modified? Many times it's quite disappointing when a client comes to us, REEs, and seek for sign and seal, but we will say only PEs can do that, and the client asks, so what, are you not professional? Maybe it's just asking for clarification regarding this one kung sa mga REE siguro, sir.
Okay, actually, that's the law. Then we have some compromise. Once it will go to the the second reading, we have arranged some compromise together with the congressman of the power block, because they also wanted to have a compromise on that matter, but I could not divulge that right now until such time na we can have the second reading in the Congress or in the Senate.
Sige, there's another one question, sir. Yung repetitive penalty ng corporation or government agency dapat monthly, not yearly, kasi yung 500,000 daw kulang pa sa sahod. Anong masasabi mo dyan, sir? Their comment about that.
Di ba merong section doon na they are already penalized being the head of not hiring the minimum personnel required, plus the corporation in itself, yun ang annual. Pero yung mismong heads, meron tayong penalty or imprisonment na nandun sa proposed law natin. So I think kung tutuusin natin, dahil pinalize natin yung mga heads of offices, whether government or private, siguro hindi na aabot ng yung company pa ang i-penalize.
Okay. Parang tatlo lang yata ang nag-question dito sa group question and answer natin. I think tingnan natin dito sa chat group kung meron. Wala rin naman, Sir Leo. Pero yung tanong ko, sir, maybe ako na lang magtatanong in behalf of them. Yung nasama ba diyan sa in our proposed new electrical engineering law yung dapat ng compliance ng mga LGU when comes that yung mga LGU ba na walang mga electrical engineers sa kanilang mismo sa LGU?
Sa law na ito, if this will be enacted, all LGUs are mandated to hire.
Tama yun.
Nandito yun sa law natin. Again, kahit gobyerno sila, they can be penalized under this law kung hindi sila mag-hire.
Kasi maraming mga LGU walang electrical engineer. They just base their inspection on the civil engineer na meron sila doon. Hindi naman
Yes.
natin makabaro yun.
Tsaka meron tayong provision dito ng sinabing certified plants examiner and certified inspector. So, itong dalawang ito are electrical practitioners, be it an RME or RE or PEE, who will be employed sa mga LGUs para titingin doon sa mga installations. So si Certified Plants Examiner, nasa opisina, siya yung nag-examine ng mga electrical plants. Then si Inspector, yun ang pupunta sa mga construction sites para titignan muna bago magbubuhos yung concrete kung tama ba yung mga layout ng mga electrical systems within a building. Yun ang mga trabaho nila. And these people or these practitioners will be certified by the PRBA also, that they are certified plants examiner and certified plants inspector. No, certified inspector, not plants.
Sige. Sir, dito sa chat box may coming from Engineer Danny Dave Fabiania. What is now the status of new RA 7920 Section 33 in terms of extend in the enforcing and implementation? Enforce. Section 33 daw, sir.
Sa RA 7920, I hope may nakarinig kanina doon sa isang resource person who is explaining on Section 33 of RA 7920. Merong mga inspection doon na sinabi niya at saka merong doon sa mga employment. Pero this lecture of me right now is focused on the proposed law. So magiging kung papasa ito as a law, then magiging irrelevant na yung RA 7920.
Supersedes na.
Amended na.
Sir, ito interesting tanong. Sabi niya, ano daw ba yung starting salary ng, saan ba to? Nakikita ko dito kanina, sa chat pala to, sa chat. Ano daw yung starting salary ng ng REE?
Depende pa rin yun sa company. Depende sa company.
Ano po yung starting salary grade na i-hire ng electrical engineer sa isang LGU na walang REE? It comes from Christopher Ordonez of IEE Mactan.
For the LGU, meron silang mga di ba? May
salary
mga
grade naman yan.
Salary grade. So, yun, di ko alam kung ano yung mga salary grades na especially na meron silang salary standardization. So I am not privy on the value ng
meron din dito si Sir
grades.
Ferdinand Zomar, yung tanong niya LGU rin eh. Kanina na we have already answered that one. Ito sir from Rodel Luis, who will certify you as certified electrical inspector and plant examiner? Yung kanina you mentioned that one, sir.
Yeah, I have said that for those who will be planning to become a certified plants examiner or inspector, they will undergo a certain training, then be certified by the PRBEE. So meron talaga siyang isang card, isang ID na certified plants examiner siya. So that's coming from the PRC.
Yes,
Bale.
PRC. Ito sir, another question from Ramil Kapangpangan. Sir, so in our present setup, we have no RME in our substation. Siguro nasa electric utility ito. or maybe in transmission. So we will be hiring more RMEs if this is approved. Yung proposed na law, sir, if once approved, of course, they will be, so mag-hire ba sila ng additional RMEs? Yan yung tanong niya.
Yes, correct. Correct. Because as I have kanina pinakita ko, for any capacity of a substation, merong equivalent number of RMEs, REEs per shift. So mandatory yon pag na-approve itong law na to. Kumbaga may ngipin itong law na ito kung ma-approve lang.
Tama. Ito may tanong si Sir Claro Kisel. Actually, sa kanila daw, in our agency, we, the REE, are directed to sign the plan so that the project can be funded. Is there any violation on this? Depende. May violation ba daw, sir? Kung may project sila and before it will be funded, dapat mag-sign yung REE na employee ng company nila.
Okay lang naman yun kasi that is for presentation pa sa kwan . So hindi pa naman yun isasubmit sa LGU for implementation. So for budget
violation dyan, pag
presentation,
nag-sync ka na hindi ka PEA, di ba?
For budget presentation lang yun.
Yes,
So walang violation yun within the company.
Ito, sir. Good day, sir. Tanong ko lang po, sana kung kasama po dito sa new law na ito, yung new requirements for the PE upgrade requirements. Previously, it was only 4 years after REE registration. However, ngayon po ay 10 years na po. Salamat po.
Meron tayo. If you can read the law na proposed, may 5 years na experience from being a registered electrical engineer. 5 years experience. Hindi
5
yung
years, okay.
pumasa ka, wala ka namang experience, tapos kukuha ka na ng malaking problema yun. Pero yung 10 years kasi na sinabi dito is the requirement galing ng BEE kasi they wanted to match doon sa internationalization accords na dapat may 10 years experience ka para kumakuha mo yung level 6 ba yun sa mga internationalization accords.
Oo. Sige, sir, siguro ito ng last question natin kasi mayroon tayong closing ceremony, di ba? BEE ba mag-file ng kaso sa violation sa LGU at corporations? Yung
No.
Board of Electrical Engineers ba?
No. Tayo yun.
As
concerned individuals, tayo yun as a chapter or as yung personal mo. Ang BEE are the sila yung mga kumbaga kwasay sila . And they will be the one to implement penalties. So hindi sila yung
penalties.
Hindi sila yung
Revoke
magpo-complain.
your license kung napatunayan na may violation ka. Yun yung gagawin ni BEE through PRC.
Yeah. Pero of course, it will undergo
trial,
a process.
Yes. So with that, Sir Leo, thank you very much. I think that's all. We have already answered those questions, and then if you still have question, you can send email to Sir Leo or
through the
our
secretariat.
Kung meron pa kayong mga tanong tungkol doon sa proposed na new electrical engineering law. Matagal na yan, so I hope na maano natin yan, mapasa na in this coming Congress. Diba, Sir Leo? Any last words, Sir Leo?
Okay, ang hingi lang namin sa committee because we have been working with this for so many years already na whoever are with close contacts to these politicos.
Yeah.
Hopefully, you can help us endorse this law para magka-second reading, then we will have a compromise during the second reading. Then yung pag lumusot kasi sa second reading, parang ano na lang yung third reading.
Oo, tama.
Oh, yung second reading yung madugo. We have done already the first reading. Kaya nagka-number na yan and it's being endorsed to the Professional Service Civil Service Committee of both houses. Hopefully, kasi nahirapan din talaga yung mga congressman and senator because of this is a highly technical
Tama.
law.
Kailangan electrical engineer ka.
So, nahirapan silang umintindi ng mga kaya we were asking them na kung they need our assistance para ma-enlighten sila, then we are willing also.
Yeah.
So that's it. And thank you very much sa lahat.
Thank you very much, Sir Leo Kabasag, for that inspiring presentation.
Okay.
Ma'am Yela? Can we post the certificate of appreciation for Sir Leo? Ma'am Lea, ikaw na lang magbasa kasi ay mobile ako, hindi ko makita.
Yes, sir. Okay, sir, to award the certificate of appreciation to our resource speaker, let me read the citation. The Institute of Integrated Electrical Engineers of the Philippines Incorporated awards the certificate of appreciation to Engineer Leo S. Cabasag for imparting valuable insights as a resource speaker on the topic updates on the proposed EE law during the simultaneous technical sessions in conjunction with the 46th Virtual Annual National Convention with the theme Got One IIE at 46, Transcending the Challenges in the New Normal by Embracing Resiliency and Complementarity, held on November 22 to 27, 2021 in Manila via Zoom conference video, given this 27th day of November 2021. Signed, Engineer Alberto Herrera, National Secretary. Signed, Engineer Roland P. Vasquez, National Vice President for External Affairs and Exhibit Bureau Director. Signed, Engineer Lyndon R. Bague, the Vice President for Internal Affairs and the Convention Bureau Director. And of course, our National President, Engineer Alan Anthony Alvarez. Sir Leo, for a photo op in a count of 3. 1, 2, 3. Again, thank you very much, Sir Leo, for
Thank you very much, sir. Thank you very much. Regards.
Okay, so it's a wrap, everyone. Thank you for staying with us. So it is the end of our technical sessions. Thank you for being connected for 2 days. We truly appreciate your presence today. Without you, this event won't be a success. See you all next annual National Convention. God bless us all.
Wala pa rin. Saan magre-restart ko?
The nation around the
Walang marinig. Walang audio.
Yes, also the
Technical yes.
Sayang, di marinig.
Audio please, audio.
Marvin, walang audio.
Wala namang sound.
Wala pong audio. Wala pong audio.
Walang audio, wala.
Miss Ann, Sir Woody, wala kaming audio dito. Ma'am Ann, tech team. Thanks, Sheila.
The election is 9,768 votes. This year, a total of 11,120 members cast their votes. And the ELCOM decided to award chapters and regions who garnered the highest percentage in casting their votes. So, there are two chapters who made 100% in casting their votes. And these two chapters are Agusan del Sur chapter, 100% of the members voted, although there are only few of them. Soxardin also recorded 100% votes cast with 91 members, 91 members. 91 members, 100% voted. We also would like to cite the second best chapter, White chapter, which has a 77.27% voting members. For the best region in terms of voting, it's for the second time around, it's foreign region with 35.9%. And we'd like to cite the second best region in terms of percentage, Western Mindanao with 28.2%. With most number of votes is Soxardin with 91 members voted 100%. Mahirap talunin yung Soxardin. The national percentage is only 21%. Marvin, take it away.
Thank you very much, Engineer Escalante, and to the rest of the electorals. Congratulations also to the new set of IIE Board of Governors and the cited chapters. We are very lucky today to have with us our guest of honor, a fulfilled man in uniform to provide us some inspiration. May we call on Engineer Alberto R. Herrera Jr., the current IIE National Secretary, to introduce to us our guest.
It is an honor and privilege to introduce to you an ideal public servant who, in his own way, unassuming ways, have proven his worth many times over as a true enforcer of law, a champion of justice, and above all, a model of integrity, courage, and accountability. A pure-blooded Ilocano from Bayumbong, Nueva Vizcaya, is a proud member of PMA Sambisig class of 1991. His impressive service reputation, coupled with understanding educational achievement, sincere heart to serve, contributed vastly in the achievements of the PNP organization in general. He spent his police career in Davao region for more than 20 years, holding key positions as a commander to the different stations. As the battalion commander of the Regional Mobile Force Battalion 11, he spearheaded the crackdown of CPP, NPA, NDF in southern Mindanao, wherein the unit was awarded as the best mobile force battalion. He was the city director of Davao from 2013 to 2016, when the city was adjudged as one of the safest cities worldwide in the year 2014, with then Mayor Rodrigo Duterte as its chief executive, who is now our president. Accepting more challenges in his police service career, he then showed exemplary performance while being the chief directorial staff and at the same time the deputy director for operations of CIDG, which gave the unit the recognition as the best national operational support unit for the calendar year 2017 to 2018. It was during his stint as the Manila Police District Director in 2019 when the city of Manila was known as the 43rd safest city worldwide. Our distinguished guest introduced the new era of change in Police Regional Office Calabarzon, in which he challenged and encouraged every personnel to set a good wherein the unit was awarded as the best mobile force battalion. I am privileged to introduce our speaker, Police Major General Vicente D. Danao Jr., Regional Director, NCRPO.
The great architect of the universe, wisdom and strength, the members and officers, national and regional officers of the Institute of Integrated Electrical Engineers, led by its president, Honorable Alan Anthony P. Alvarez, to the members of the regional governors, our distinguished guests, exhibitors, sponsors, isang mapagpalang araw po sa inyo lahat. Imagine a world, a nation or a city like the National Capital Region, where the seat of power and the seat of government lies. Without an electricity, without light, and all under the cover of darkness. What do you think our situation will be? Amidst the pandemic that we have now, definitely there will be that chaos, criminality, illegal drugs, and terrorism might be everywhere. Given their Herculean task of being law enforcers, definitely the PNP will have the difficulty of maintaining the peace and order of this city without the convenience of light and electricity within our area of responsibility. And for this, I am very grateful to speak before our electrical practitioners, our delegates, sponsors, and exhibitors, who has been our partners in our crime prevention for making this momentous occasion possible. Your mere presence in this convention shows your diligence in taking greater responsibilities amidst the global challenges that we are facing. Indeed, your share in the advancement of technology from simple lights, stoplights, power generation, navigation system, communication system, cyberspace, DNA tests, lab tests, drug tests, and the like would be that easy with you as our partners on the ground. Your contribution as electrical practitioners to maintain all this equipment running 24/7 has manifested a big help in maintaining the tranquility of our country. Having the same role, our coexistence in crime prevention makes IIEE and the PNP as perfect partners, for we have one common goal: to be of true service to God, to our country, and to our people. It is my fervent hope and prayer that we will rise above all and be of great service for the Filipino people. Let us all stay safe and healthy and be prepared to the challenges of the new normal. My warmest congratulations to IIEE for this successful convention and exposition of 46 years of a strong IIEE. Kami po ay nakikisa ang buong pambansang pulisya sa pagbibigay pugay po sa inyong lahat, lalong-lalo na sa mga minamahal nating electrical practitioners, mga kapulisan, mga opisyales ng inyong organisasyon, sa inyong walang sawang servisyo at pagpapakita ng tunay na paglilingkod para sa ating inang bayan. Mabuhay po ang IIEE, mabuhay ang Philippine National Police, mabuhay ang sambayan ng Pilipino.
That is a truly inspiring message, General. We are very grateful. So as our token of appreciation, we would like to request our National President, Engineer Alan Anthony Alvarez, to present to our guests our plaque of appreciation. So this certificate of appreciation is presented to Police Major General Vicente D. Danao Jr. For imparting valuable insights as guest speaker during the 46th Virtual Annual National Convention and 3E Expo with the theme Got One IAE at 46, Transcending the Challenges of the New Normal by Embracing Resiliency and Complementarity, held on November 22 to 27, 2021. Thank you very much, Engineer Alvarez. Now, may we again call on the Chairman of the Elections Committee, Engineer Arthur N. Escalante, to administer the induction and oath-taking of our 2022 Board of Governors. Engineer Escalante. So, sorry about that. It's Engineer Peñalosa to administer the oath-taking and induction of the 2022 Board of Governors.
For our chairman of the Elections Committee, I was advised to represent him and induct the incoming officers of the organization. So may we call on the officers present tonight to please occupy the front space. Yes, from the President, VP Internal, VP External, VP Technical, Secretary, Treasurer, and Auditor, if present, and all the other governors present as well. For all officers at the virtual places, can you please show your videos? Can we request our audio and video technicians to please show the videos of our new officers and governors? Do we have them? Is it okay? Are all of them present? Okay. If all of them are present, even individual officers and governors, please raise your right hand and repeat after me. I state your name.
I, Woody Irama,
After having been elected,
after having been elected
state your position
to the position of Regional Governor
of the Institute of Integrated Electrical Engineers of the Philippines Incorporated,
of the Institute of Integrated Electrical Engineers of the Philippines
for the
Incorporated
year
for the year
State the year.
2022.
For the year 2022,
do hereby solemnly swear
Do hereby solemnly swear
that I will faithfully do
that I
will faithfully do
and discharge
and discharge
and discharge
to the best of my ability
to the
to
best
the best of my ability
the duties and responsibilities
the duties and responsibilities
incumbent upon this office.
incumbent upon this office. That I will abide
By the articles of incorporation
by the Articles of Incorporation
and bylaws of the Institute.
and bylaws
and bylaws of the Institute.
That I will abide
That I will abide
the code of ethics
by the Code of Ethics
and the
Manual for Professional Practice.
that I will do my duty
that I
That I
will
will do my duty
towards God,
towards
God,
country,
my country
and my fellow men. And lastly,
and lastly,
that I impose upon myself
that I
I
impose
impose upon myself
the aforementioned duties
the aforementioned duties
and responsibilities
and
responsibilities and obligations voluntarily
and without reservation
without
or purpose of evasion.
of
So help me God. Congratulations to all.
so help me God.
Thank you very much, Engineer Peñalosa. And congratulations to the 2022 Board of Governors, hoping for a successful year ahead. Now, may we request, before you sit down, sir, may we request the incoming 2022 National President for his acceptance speech.
Good afternoon to everyone. First of all, I would like to say thank you to all the members who participated in this successful exercise. So we are really improving in number in terms of number and members who participated in this election. I would like to recognize our ELECOM, the canvassers, headed by our former National President, Sir Art Escalante. Congratulations, sir, for a very successful election. And then I would like to congratulate those who made it to the 2022 Board of Governors. I hope that we can work together as a team, looking at the long-term success of our organization. I was a member of the EXCOM as a National Treasurer last year, and this 2021, I was your National Vice President for Technical Affairs. I want to continue serving the membership, our organization, in my full capacity in the coming years to fulfill our long-term economic, moral, legal, and social obligations. I'm still on the state of shock because I don't believe it came very fast actually. So that in 3 years as your EXCOM, I will be your national president for the year 2022. So what can I say? I accept the challenge. Thank you to all of you for giving me the trust and confidence to serve the organization as your national president on this very challenging time. I hope that we could be of service to the memberships and hopefully we could work together as a team in the help of our Board of Electrical Engineering, Honorable Francis P. Mapile, Member Jaime Mendoza, and our COPNAP, who will be guiding us, mentoring us, advising us in the right direction. My battle cry is that during my stay as EXCOM is good governance and transparency, and I always live with that. Looking at the best interests of the organization in its members and my own personal interests. Actually, not everyone is given the opportunity to lead and serve, so this is it. I would like to encourage everyone to unite and let's overcome the challenges through dedicated service and excellence. Looking forward for a very successful 2022. Let us keep the light in all of us. Mabuhay ang IIE. Mabuhay po tayong lahat. Maraming salamat po.
Thank you very much and congratulations to our incoming 2022 National President, Engineer Feliciano F. Padua III. Since our new Board of Governors have already been inducted, I think it is fitting to administer the induction and oath-taking of the 2022 chapter officers who are here today joining us in the event. May we request Engineer Alvarez to administer the oath of office for the chapter officers. To every chapter officer here today, may we request to turn on your video cameras as Engineer Alvarez administers the induction ceremony.
Good afternoon. So before we go on the induction of our chapter officers 2022, may I call our former national president and former chairman of COFNAP, Manny Diaz, to do the charging for our new sets of officers. Mr. Manny.
May I request all the officers to please come forward, all officers to be inducted. Meron ba? Meron. All officers. All officers to be inducted, please come forward. Also on the beat pal, be sure your video or isa lang.
Join na rin kayo.
All officers, chapter officers, newly elected. Kanina pa ako nagtatawag eh. Mukhang kailangan Tagalogin o yung mga halal na pamunuan ng IIE na chapter. Sige. Okay, sige. Okay. So, kompleto na ba? So, yata Tagalog eh, no? Ayaw ng English. Wala na? Okay, yung sa virtual, nandiyan na ba? Pwede ba yung mga nandito because of the solemnity of the occasion, please, lahat po kayo nandiyan? Yan. So, tuloy na tayo. Maganda Tagalogin yata eh, para maintindihan. Anyway, charging of officer, hindi po ito katulad na inyong mobile phone pag naubos na yung baterya. Ano po? At the same time, hindi po yung call ng referee pag nagbabasketball kayo ang tawag charging. Yan. Charging of officer to formalize your installation of incoming officer. You are charged with the responsibility for proper functioning of all the committees, activities, projects, and the likes. You were elected or chosen by your constituent or your member because you have three qualities, because you have the talent, you have the treasure, and of course you have the time. I would like to make a quote from the famous quotation of John F. Kennedy. Ang sabi niya, ask not what you can do for your country, but what you can do for your ask not what you can do for you, but what you can do for your country. Sa Tagalog, ano ba ang magagawa niyo sa IIE? Hindi yung ano mapapala niyo. Dapat ganon. Kadalasan tinatanong natin, ano ba mapapala ko sa IIE? Moreover, you must be familiar with the Robert's Rule of Order. No? At the same time, you have to read and familiarize yourself with our Constitution and bylaws, and also our policy manual. With that, do you accept the charge? Ayaw sumagot. Tinatanggap niyo bang mangmuno kayo? Ay. Yon. Mr. Inducting Officer, they are now ready to be inducted. Salamat po.
Okay, so everyone, Please raise your right hand and repeat after me. I state your name. After having been elected to the position of, state your position.
VP External Affairs.
Of the Institute of Integrated Electrical Engineers of the Philippines, Inc. State your chapter.
Iloilo chapter.
For the year 2022, do hereby solemnly swear that I will faithfully do and discharge to the best of my ability the duties and responsibility incumbent upon this office. That I will abide by the Article of Incorporation and bylaws of the Institute.
I will abide with the bylaws.
I will abide by the Code of Ethics and the Manual for Professional Practice. That I will do my duties towards God, my country, and my fellow men. And lastly, that I impose upon myself the aforementioned duties and obligations voluntarily and without reservation or purpose of evasion. So help me God. Congratulations, everyone.
So thank you, Engineer Alvarez. And to the virtual 2022 chapter officers and the ones who are here, you have now officially been inducted and has taken your oath of office. Congratulations. So after the mass oath taking of all the 2022 chapter officers, let us call on the chairman of the College of Fellows, Engineer Fortunato C. Lines, to confer the new members who will be welcomed to the elite group of IIEE College of Fellows. Engineer Lines.
Thank you. Good evening, everyone. So I would just like to mention the criteria, the minimum criteria for an IEE member to be elevated to the College of Fellows. First, he must be either a professional electrical engineer or a holder of a PhD or MS degree in electrical engineering, or a Master of Engineering, major in electrical engineering, or allied fields with at least a registered electrical engineer's license. The nominee also must be an active IIEE senior member at the time of his nomination and must have been active in any professional practice for 20 years or more years, and shall have shown significant performance over a period of not less than 10 years. In addition, the nominee shall have achieved demonstrable eminence in any field of electrical engineering in the following sectors: the academe, private practice, industry, government agencies, corporation, consultancy, or electrical contracting, and research and development. The achievements may be evidenced by any of the following: publication of technical papers or books in electrical engineering or related scientific fields, invention, having a relation to electrical engineering and supported by patents or equivalent evidence, technical direction or management of important electrical engineering work or scientific work related to electrical engineering with evidence of accomplishments, recognized contributions to one or more fields of electrical engineering, recognized contributions to the development and furtherance of electrical engineering education, recognized contributions to the welfare of the scientific or electrical engineering profession. So those will be the criteria for a senior member to be awarded as or to be upgraded to the College of Fellows. And for this year, we have 3 senior members who will be elevated to the College of Fellows. So can you please, so these are Dr. Angel De Vera, Jr., Engineer Ferdinand P. Villarreal, and Engineer Marites R. Pangilinan. So can we have the citation for the plaque of appreciation to be, or for the plaque to be presented to the College of, to the fellows, new fellows of the Institute of Integrated Electrical Engineers.
As we award the trophy, may we call on Engineer Alan Anthony Alvarez. And allow me to read the citation for the plaque of conferment to the new members of the College of Fellow. Institute of Integrated Electrical Engineers of the Philippines, INC, hereby confers the grade of Fellow to Angel V. De Vera Jr., to Marites R. Pangilinan, and to Ferdinand P. Villarreal for her remarkable accomplishment as an electrical engineer and distinguished dedication to the Institute of Integrated Electrical Engineers of the Philippines, INC, and for his countless efforts devoted to the benefits of his fellow electrical engineers and the electrical engineering profession in general. Given this 27th day of November 2021 during the 46th IIEE Annual National Convention at the PAMAV Training Institute and Technology Center, Diliman, Quezon City, Metro Manila, Philippines. Ladies and gentlemen, let us give them a virtual round of applause. Once again, let me read the citation for the certificate of conferment. First, the Institute of Integrated Electrical Engineers of the Philippines, INC, hereby confers the grade of Fellow to Angel V. De Vera, Jr. Next, the Institute of Integrated Electrical Engineers of the Philippines, INC, hereby confers the grade of Fellow to Marites R. Pangilinan. And next, the Institute of Integrated Electrical Engineers of the Philippines, INC, hereby confers this grade of Fellow to Ferdinand P. Villarreal. Once again, given this 27th day of November 2021 during the 46th IIEE Annual National Convention at the PAM of Training Institute and Technology Center, Diliman, Quezon City, Metro Manila, Philippines. Let us all give them a round of applause. And now let's move on to the glitz and glamour as we present the awards and recognition to outstanding practitioners in the field, the different chapters who excelled and performed above and beyond despite the challenges we are facing. May we call on Engineer Vic Abejero, Vice Chairman of the Selection and Awards Committee.
Yes. Good evening, Philippines and Singapore. Good evening also to our members in Brunei. Magandang hapon po sa mga taga rito sa Middle East, and good morning to our members in Cayman Island. I'm speaking actually on behalf of our chairman, Engineer Samuel Julio, who is unable to attend this ceremony. That on behalf of the Selection and Awards Committee, whose members are the following: former Regional Governor Sam Julio as our chairman, former National President Joby Panhilason as our advisor, and to the members, former Regional Governor Francis Calaño, former Regional Governor Marlon Parrot, former Regional Governor Ronaldo Brada, former Regional Governor Wilson Faria, former Regional Governor Victorino Abejero, and former Regional Governor Noel Leia. We would like to extend our warmest congratulations to those who tried their best to participate in the different categories of this yearly activity. We thank the different members who were nominated and participated in the most outstanding electrical engineers of the year, and to those who participated in the most outstanding chapter in the Chapter Excellence Award. For this year, there are 2 outstanding engineer awardees, 13 chapter awardees of different categories, platinum, gold, silver, and bronze, 2 most outstanding chapter awardees, 1 Hall of Famer awardee, and by the way, a Hall of Famer awardee can be granted to a chapter after getting a most outstanding chapter award for 3 consecutive years. This IIE's way actually of recognizing excellence amongst its members and even chapters in providing excellent services to their constituents, even during these difficult times. That even during these difficult times, there are different chapters who were able to improve their targets, increase their memberships, provided community services, and never wavered in committing and providing unselfish service to their members. With this, my warm congratulations to the awardees, and it is my hope that there will be more participants next year. Mabuhay ang IIEE, and God bless us all. Maraming salamat po, and back to you, Mr. and Ms. Master of Ceremonies.
Thank you very much, Engineer Abejero. Now let us read the citation for our certificates for the awards of the most outstanding electrical engineers. First, the Institute of Integrated Electrical Engineers of the Philippines Incorporated proudly presents this award for the 2021 Most Outstanding Electrical Engineer in the field of consultancy to Engineer Edgar B. Bernardo. Let me call on the representative to please accept the award here in front. And to award the certificate, Engineer Alan Anthony Alvarez. Given this 27th day of November 2021 during the 46th IIEE Annual National Convention at the PAMAW Training Institute and Technology Center, Diliman, Quezon City, Metro Manila, Philippines. Let us give them a round of applause. For the next award, the Institute of Integrated Electrical Engineers of the Philippines Incorporated proudly presents this award, the most outstanding electrical engineer in the field of project management, to Engineer Marlon L. Manantan. And now for the awarding for the chapters. First, the Institute of Integrated Electrical Engineers of the Philippines Incorporated presents the Certificate of Participation to Iloilo. To the officers present, may you please open your camera. Moving forward, the Institute of Integrated Electrical Engineers of the Philippines Incorporated presents this Chapter Excellence Award, Bronze to Metro Central Chapter, to Davao Chapter, the Kuwait Chapter, and to Eastern Region Chapter, Saudi Arabia. The Metro Central is present here at the venue, so may we call you on stage, sir, to receive your award. And also we have Engineer Alan Anthony Alvarez to give the trophy to Metro Central Chapter. Congratulations to our bronze awardees. And now the Institute of Integrated Electrical Engineers of the Philippines Incorporated presents this Chapter Excellence Award, Silver, to Metro West, Central Region Chapter, Saudi Arabia, and Cagayan de Oro. The Metro West chapter also has representative here at the venue. Congratulations to our silver awardees. And now the Institute of Integrated Electrical Engineers of the Philippines Incorporated presents this Chapter Excellence Award Gold to Northern Laguna. Please come on stage, sir. Congratulations, and the Institute of Integrated Electrical Engineers of the Philippines Incorporated presents this Chapter Excellence Award Gold to Southern Cavite. Congratulations to our gold awardees. The Institute of Integrated Electrical Engineers of the Philippines Incorporated presents this Most Outstanding Chapter in Local category and Chapter Excellence Award Platinum to Northern Cavite. The Institute of Integration. Congratulations! The Institute of Integrated Electrical Engineers of the Philippines Incorporated presents this most outstanding chapter in foreign category and Chapter Excellence Award Platinum to United Arab Emirates. The Institute of Integrated Electrical Engineers of the Philippines Incorporated awards this Hall of Fame to State of Qatar chapter for the unselfish commitment and tireless cooperation to the Institute. Your contribution towards the betterment of our organization is greatly appreciated. Thank you for your continued efforts and dedication to the chapter's members, to the community, and for the support of the IIE team, Got1 IIE at 46, transcending the challenges in the new normal by embracing resiliency and complementarity.
Congratulations to all of our winners, the chapters, and the professionals. Earlier, we had chapters who were proactively creating activities, benefits the chapters members. Now, we'll announce the winners for the chapters who helped their communities through the Upland Daguitab project. Let us call on Engineer Vincent Lago, the Vice Chairman of the Upland Daguitab Committee, to announce the winners. Engineer Vince.
Yes, good evening to everyone. In behalf of our committee chairman, Engineer Alex C. Cabugao, for this year, Electrical Engineers of the Philippines Incorporated proudly presents this recognition to the chapters awarded, given this 27th day of November 2021 during the 46th I
So, excuse me everyone, I think nawala sa signal yung ating Vice Chairman ng Oakland Dagitab. So while waiting for him to come back, let us now move on to the next item. So, throughout the year, our regional governors were busy making sure to conduct a successful conference in the respective regions. And to recognize these efforts, we request our National Auditor, Engineer Eusebio A. Gonzalez, to award the region with the best conference.
Good evening. For those, hello. Hello. Yeah. Good evening po sa lahat ng IIE members na nandito, sa lahat ng 11,000 na mahigit na bumoto. Congratulations po sa ating mga ELECOM committee na nag-conduct ng e-voting natin ngayon. Salamat po ng marami sa inyo at ako po ay naatasan as National Auditor to present the best regional conference who conducted the conferences this pandemic era na dinadanas natin ngayong panahon na to. Sana po ay maka-recover na tayo at sa next year ay pero kahit na po mag-hybrid tayo, sana po mag-face-to-face na rin po tayo sa mga conferences natin at sa mid-year at annual national convention. To those who stayed, I'd like to inform that as chairman of the Best Regional Conference Committee, which was selected by our ExCom, our exhibitors, our delegates, and especially their submission of the FS for those chapters that participated in our regional conferences. All 11 chapters conducted their conferences. Some are hybrids and some are purely virtual. For those hybrid po na nag-conduct ng we prepared a special prize for them, and for the third placer for the hybrid conference, we give the certificate of participation as a hybrid conference host to Northern Cavite chapter. I'll call on the governor, Jeff Anhuco, and our president to award. For the trophy po, habol na lang po sa December 11 turnover, saka congratulations po sa Northern Cavite. Platinum awarded na. Third place pa sa hybrid. Talagang iba kasi po Northern Cavite. continue for our second hybrid awardee. I would like to give the award to Pangasinan Chapter, CLC, Central Luzon, to Governor Woody Irama. Nasa virtual po yata siya. Press, nasa virtual. So, we will give the certificate to you. Virtual din muna yung certificate. And for the winner of the Best Hybrid Conference, we'd like to give the award to our foreign region, to Governor Orlando Villapaña. Congratulations po, Go for Bill. Job well done po. Andiyan po ba kayo? Abu Dhabi chapter po ang nag-host. Siya na po yung bibigyan natin ng award. So, for the main event, ito na po yung pinakihintay ng lahat. Amazing the cumulative grade of 82.35. Konti lang po lamang nito. Anong to? Fraction of fraction lang po ang lamang. So doon sa second, saka sa third. Dikit-dikit po to actually. Napakahirap po pero alam ko sa financials, sa FS po, saka sa XCOM, medyo doon po lumamang ng konti. So, I'm very proud to announce that the Best Regional Conference for 2022 hosted by Metro West, Metro Manila Region Best Region Conference. Congratulations, Metro Manila. Salamat po. Congratulations, Gov Alwin Wagan.
Congratulations to our winners.
2021 po yun Metro Manila Region Best Regional Conference.
Okay, congratulations. And now let us call on once again Engineer Vincent Pelago, the Vice Chairman of the Upland Daguitab Committee, to announce the winners.
Thank you po. To continue po to read the citation. Institute of Integrated Electrical Engineers of the Philippines Incorporated proudly presents this recognition to the following chapters, given this 27th day of November 2021 during the 46th IEE Annual National Convention at the PAMAB Training Institute and Technology Center Incorporated, 68 Kalayaan Avenue, Diliman, Quezon City, Metro Manila, Philippines. Signed, Alex C. Cabugao, Chairman of Landagitab Committee. Signed, Alberto R. Herrera Jr., National Secretary. Signed, Alan Anthony P. Alvarez, National President. And for the 2021 Best of Landagitab project goes to Southern Cavite Chapter. And for the 2021 Best Bigay Liwanag project goes to Southern Cavite Chapter. For 2021 Best Bigay Liwanag First Runner-Up, Northern Laguna Chapter. And for 2021 Bigay Liwanag Second Runner-Up, Cagayan de Oro Chapter. And for 2021 Bigay Liwanag Runner-Up, State of Qatar Chapter. Another runner-up for Bigay Liwanag, Iloilo Chapter. for 2021 Best Brigada Eskwela Project goes to Southern Cavite Chapter. Tuwing 2021 Brigada Eskwela First Runner-Up, Cagayan de Oro Chapter. Tuwing 2021 Brigada Eskwela Second Runner-Up, Iloilo Chapter. Tuwing 2021 Brigada Eskwela Runner-Up, Northern Laguna Chapter. Lack of recognition for Oplan Dagita Balik Liwanag, Southern Cavite Chapter. Another plaque of recognition for Oplan Dagita Balik Liwanag, Cagayan de Oro Chapter. The following chapters will receive the plaque of appreciation in support of Oplan Dagita projects of IEE. First is Northern Cavite Chapter. Plaque of appreciation to East Laguna Chapter. Plaque of appreciation given to United Arab Emirates Chapter. plaque of appreciation given to Batangas chapter. Another plaque of appreciation given to Metro Central chapter. And another appreciation given to Catanduanes chapter. So that's all for the Oplan Dagitabs awarding for 2021. Again, we thank everyone, all the chapters, in your valuable support to the committee. Looking forward to the next years in this endeavor. Thank you po.
Thank you very much, Engineer Pelago, and congratulations to the awardees of the Upland Dagitab. Hand in hand with the convention, in the event hub platform, we have virtual exhibitors showing and sharing their products and services. During this time, the exhibit bureau evaluated these virtual booths. And to award the best virtual exhibit booth, we have Engineer Roland P. Vasquez, our Vice President for External Affairs and the Director of the Exhibit Bureau.